it's your favorite NPC, and today I will turn you from a JavaScript beginner to a JavaScript pro. The job market is splitting right now. On one side, developers who understand JavaScript fundamentally, who can read AI code and spot bugs immediately, and who can direct AI to solve real problems. On the other side, developers who just prompt and hope. You know something is shifting. You see developers using AI. You are using AI, but you can feel the gap. You don't understand deeply enough to really control it. You can't evaluate what AI gives you. You're just hoping it works. This course teaches you the JavaScript knowledge to stay competitive in today's world. And here's how we are going to build that understanding. We start with the fundamentals, how JavaScript executes, what variables are, and how types work. Then we cover functions, loops, and if statements. Afterwards, we go over control flow, objects, classes, and how they all connect. Then we understand the browser, so the DOM, events, async, await, and a lot more. By the end, you won't just write code. You will understand the code deeply. Most courses teach syntax. This course teaches you how JavaScript actually works underneath, so you can evaluate any code, whether you wrote it, AI wrote it, or a senior developer wrote it. And if that sounds good to you, then let's get started, guys. JavaScript is a programming language that adds functionality and interactivity to websites. It was created in 1995 by Brendan Eich to solve a key problem, making web pages dynamic instead of static. HTML defines the structure of a website, and CSS controls how it looks. But without JavaScript, everything stays static. JavaScript lets you respond to user actions and control what happens on a page. For example, when a user clicks a button and something happens instantly without reloading the page, that's JavaScript. It can update text, show or hide elements, or load new content in real time. Instead of reloading the entire page, JavaScript can update parts of it instantly, making websites faster and more interactive. It also powers things like animations, forms, APIs, and full applications. Today, JavaScript is used in almost every website. It's not limited to websites either. You can use it to build games, apps, and even run code on servers. You should learn JavaScript because it gives you control over how a website behaves and is essential for building modern, interactive applications. Let's get started by understanding the absolute basics of JavaScript. JavaScript works together with HTML and CSS and allows us to add interactivity to a website. So ideally, you're able to code a little bit in HTML and a little bit in CSS before you learn JavaScript for web development. JavaScript can run in every single browser. Let me show you. We can just right-click any website, even Google, and then press Inspect right here. And this will likely open this tab right here for you. And right now, we are inside of the Elements tab. So now let's click the console right here. And you will use the console a lot when working with JavaScript. And the reason for this is that you can, for example, write JavaScript code inside of the console. Probably the easiest JavaScript statement would be console.log followed by opening and closing brackets. And inside of these brackets, you can use a string. You don't need to understand any of this, but this here is essentially a string, so a text. And right here, you can just write anything you like. So I could have hello guys, like so. Now I can press enter, and this will execute JavaScript code. So now we get inside of the console, hello guys. And of course, the console is the tab where we are currently in. So this here is the console. And this statement essentially just says, inside of the console, output the string hello guys. And again, you don't need to understand this statement yet, but why is it even possible to execute JavaScript code in the browser? And the reason for this is that every single browser, so Google, Firefox, Microsoft Edge, and so on, so all of those browsers have their own JavaScript engine. So an engine that essentially takes your JavaScript code, interprets the JavaScript code, and then executes the JavaScript code. And therefore, it is possible to execute JavaScript code in the browser. So without those engines, it wouldn't be possible. But since every browser has this engine that is able to execute JavaScript code, we can just use JavaScript code right here, for example. So inside of the browser. So inside of this course, I could show you pretty much all of the JavaScript basics inside of this console, but I'm not going to do this because there is a better and cleaner way. And that is a development environment. In our case, we are going to use Visual Studio Code. You can use pretty much anything you like, but Visual Studio Code is pretty common, and if you want to follow this course, I recommend you to install it as well. So let's first of all install it before I further explain it to you. So we're going to enter Visual Studio Code into Google. We're going to press the first link. We're going to press Download for Windows right here. This will start the download, and we're going to wait for this to finish. Once done, we can press the setup. This will open this window. We have to accept the agreement. Then we're going to press next. Those two checkboxes need to be checked. Then we're going to press next again. And now we're going to press install. So essentially, you just follow the setup steps and always press next. Then we're going to wait for this installation right here to finish. And once done, we can, in a couple of seconds, just press finish right here. So now we can press finish, like so, and this should open Visual Studio Code for you. So now this open Visual Studio Code. Alternatively, you can always just go to your search bar and just enter Visual Studio Code, press Visual Studio Code, and this will also open Visual Studio Code for you. Then you will have this welcome screen. And for those of you who already used HTML, you know that you can create a new file by going to the Explorer tab right here. Then, first of all, you have to open a folder. This folder will be your root directory. So essentially the folder where you have your entire project. So all of the files that belong to your project. So we can just press Open Folder. And if you are going to create a new project, you usually also create a new folder because, of course, the project is inside of this folder. So I'm going to go to my desktop. I'm going to right-click my desktop. I'm going to press New, Folder, and now I'm going to give this folder a name. And this can literally be anything you like. But since this is a JavaScript course, I'm probably going to say JavaScript course. I'm going to select this folder, like so. And now this will open Visual Studio Code within this folder, so within our project folder. Everything that belongs to our project should of course be inside of this folder later on. Let me also close this right here so we see a little more. And now, when you work with HTML, CSS and JavaScript to create your websites, you usually create HTML, CSS and JavaScript files inside of your root directory. So in our case, instead of JavaScript course, inside of this folder. And for those of you who already know HTML, you can, for example, create an HTML file by using index.html. And the .html extension will say that this here is going to be an HTML file. So this later on tells the browser that this should be interpreted as an HTML file. The same works with a CSS file. So style.css, for example. And again, the .css extension tells the browser that this should be interpreted as a CSS file. And now you can already imagine that you can do the exact same for JavaScript. So you can, for example, use an index.js file. And by using the .js extension, you will later on tell the browser that this here is a JavaScript file and should therefore be interpreted as a JavaScript file. And of course, the name index, and style is up to you. That is just a convention that a lot of programmers use. But you can pretty much, again, use anything you like. So you could also use something like this. And this would work as well. Let me close the Welcome tab. And let me again rename this to index.js, like so. And now you can also write JavaScript code inside of this index.js file right here. So I could also say console.log hello guys, for example. Usually every JavaScript statement ends with a semicolon, like so. And now this here is valid JavaScript code as well. The only difference is that this time we are not writing it inside of the browser, so inside of the console right here, but instead we are writing it within an IDE, so an integrated development environment. And the name is really complex, but an IDE is essentially just a place where you can write your code. And in our case, it's Visual Studio Code. So an IDE gives you auto-completion, gives you some suggestions, shows you when you have an error, and so on. So an IDE just makes your life a little bit easier. So let me show you. When you write console, for example, this here is auto-completion, for example. So now I can just press enter or click console, doesn't matter. And this will automatically auto-complete the statement for me. Now, once I use a dot, and you don't need to understand this yet, but now I get a couple more suggestions. So those are things that I could want to do. And right here, you also see the log suggestion. So now I could also just press this one, and this will automatically use console.log right now. And that's the benefit of an IDE. It just makes your life a little bit easier. Now, to really execute this JavaScript code in the browser though, you have to link it to your HTML file. Because in the end, every website starts with an HTML entry file. You will open this HTML file. This index.html file then loads a couple of styles from a CSS file, and it can also load some logic from a JavaScript file. So to sum up, the HTML file is your entry point, and only the HTML file then, once it's loaded, loads the CSS code and the JavaScript code. So we somehow need to link our JavaScript to our HTML code. In Visual Studio Code, we can create a basic HTML template by using an exclamation mark and then pressing enter, like so. So now we have this basic HTML template. Now there exist three ways to execute JavaScript code, or to include JavaScript code to be precise, inside of HTML. The first one, and the most important one, is just linking an external style sheet. And in order to link an external style sheet, you can just use the script tag in the head in VS Code, and then you use :src, like so, and then you press enter, and this will automatically create the script tag for you. And now, instead of the source attribute, you can define a path to your JavaScript file. In our case, the JavaScript file is inside of the exact same folder, so it's enough to just define a name like so. So index.js, and now we link this JavaScript file to our HTML file. But every time you use the script tag to link a JavaScript file inside of the head, right here, so inside of this head tag right here, you also need to use the defer attribute. And the reason for this is that usually HTML gets executed from top to bottom. So first of all, this line gets executed, then this line, then this line, then this line, and so on. So from top to bottom. And usually you first of all want to execute your entire HTML code. So maybe you have an H1 right here that says npc codes, like so. Then you might have a paragraph right below that includes a little bit of text and so on. So I think you get the idea. And only after all of this has been executed, only then you usually want to execute your script. Because the script only adds functionality to the elements on your page. But it would be kind of useless to add functionality to something that hasn't even been loaded yet. Therefore, you first want to load all of the elements, and then you want to include your script tag right here to add the functionality to all of the elements that have been loaded. So something that you did a couple of years ago was to always take the script tag and put it at the end of the body tag. So script::source, and then you would link your index.js file like so. And this here is completely valid. But a modern way to achieve the exact same is to just take the script tag, put it into the head like so, so script::source. Then you're going to link your index.js file, and then you use the defer attribute, and the defer attribute essentially says execute the entire HTML code, and only after you've finished executing all of this, only then execute this line of code. So only once everything has been loaded, we're going to include our script, so our JavaScript file. And now everything we write inside of this index.js file will also be executed on our website. So let me show you. Most of you who know a little bit about HTML know that there exist a couple of methods to open an HTML page. So this HTML page right here. The first one is to simply open our folder right here, so our project, and then you can just double click the index.html file, like so. And now this here is our website. At the moment, we are not seeing anything on this website. So let me take a look at the website. And actually, I need to save this. And now, every time I reload, the changes will appear on this page, like so. So now we have this text right here and this paragraph that we included previously on our index.html page right here. But this is not an HTML course. We also want to see that our JavaScript has been successfully included into our project. In order to do so, we have to right-click our page and we have to inspect our page. Now we have to go to the console tab because currently we are saying inside of the console we want to log hello guys. So we are going to go to the console, and if everything worked, then we should see hello guys in the console. And you can see we are seeing hello guys in the console. So this code right here has been executed. I could also say console.log hello again, like so. I'm going to end the statement by using a semicolon. And now let's go back to the page. We need to reload the page. And now we're having hello guys, hello again. So our JavaScript code right here has been executed successfully. So this here is the most common way to include a script, so a JavaScript file, into your HTML code. And that is the way that you should definitely remember. And we will use this throughout the entire course, so we'll definitely remember this. But there exist two more ways to achieve the exact same result. Now let's delete this line right here and let's save this. Let me go back to the browser. I'm going to reload, and you can see once we remove the script tag that links our index.js file to our HTML file, we are not seeing this output on our page anymore. But now there exists another way to use JavaScript code inside of an HTML file, and that is by using the script tag. Usually, you will use the script tag at the bottom for the same reason that I've previously explained. You always want your JavaScript code to execute after all of the HTML code has been parsed. So now I'm going to use the script tag right here. And now we have an opening script tag and a closing script tag, like so. And in between of those tags, so in between opening and closing tag, we can now write JavaScript code. So we could, for example, say console.log hello from the script tag, like so. I'm going to save this. I also add a semicolon. Let me go back to the page. Again, I have to reload the page, like so. And you can see we're getting in the console hello from the script tag. So this seems to work as well. And usually this method is not really that great, and the next method is probably even worse. You can use it if you're just testing or want to get things done very quickly, but it's not the recommended way. The recommended way is to always link an external JavaScript file. But let me show you how inline JavaScript code works. Imagine you have a button, for example, like so, and this one could say click me bro, like this. And now let me reload the page. So we now have this button. We don't have any output in the console. And now I can say on click, for example, I want to execute a little bit of JavaScript code. So now I could just add the JavaScript code right here. So I can say console.log, like so. And now I'm just going to use single quotes in order to make this work, because you can't use double quotes instead of double quotes. This will not work properly. You will later on understand why. But for now, just accept this. And now I could just say, hey, for example. I'm going to save this. I will open my page. I'm going to reload this. I'm going to click this button, click me bro. And you can see we're having hey in the console. Every time I click this button now, you can see this number here increases and we add a hey as an output. So the more I click, the more often we're going to output hey. And let's go back to our code. Let me delete this line And just remember that there exists a couple of ways to include JavaScript code into your HTML, but the method that we are going to use, and the one that you should use as well, is always to use a script tag and define a source attribute that points to your JavaScript file. If you define it in the head, you always want to add the defa attribute that tells our browser that JavaScript, so this line right here, should be executed after all of the HTML code has been parsed. And that is how you include JavaScript into your HTML code. Up to this point, you saw that I always had to reload the page right here. And I also had to click the page inside of our folder to open it inside of our browser. Of course, this is a way to do it, but this here is kind of annoying because every time I make a change, I have to reload, and every time I want to open my page, I have to double click it. And in order to fix this, Visual Studio Code, so our IDE, provides extensions. And this here is the Extensions tab. We can go to the Extensions tab and we can search for a lot of different extensions. There exist extensions for JavaScript, for HTML, for CSS, for all kinds of purposes. And of course also for Python, for React, for pretty much all kinds of programming languages. And one that you will use very, very often together with HTML, CSS, and JavaScript is the live server. Because the live server solves exactly the problem that I have been talking about. So we're going to go and press on live server. I already have it installed, but in case you do not have it installed, you're just going to see an install button right here. You will press this install button and wait for the installation to finish. And once you have the live server installed, you can go back to your Explorer tab right here. You can right-click your index.html file like so, and then you can open it with the live server by just pressing open with live server like so. And you can see this here now also opened our page inside of the browser. But now let me go to inspect like so. Let me write a little bit of JavaScript code. So I'm going to go to our index.js file. I'm going to save this. Let's go back. Let's open the console. You can see we're having hello guys, hello again. Let me reload this. So all of this here is gone like so. We're only seeing hello guys, hello again. And now I can just say console.log updated, for example, like this. I'm going to save this. Once I save, you can see our server restarted essentially. And now we're getting hello guys, hello again, and updated. And I did not have to reload the entire page. And the same also works for our HTML code. So if I'm going to write something else right here, so maybe a paragraph, updated, and once I'm going to save this, I can go back to my page and I have updated right here. So no matter what change occurs, once we use the live server will immediately detect the change and will immediately update our website. So whether it's JavaScript code, whether it's CSS, whether it's HTML, that doesn't matter. The live server will always make sure that we're seeing the newest version. And now that we've set everything up, we are ready to really understand CSS. So let's close our style.css because we are not using CSS at the moment. We can actually also close our index.html file because now our JavaScript file is essentially included into our HTML file. So we do not have to touch this here anymore. And now we purely want to focus on JavaScript. So from this point on, let's really understand how JavaScript works. So let me delete this and let's start by taking a look at the first topic. Let's now really understand the basics of JavaScript. And let me first of all get rid of this text right here because this is probably a little bit distracting and we do not need it for now, like so. Let me close this tab and let's go to our index.js. Let me also minimize this right here. And now this here is the console and this is the website. And every time you want to clear the console, you can just press this clear console icon right here to get a clear overview. You've already seen the probably most basic statement, and that is the console.log statement. that essentially allows you to just output something in the console. So this could be text, for example. Every time you have text in JavaScript, you use quotation marks. So you usually write text inside of quotation marks like so. So this could be NPC codes, for example, like this. Every single statement in JavaScript ends with a semicolon, like so. And now I can save this, and you can see we're getting NPC codes in the console right here. So let me clear the console again. You can also use the console.log statement to output numbers, for example. So you could also say console.log, like so. And now I can just enter a number like this. Again, I have to end the line by using a semicolon like this. I'm going to save this, and we're getting NPC codes in the console right here, and we're getting 10 right here. And let me also make the console a little bit bigger for you, so you really see what is going on right here. And now you can see we're having NPC codes and 10 right here. And let me actually also just resize the console for you so you see it a little bit better. Like this probably. You could also use basic addition like this, so 10 plus 10 for example. I'm going to save this, and you can see we're getting 20 in the console right now. But we'll understand more about this when we get to arithmetic operators. So this right here is a line of code. You always have your code right here, and you end the statement by using a semicolon. The code in JavaScript will get executed from top to bottom. So first of all, JavaScript, or the browser to be precise, will execute this line. Once this line has been executed, the browser is going on to this line and will therefore execute this line. And you can see that this happens if you take a look at the console. First of all, we are seeing NPC codes, and only after that we are seeing 20 in the console. Now, there also exist comments in JavaScript. You can write a comment by using a double slash, so slash slash. And now you can write pretty much any text you like. So, hey guys, what's up, for example. Like this. I'm going to save this. And you can see, even though I wrote something right here, nothing really happened. And the reason for this is that comments are only there for you or other developers. So comments really exist to document your code. So maybe you want to explain something to other developers. Maybe you want to add a note for yourself so you remember something later on, and so on. So for all of those reasons, you could use comments. So comments will never get executed. They just exist to add a little note for you or someone else. So that is the purpose of comments. Let's now understand variables in JavaScript. A variable is used to store a value. So what do I mean by that? In order to explain it properly to you, let me just use a console.log statement. And let's just output my channel name, for example. So NPC codes like this. We end this by using a semicolon. I'm going to save this. And you can see we get NPC codes in the console. But isn't there a way to store this value somewhere else, for example, and then just reference the place where we stored this value? And in order to do so, we can use a variable. You can create a variable by using the let keyword. So using let always says that we are going to create a variable. After the let keyword, you always define a variable name. So this one could be channel name, for example. Now for the channel name, I can say that my channel name is equal to NPC codes like this. And now I can use this variable channel name and just replace this text right here with the variable name. So now I'm referencing this variable name right here, and we are getting the exact same result. Now I can change the value right here to NPC, for example. I'm going to save this, and you can see we're now only getting NPC in the console. So what is even the benefit of having a variable? And our programs at the moment are really simple. But later on, you might want to use a variable over and over again. And let me create a basic example that doesn't really show the reality, but I think you will get the idea. So maybe I have this variable right here twice. And inside of a real app, I might have this variable and use it somewhere like maybe 10 times, maybe 20 times, maybe 100 times. If I now would have the value right here instead of the variable name, like so, I still get the exact same result. But now imagine I wanted to have NPC codes instead of NPC right here. Now you can imagine I would have to take this value and paste this value in here, in here, in here, and in here. And for a small app like this one, you could argue that it's not that bad, but as apps grow, this gets worse and worse. So it is much smarter to just use a variable, define this value once. Now we can just use this variable name right here and essentially reference our variable. And every time we want to change our variable, we only have to do this change in one single place. So now I could say I want to have NPC codes instead of NPC. I'm going to save this, and you can see it updated every single console.log statement. So this is much more efficient. If you take a look at the naming convention, for variables, this here is the naming convention. So this is called camel case. Let me write this out for you. So this is what you call camel case. And the reason for this is that this is pretty similar to a camel. A camel also starts kind of low, and then you have a peak, a low, a peak, a low. And the same works for naming essentially. So you always start with a lowercase letter, and every new word has an uppercase letter. So channel name of my YouTube channel, really a bad variable name, but that is how you would use this convention to define this variable name. So every new word has a capital letter and the rest is always lowercase. Something that is important for variables in JavaScript and in pretty much any programming language is that variable names should be descriptive. So from time to time you might see developers that will just use something like X, Y, Z, and so on. And technically, of course, this works. So you can also say console.log Z, for example, but it doesn't really make any sense. And later on, if you open this code or another developer opens your code, no one will really understand what you were doing right here. Instead, if I'm giving this variable the name, channel name, for example, like so, everyone will understand, so you and even other developers will understand that this here is going to be the channel name. So this here is much more descriptive. And when writing code and defining variables, you always want to use descriptive names. So to summarize, a variable allows you to store a value inside of the variable. And this is pretty similar to a package in the real world, for example. If you think about a package, you also have this package, and then you can put something into this package, and it is essentially stored there. And later on, when you want to know what is inside of this package, you can always take a look at this package. So a variable is pretty similar. It allows you to store something inside of it. And when defining a variable using let, you always have the possibility to change the variable later on. When defining the variable, so when defining it for the first time, you always have to use the let keyword. When modifying the variable later on though, you can just use the variable name, so channel name, and say this one is equal to NPC, for example, like this. So I could also say channel name is equal to NPC after you've used console.log for the first time. And now you can see for the first line, channel name is NPC codes. Now we are changing our channel name to NPC. So every console.log statement that comes after this change will now use NPC instead. And of course, the reason for this is again that JavaScript code executes from top to bottom. So just remember, you can always modify a variable that you define by using let later on. Something that is important though is that you do not have to assign this value immediately when declaring the variable. So you could also just declare this variable, so let channel name. Now this variable channel name exists. You can already see that now our first one right here is undefined. We will understand what this means later on, but for now, this essentially just means that this variable does not have a value yet. But now I could also say channel name is equal to NPC codes, for example, like this. So this here is what you call the variable declaration, and this is what you call the assignment. Because right here, you declare that this variable exists, and right here, you assign the value to this variable. And of course, you can do both of those steps in one single step by using the equal sign right away, like this. So this works as well, and is a lot shorter. So most of the times you will see this. Now you can define a variable by using the let keyword, but you can also define a variable by using the const keyword. And when using the let keyword, this essentially means that you can modify this variable later on. When you use the const keyword, this means the variable is constant. So this variable cannot change its value after the declaration. And a good example is pi, for example. So pi is a constant because pi, of course, is always the exact same and it should never change. So pi is 3.14, and I don't really know more numbers, but that is enough for now. And now I can, for example, console.log pi right here and pi right here. Let me delete all of this because we do not need this anymore, like so. And you can see we're getting 3.14. So this works just the normal way. But if I now want to modify pi and say this here is 4, for example, you can see that we're getting an uncaught type error, assignment to constant variable at index.js84. So at this line essentially. So it is not possible to reassign another value to a constant variable. And a convention for constant variables is that you use capital letters. So everything is essentially capital. So to summarize, a variable is essentially a placeholder for a value that you can later on use to reference this value. You can define a variable by using let or const. When using let, you can modify this variable later on. When you use const, this variable is constant and the value cannot change after the first assignment. And that is all you need to know about variables in JavaScript. Let's now understand all of the primitive data types. Whenever you have a value in JavaScript, under the hood, JavaScript will assign a data type to this value. And knowing those data types is really important. So let's take a look at a couple of them. And the first one we are going to look at is the data type string. A string is essentially just a text. Imagine we wanted to define a first name. So let first name be equal to maybe NPC codes like this. So now we're defining the variable first name, and that one is equal to a string, so essentially a text NPC codes. Every single string is inside of those quotation marks. You don't have to use those quotation marks though. You can also use single quotation marks like so. This here works as well. And you can also use backtick characters, for example. So all kind of quotation marks work, like so. So this here is what you call a string in JavaScript. And the next data type we're going to take a look at is the data type number. And as you can already imagine, a number is just a number. For example, if we have a power level like so, that is likely going to be a number. So that one could be 9,000, for example, like this. When you define a number, you essentially just type out the number. You don't need quotation marks, you don't need anything like that. Just typing out the number is enough. The next important data type is the Boolean. And a Boolean is similar to a light switch. A light switch can be turned on or off, and a Boolean can either be true or false. So imagine we wanted to define whether someone has a big biceps or not. So you can either have a big biceps or you don't have a big biceps. It's as simple as that. And now you could define a variable, let has big biceps, for example, be equal to, and now possible values would be true, like so, or false, like so. So a Boolean can either be true or false. And if someone has a big biceps, it might make sense to say let has big biceps be equal to true, like so. The next important data type is undefined. And we've already seen undefined. If you define a variable, so maybe the variable age, but don't assign a value to that variable, like so. So you only declare the variable, but never assign a value to this variable, then the variable is going to be undefined, because there's no value defined yet. And now there also exists the value null essentially. In case you want to say that a variable does not have a value, then it might make sense to say that this variable is equal to null. So I could say let empty value be equal to null. And by explicitly setting this equal to null, we are saying that empty value does not have a value. So the difference to undefined is that a variable that is undefined is just not defined yet, whereas a variable that has the value null should not have a value. So we're explicitly saying this one should not have a value at this point in time. The behavior is pretty similar, as you will see later on, but nevertheless, it's important and good to understand the difference. And those ones were the most important primitive data types that you need to know. Let's now understand the Typeof operator. And the Typeof operator returns the data type of a value. Let me show you. Imagine we're having a first name, for example. And first name is again going to be equal to NPC codes like this. Now I want to find out what the data type of first name is. Of course, right here we know that the data type is string, but oftentimes you will use the Typeof operator when you do not know in advance what the data type is going to be. And now we can use the Typeof operator by using type of first name. And let me just console.log the result of this. So I'm going to console.log the type of first name. I'm going to save this, and you can see we're getting string. Because of course, first name at the moment is a string. Let me also replace this and use a number, like 1000. You can see we're getting number as a data type. If I would use something like a boolean, so true, I would get the data type boolean. If I'm not going to assign a value at all, I'm getting the data type undefined. And if I'm going to set this equal to null, we are getting an object. And you do not need to understand objects yet. We will get to that later on. And that is all you really need to know about the Typeof operator. So the Typeof operator just allows you to return the data type. Let's take a look at the plus operator. And the plus operator can be used to add numbers or join strings. Let me show you. For now, let me just console.log something. And now I could, for example, have a string that says hello right here. If I'm going to save this, you can see that I'm getting hello in the console. And now I could use the plus operator to concatenate strings, for example. So I could say hello guys, like so. And you can see I'm getting hello guys, but I'm not having a space in between those words. In order to do so, I would have to add a space right here in front of this character, like so. Instead, I could also add a space to the end of this word, like so. And I can do this as often as I like. So I could also say hello plus. Now I could add a space right here inside of another string. And I can use another plus right here. And this would have the exact same result. I could also add an exclamation mark like this. So I can use the plus as often as you like together with strings, and then you can concatenate them using the plus. But you can also use the plus for numbers, and the behavior for numbers is completely different. So if I'm now going to console.log 10 plus 5, for example, we are getting 15 in the console, whereas adding 10 as a string to 5 as a string, for example, would give us 105. Because right here, JavaScript interprets this as a text, and if you add the text 5 to the text 10, you will of course get the text 105. If you add the number 10 to the number 5 though, you will of course get the number 15. So right here, it just concatenates text, whereas right here, it adds one number to the other number. So this here is the mathematical operation, whereas this is text concatenation. So when using the plus operator, it depends whether you're working with text or with numbers. So to summarize, you can use the plus operator to add numbers or join strings. And that's all you need to know about the plus operator. Let's now take a look at arithmetic operators in JavaScript. You use arithmetic operators for math. And you will probably know most of them from basic school math, but some of them might be new to you. So let me introduce you to all of them. Let's start by taking a look at subtraction. Let me just console.log the result of this operation. And for now, let's use 10. For subtraction, we're just going to use the minus symbol. And let me subtract 5 from 10, like so. I'm going to end this by using a semicolon, like this. And you can see, as expected, we're getting 5 in the console. So this here is just a normal minus. You can also use addition. And addition is pretty similar. Again, I'm going to console.log the result of 10 plus 5. And as you can imagine, we're getting 15 in the console. There also exists multiplication in JavaScript. And you can just multiply one number by another number. So 10 times 5, for example, would result in 50. And of course, we also have division like this. And we can divide one number by another. So if I'm going to divide 10 by 5, we should get 2. And indeed, we do get 2. So those ones were the basic ones. But now there also exist a couple more confusing ones. The first one is the remainder. And that one is also not hard, but a couple of you might not know that one. So let's console.log the result of 10, remainder 3, like so. I'm going to end this by using a semicolon. And you can see we're getting 1 in the console. Why are we getting 1 in the console? This here essentially says divide 10 by 3. 10 divided by 3 is 3. But it doesn't really work. We will still have a rest of 1. And the remainder is essentially just the rest. Since the rest is 1 right here, we are having a remainder of 1. I would now use 5, for example. So 10 divided by 5. This works perfectly fine. So we don't have a rest. 10 divided by 5 is 2. Rest 0. So we are going to get 0 in the console, as you can see. If I would use 4, for example, we would have 10 divided by 4, which is 2, rest 2. We're going to get the rest again, so rest 2. And of course, you can also use 6, for example, then you would get rest 4, because 10 divided by 6 is 1, rest 4. So that is how the remainder works. There also exists an exponent in JavaScript. So let me console.log the result of 2 to the power of 2, for example, which is going to be 4. So we are getting 4 in the console right here. I can also raise 2 to the power of 3. So now we're getting 2 times 2 times 2, which is 8. I'm going to save this, and you can see we're getting 8. I can raise 2 to the power of 8, which should be 256. And we're getting 256, like so. Now let me delete all of this and let's create a number. So imagine we have the number 10, for example. Let me now just console.log our number, like this. And now we could also say that number is equal to our number, so our old number, plus 10, for example. And now we're getting 20 in the console because we assigned to our variable number the old number plus 10, like so. And of course, we could also say number plus 20. So that is up to you. But there's also a shorter syntax for writing number plus 20, for example. You can achieve the exact same by saying number plus equals 20. And this is essentially equivalent to saying number is equal to number plus 20. So this is just the shortest syntax in JavaScript. And again, we're getting 30. I could also say plus equals 50, and this would be equivalent to saying number is equal to number plus 50. Now we're getting 60, of course, And you can do the exact same with subtraction. So I could also say minus equals 50, and now you would get minus 40. You can also do that for multiplication, like so, and of course also for division, and of course also for the remainder, like so. So you see, all of this here works. Now, from time to time, you maybe only want to increment a number by 1, for example, like this. And this is actually something that happens pretty often in JavaScript. And under those circumstances, you could of course say number plus equals 1. You could also say number is equal to number plus 1, which would just be a little bit longer. So you would definitely prefer to say number plus equals 1. But there is actually an even shorter syntax, and that one would be to just type out plus plus. And saying plus plus in JavaScript just means that you're going to increment this number by 1. And now you could do the exact same once again. So number plus plus, and now we're incrementing once and we are incrementing twice. So we are getting 12 right here. And the same also works for minus minus to decrement by 1, like so. I'm going to duplicate this twice. And now we're going to increment 10 to 11. And then we're going to decrement 11 to 10, 10 to 9, and 9 to 8. So we should get 8 in the console. And you can see we get 8 in the console. Now let me also show you a basic equation. So let equation be equal to 10 times 6 plus 3, for example. And now let me just show you the result by console.logging our equation. And you can see we are getting 63. So similar to normal math, multiplication comes before addition. The same, of course, also works for division. So division also comes before addition. And of course, division and multiplication also come before subtraction, like so. And let's use plus and multiplication right here. So we're getting 63. But now you can also use brackets, for example. And brackets will always come first. So now we're having 6 plus 3, so 9. And then 9 times 10, so 90. So the order in which operators get executed is pretty much the exact same that you have learned from school. You always have brackets first, then multiplication and division, and last addition and subtraction. So just the normal order you know from school essentially. And those were the most important things you need to know about arithmetic operators in JavaScript. Let's now understand escape characters. And escape characters are used to add special characters to a string. So imagine we are having the string NPC is the best, like so. And you can see inside of the console we are now having NPC is the best. But now maybe I want to have a new line after NPC. In order to do so, I can use a backslash like this, followed by NN. And this here is an example for an escape character. I'm going to save this, and you can see NPC is now in the first line, whereas is the best is in the second line. So an escape character adds a special character. Under those circumstances, it's a new line. I can also use /t to add a tab, so essentially a second spacebar. And now I could do this as often as I like so. And you can see we are adding tab over tab, like so. So I can also stack them right after another. Another example for an escape character would be a backslash, and then you need to use a double backslash. Because of course, the first backslash always says that I want to use an escape character. So for example, new line, a tab, or a backslash. And because a backslash has a special meaning, we also need to escape the backslash. So backslash says that I want to use one backslash, like so. And now the same goes for quotes. So since quotes have a special meaning inside of JavaScript, we cannot just use normal quotes. In order to use quotes, we need to escape them to tell JavaScript that I want to use a quote, so a quotation mark, like so. And now this here will work, but once I'm going to save this, VS Code is actually going to transform this, because you can also use double quotation marks instead of single quotation marks. So this here is valid. And therefore, you technically do not really need an escape character, but this would work. My IDE essentially just says that this here is a better solution, and once I save, it automatically replaces that. But remember, escape in quotes would work as well. So to summarize, an escape character allows you to add special characters, like a new line, a tab, or a backslash, for example. Let's take a look at the most important string functions. And you use string functions to work with text. So imagine we're having a text like channel name once again, which is going to be equal to NPC codes like this. And now maybe I want to know the length of the string, so the length of this text. So how many characters does this text have? And in order to do so, there exists something like a string function. There exist all kinds of string functions, and as mentioned, one is for outputting the length of a certain text. In order to do so, we're going to use the variable name that holds our string, so channel name, and you can always access those string functions by using a dot. So once you use this dot, VS Code will already show you a couple of those string functions. So one is length, and we have a lot of them, as you can see. So replace, repeat, and if you hover over them, you already see within those brackets that repeat or replace, for example, are methods, whereas length right here is a property. Every time you call a property, so something like length, for example, you can just do it like this, so dot length like this. Every time you call a method, so something like replace, for example, so this one, you always have to use opening and closing brackets. You will also understand methods and properties and the difference between them a lot better later on, but for now, all you really need to know is that once you hover over something, you will see whether it's a property or a method. And if it's a property, you can just type it out like this. If it's a method, you always need opening and closing brackets. But let's now take a look at the length property. We can output the length by console.logging that, of course, the way we've done up to this point. And you can see we're getting a length of 9. If I would add a couple more spaces, we're getting a length of 11, and so on. So everything counts as a character, even a space. Let me remove those spaces right here, and now we're getting 9 again, because we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 characters. So, like this, we can get the length. We can also transform a text to uppercase or lowercase. So, uppercase. In order to do so, let's again console.log the result, and let's access channel name. Again, we need to use the dot to access a property or method. And in this case, we want to get the to uppercase method. You can see that it's a method again by taking a look at those brackets right here. And we have method inside of them. So we're going to access the to uppercase method. Again, if we are accessing a method, we need opening and closing brackets like so. We're going to end the statement by using a semicolon. And I'm going to save this. And you can see we're getting NPC codes, but now everything is uppercase. Of course, we can do the exact opposite by using lowercase. So I'm going to console.log channel name dot to lowercase. Again, we have a method, so we need opening and closing brackets, and we end this by using a semicolon, like so. And now we have NPC codes, but this time everything is lowercase. We can also check whether our string, so NPC codes, includes a certain character sequence. So we're going to take a look at includes. Let me console.log whether our channel name dot includes you can see it's a method right here. So we have to use opening and closing brackets. And right here, VS Code also suggests that inside of those brackets right here, we should enter a search string. And that parameter is of type string. For now, you do not need to understand this really in depth, but just remember that inside of those brackets, we can define what we are searching for. And you will understand why exactly we have to do this a lot better later on. But for now, let's just insert a search string. So what are we searching for? We are searching for a certain character sequence, so maybe for NPC. Let me save this. And you can see we're getting true because, of course, NPC is inside of our original string, NPC codes. I'm now going to search for NPC like this. So with a lowercase c, we're getting false because we're not matching the exact same character sequence anymore. Next up, let's take a look whether a text starts with a certain character sequence. In order to do so, we can again console.log the result of channel name dot, and now we can use the starts with method. Again, it's a method, as we can see right here. I'm going to use opening and closing brackets, and every time you use those opening and closing brackets, you can see that Visual Studio Code already suggests us that we can use a search string, for example. We could also use a position argument, but that's not really important. So for now, let's focus on the search string. What are we searching for? We want to check whether our string starts with NPC, for example, like so. I'm going to save this. We're getting true again. If I'm going to check for n, this is also true. If I would check for p though, this would be false because our string, so our channel name, NPC, does not start with a p. Of course, we can also check whether something ends with a certain character sequence. So I'm going to console.log our channel name again, and I'm going to check whether it ends with a certain character sequence. At the moment, it ends with an S, so let's search for this. I'm going to save this. We're getting true in the console because, of course, this is true. If I would insert codes, I would also get true. If I would say C though, I'm getting false because, of course, NPC codes ends with an S and not with a C. We can also search for a certain index. And that one is a new concept to you, but it's pretty simple. So I'm going to console.log channel name dot index of. It's again a method. So we need those brackets. And now we can search for a certain character or a certain character sequence. Let me, for example, use P like so. That one should be our second letter. So N is the first one, P is the second one. Let me save this, and we're getting 1. Why are we getting 1 even though it's the second character? Because in JavaScript, strings and a lot of stuff start counting at 0. So this here is position 0, this here is position 1, this is position 2, this is position 3, 4, 5, 6, 7, and 8. So instead of starting to count at 1, in JavaScript, you most of the time start to count at 0. And therefore, P has the index 1 because it's 0, 1, like so. If I would enter N, for example, you can see 0 in the console. So index of will essentially just return the index position, so the position of a certain character or character sequence. So I could also say NPC, and we would still get 0 because it outputs the starting position of a certain sequence. If I would enter codes, we would get something like 4. We can also trim a certain string. So imagine I had all of those white spaces right here. And you can see now this moved our text to the right because now we have those white spaces. Let's also add some at the end, like so. Even though you cannot see them right here, if I mark the entire string, you see that we now have white spaces in the beginning and at the end. So can I somehow get rid of those white spaces? In order to do so, I can again use console.log And now I'm going to use channel name dot trim, like so. Again, this is a method. So I'm going to use that one or execute this one. I'm going to save this. I'll output the result. And you can see now our white spaces are gone. And you might think at first that this trim method is useless. But this here is actually one of the most important methods overall, because that one allows you to, for example, accept user input, for example, when a user registers on your website, and then remove all of the white spaces. For example, if a user goes to your website and enters something like hello@gmail.com, like this, it would be pretty useless to store those white spaces and those white spaces in a database. Therefore, you can then use this trim method and trim this and store the trimmed version in the database, which makes a lot more sense. So this here is something that you really want to do pretty often in the real world. So that is a method that you definitely want to remember. We can also split a string at a certain position. So let me just show you. I'm going to console.log channel name dot split, like so. And now right here I can define a character where we want to split our string. This can be anything. It could be an N, it could be a P, it could also be a white space. So a tab essentially. And that is something that you do pretty often. So I'm going to do it like this. And you can see for every single white space, it created one entry inside of this list. You do not need to understand this. This here is what you call an array in JavaScript. Again, you do not need to understand this, but it's essentially a list that stores everything for you. And every single comma essentially separates one item from another. So at the moment, we have 8 items inside of this array. Why do we have 8 items? Because I still have those white spaces right here. So let me remove them for you. So you really see how this works. I'm going to save this. And we only have 2 items left. Why do we have 2 items? Because we have one white space. So we separate this string from this string because that has been our splitter essentially. So we split this text whenever we have this white space inside of our sequence. And then we take the individual parts of our text and store the parts inside of a list. So inside of an array in JavaScript. And those were the most important string functions in JavaScript for now. So to summarize, you can use those string functions to, for example, get information about a string, to manipulate strings, and to work with them in general. Let's now take a look at template literals. Template literals allow us to insert variables into text. What do I mean by this? Imagine we are having something like first name. And the first name could be equal to NPC once again. And now in the console, maybe I want to output something like hello space plus first name, for example. So that is something that works. So now in the console, we are having hello NPC. And of course, you could also have something like an age. So I could define an age of 116, for example, because I'm probably kind of old already. And now I could say hello plus first name plus comma, for example, you are plus age plus years old, like so. Let me save this. Hello NPC, you are 116 years old, like so. But now, as you can see, this here looks kinda off, to be honest, and it's really confusing as well. So isn't there a better way to insert variables into text, for example? And that is where you can use template literals. So again, I'm going to use console.log, and when using template literals, you always have to use backtick characters. So 2 backtick characters. Besides that, there's not really a difference to a normal string. Instead of normal quotation marks, you just use those backtick characters. And now I can also say hello, followed by a spacebar. And now we can insert our first name variable, for example, by using a $sign and opening and closing curly braces. And inside of those braces, we can now define our variable name. So hello, first name, you are, again, $, opening and closing brackets, age, years old, like so. And we're getting the exact same result. The only difference is that this here is a lot more readable. So by using template literals, we can get a much cleaner version when inserting variables into text. Something that is also cool about template literals is that it will also recognize new lines. So if I'm going to do this, for example, you can see that your 116 years old now goes into the new line, like this, for example. So every time you want to use a variable together with text in JavaScript, it might make sense to use template literals. Let's now take a look at math functions. And math functions exist for mathematical calculations. For most math functions, use math dot. And again, you don't need to completely understand how this works, but by using the dot, we can again access properties or methods. And one of the properties, for example, is math.py. Again, you see that this is a property by looking at those brackets. And now I can, for example, console.log math.py, like so. And you can see we're getting the value of pi inside of the console. So by using math.py, we can always access the value of pi whenever we need it. And there exist a lot more math functions and properties. So let me demonstrate a couple of them to you. So let's console.log math.round, like so. And this will allow us to round a number. So maybe I want to round the number 2.5. And you probably know from school that 2.5 will be rounded up to 3, whereas 2.4, for example, will be rounded down to 2. But maybe I always want to round a number up. In order to do so, I can use math.ceil, like so. And this will always round the number up, so to the next higher whole number. So 2.1, for example. And this will be rounded up to 3. There, of course, also exists the opposite. So console.log math.floor, and this will always round a number down to the next whole number. So maybe 2.9, and this will get rounded down to 2. 2.4, of course, as well, and so on. So I think you understand how this works. You can also get the maximum value out of a couple of values by using math.max. And now you can define a couple of values. So we can use 5, 10, 20, like so. And we're getting 20 in the console because that is our maximum value. If this here would be 100, we would of course get 100. There also exists the opposite. So we can use console.log of math.min of 1, 0.4, and 1000, for example. Of course, we're getting 0.4. Let's add -1, and now we would get -1. So math.max will always return the biggest number, whereas math.min will always return the smallest number. We can also get the square root of a certain number by using math.sqrt, which stands for square root. And if you remember, the square root of 16 is 4. So we're getting 4 in the console. We can also raise one number to the power of another number by using math.pow, like so. And inside of the brackets, you can see that we need to define an x value of type number and a y value of type number. So the first one is going to be x, and the second one is going to be y. So let's raise 2 to the power of 4, for example. So 2 times 2 times 2 times 2, which should be 16. And as you can see, we're getting 16 in the console. If we would have 5 here, we would get 32, and so on. We can also get the absolute value of a certain value. So math.abs, like this. And now we need to define the number. So the absolute value of 10, for example, is 10. And the absolute value of -10 is also 10. So absolute value will only return the value without taking the sign into consideration. So whether it's minus or plus, it doesn't matter. Math.apps will only return the value. We can also generate a random number, and that is actually something that is kind of important, by using math.random like this. And now this will output a random number between 0 and 1. And every time I press Ctrl S to save the file, we're generating a new number, like so. And now I could, for example, combine math.random together with math.round, for example, like so. So now I'm rounding the result of math.random. And I'm getting 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 1. You get the idea, I think. If it's above 0.5, we're getting 1. If it's below 0.5, we're getting 0. And now I'm going to remove this and let me show you something else that is kind of cool. We can also multiply math.random by 100, and now we're getting a number between 0 and 1. And if the number is close to 1, we're going to be close to 100 because we are multiplying a number close to 1 by 100, which of course is going to be close to 100. And if the number is close to 0, we will still stay close to 0 because 0 times 100 will still be 0. So now we can create a number between 0 and 100 instead of only creating a number between 0 and 1. And that is something that you might want to do pretty often. Now we're getting 87, 39, 21. And now I can of course also combine that with math.round, for example. And now I'm getting 47, 44, 90, and so on. And there exist, of course, thousands of math functions, but those ones are the ones that are somewhat important. You don't have to memorize them as well. You can always look them up, and depending on what you're doing later on, you will probably not need any of them. So don't just memorize them, just know that they exist and look them up whenever you need them. Let's now have a simple practice project where we are going to store data for a user, so email, name, and age, for example, instead of variables, and later on we are going to use the name and the age to welcome the user. So that is a simple practice project, but it helps you to repeat some of the stuff that we've learned up to this point. So let's get started. First of all, to store the email, let's create a variable by using the let keyword, and a good name for the email would of course be email, because it describes what an email is pretty good. Our email could be equal to a certain email, so maybe npc@gmail.com. We're going to end this by using a semicolon. Next up, we want to store the name inside of a variable, so let name be equal to npc codes, for example, like so. And for the last variable, we're going to create the variable age, like so, and maybe I have an age of 99. And now we are going to use those variables to console.log a welcome message to the user. So we are going to say console.log, and now we are going to use backtick characters, and inside of those backtick characters, we're now going to say hello. We have to access our name variable, so we'll use a $sign followed by opening and closing brackets, and inside of those brackets, we're now going to access the name variable. Instead of name for the variable, I'm actually going to use first name though, like so. So I'm going to say hello, npc codes. And now maybe I also want to output the age. So you are age years old, like this. I'm going to have an exclamation mark right here, and we're going to end the statement by having a semicolon. I'm going to save this, and you can see we're getting hello npc codes. You're 99 years old. So now we've stored all of the data for a certain user inside of variables, and we use a console.log statement to output that data later on. And even though this is a simple example, you now already know a lot of the stuff in a more minimalistic way that we will later on also use in real apps. Let's now take a look at arrays in JavaScript. And to make it simple, arrays are literally just lists. So I can store all kinds of values inside of an array. So let me show you. Imagine you wanted to store all of the numbers from 0 to 10 inside of a list, for example. You can do so by using an array. So let numbers. You always define an array by just defining a variable the normal way you would do it with any other value as well. So let numbers be equal, and then you define that you want to create an array by using those brackets, so those square brackets. You have opening and closing brackets, and inside of those brackets you then define your values. So maybe all of the numbers from 0 to 10, so 0. You separate each list item by using a comma, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And of course, you also end the statement by using a semicolon. And it's as simple as that to create an array in JavaScript. Now I can also console.log our numbers variable that currently holds our array, like this. And you can see, we see that we have 11 items inside of this array, and we see all of our items, all of our individual array items. I can also expand this array by using this drop-down icon right here, and you can see all of our items are listed right here. And every single item, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, also have corresponding indexes. And if you take a look at this, you also see that the index starts at number 0. So again, in JavaScript, we do not start to count at 1, but instead we start to count at the number 0. So if I want to access an individual item of this array, I could now, for example, use the index of this array, or to be precise, of this item. So if I want to access the first element inside of this array, I have to use numbers of 0. Again, to access an item inside of an array, you use the bracket notation once again. So you start by using the variable name, followed by opening and closing brackets. And inside of those brackets, you now specify the index that you want to access. In our case, we want to access the first element, so 0, that has the index 0. So numbers of 0. I'm going to console.log this, and we're getting 0 in the console. I could also access the item that has index number 4, for example, and we're getting 4. So I think you understand how this works. But arrays are not limited to numbers. We could also store strings, for example, inside of an array. So let fruits, for example, be equal to orange, apple, and banana, like so. And now again, I can console.log my fruits, for example, like this. And now we have an array that consists of fruits, and we can also access those fruits the same way we did before. We have those indices right here once again, so 0, 1, 2. And now if we want to access orange, for example, I could access my fruits of index or at index position 0, and we're getting orange. Fruits of 1 would be apple, and fruits of 2 would be banana, like so. And of course you can also store booleans, so let has high power level be equal to an array, and maybe the first character in our array has a high power level and the other ones are probably kinda weak, like this. So now we also stored a boolean inside of an array. So you can store pretty much all kinds of data types inside of a boolean. And of course we could also access them once again. So has high power level of 0, for example, and of course this will output true. But now something that is cool about JavaScript is that you're not limited to a certain data type inside of an array. There are a lot of programming languages where you have to stick to only booleans, only strings, only numbers, and so on. So an array can only have one single data type. But in JavaScript, that is different. In JavaScript, you can have a couple of different data types. So I could also say, let whatever be equal to an array. And now the first value is probably a string, so maybe Goku. The second one could be a boolean, so true. The third one could be a number, so 101. And I could also store a value like null in here, and so on. So I think you get the idea. And now I can console.log our array, whatever, like so. And you can see we have all of those items again stored inside of this array. And of course, I can also access those individual elements by using the bracket notation once again. So 0, 3, 2, and so on. So I think you understand what this is. So to summarize, arrays are essentially just lists that allow you to store all kinds of data types inside of them. Let's now understand nested arrays. And nested arrays are arrays inside of other arrays. So imagine we have a numbers array. So const numbers, for example, is equal to this array. And inside of this array, we can have other arrays right now. So essentially arrays inside of arrays. So the first array could hold the numbers 1, 2, and 3, for example. The second one could be 4, 5, and 6. And the third one could be 7, 8, and 9, for example, like this. So now this here is the outer array, whereas those ones are the individual elements inside of this array. So first element, second element, and third element, like this. And now I can again access those individual elements the way I would do usually. So let me just console.log numbers. And now I want to access my array right here. And let's imagine I want to access the first element, so this array. In order to do so, I'm going to say numbers of 0, because again, we start counting at number 0. So this here has index number 0, this here has index number 1, and this one has index number 2. So to access the first element inside of this array, we're going to use numbers of 0. I'm going to save this, and we're getting our first array, so 1, 2, and 3 right here. And now imagine I wanted to access this element right here, so maybe the number 2. In order to do so, I can again just use an index after this index right here. So I'm just going to use another index, and this one has index position 0, index position 1. So I'm going to access index position 1, like so, and now I'm getting number 2. If I wanted to get 6, for example, I would have to access index position 0, 1. So index position 1 right here. And right inside of this array, it would be 0, 1, 2. So I have to access 1, 2 essentially. And this is a multi-dimensional array. And of course, you could also have arrays inside of arrays inside of arrays. So this here could also be 0.1, 0.2, 0.3, like this. Now I could duplicate this and have 0.4, 0.5, 0.6, 0.9, 0.8, 0.7. Now I could, for example, access number 0, so 0, number 1, for example, like this. And now I will get this array. And now number 1 again, for example, like this. And now we're getting 0.5. So this is a multi-dimensional array. And of course, as always, you can store all kinds of things inside of this array. This here could also be a stuff array, for example, or let's say things, for example. And now we are having numbers. We can also have booleans. We can also have an orange as a string, for example, and maybe an apple as a string. And now, of course, we need to access things of 0, 1, 1, which would be false. And we can also access 0 to 2, for example. So let's do this, which should be apple. We're getting apple, and so on. So I think you get the idea. You can create multi-dimensional arrays by just using arrays inside of arrays. And it's up to you how many arrays you nest inside of other arrays. So to summarize, nested arrays are just arrays inside of other arrays. Let's now take a look at the important array functions. And array functions allow you to manipulate arrays or get more information about a certain array. So let's start by creating a simple array. And maybe we want to create an array that consists of all of our favorite characters, for example. So right here, we might have something like Goku, maybe Jin Woo, Ruffy or Luffy, whatever you call it, and so on. So I think you get the idea. And now maybe I want to get the length of my array. So how many items does this array include? And I can do so by console.logging characters, so my array name, so the name of my variable, dot length. And you can see length is a property again. So we exit it without brackets, like so. I'm going to save this. And you can see we get the number 3 because currently we have 3 items inside of our array. So 1, 2, 3. We are also able to push elements to the end of our array. So essentially to add elements to this array. So maybe we define this array right here. We output the length, but later on we probably decide that we want to add a certain character. In order to do so, we can use our variable name, so characters, dot, and now we can access a certain method to push an element to the end of this array. And that is the push method right here. Again, this here is a method, so we need to use brackets right here. And now we can just define as a string an item that we want to add to the end of our array. And maybe that one is going to be Vegeta, like so. I'm going to end the statement by using a semicolon. I'm going to save this. And now I'm going to console.log my characters array once again. And if you take a look at it, we now have 4 items inside of it. So we have Goku, Jinwoo, Luffy, and Vegeta. Our length, as you can see right here, is also 4. We're outputting the length right here before adding the character to the end. Therefore, length right here is 3. And if I'm going to console.log characters.length right afterwards, it is 4, because now we have 4 items inside of this array. Let me delete all of this. And now we can also add an item to the beginning of an array. In order to do so, we can again use the variable name. And instead of push, we are now going to use unshift, like so. And now again we have to add our item as a string inside of the brackets. And maybe I want to have the character. I'm not really creative, so I'm just going to use Piccolo. I don't even know if that is written properly, but I think you get the idea. I'm going to save this. I'm again going to console.log my characters array. And now we have Piccolo at position number 0, so index number 0. So we can use unshift to add an item to the beginning. And we can use push to add an item to the end. So this here could again be Vegeta, like so. Now we have this array right here. So Piccolo, Goku, Jinwoo, Luffy, and Vegeta. Now we can also remove an item from the end or an item from the beginning. To remove an item from the beginning, we are just going to use the characters.shift method. So instead of using unshift to add an item to the beginning, we use shift to remove an item from the beginning. Right here, we do not need to specify anything inside of the brackets because we are just removing the first item. So there's not really anything we need to specify. And now you can see Piccolo is gone. So now we only have 4 items inside of this array at this point. To remove an item from the end, we are going to use the pop method. So characters.pop, like so. And this will now remove the last item. In our case, this will be Vegeta. I'm going to save this. And you can see again, we now have 3 items inside of this array. So Goku, Jinwoo, and Luffy. And Piccolo and Vegeta are now gone. So to summarize those methods, unshift adds an item to the beginning of an array. Push adds an item to the end of an array. Shift removes an item from the beginning of an array. And pop removes an item from the end of an array. Now we can get rid of them. And maybe we want to know if our array includes a certain item, for example. In order to do so, we can console.log the result of characters.includes. Again, this is a method, and this method expects a search element. So what are we looking for? Maybe we are looking for Luffy, like so. I'm going to save this, and we're getting true in the console because obviously our characters array includes the item Luffy. If I would now say this here is Ruffy, for example, we're getting false because Ruffy, of course, isn't Luffy. So I think you get the idea. The includes method just checks whether an array has a certain item or not, and then returns a boolean, so true or false. We can also find the index of a certain item by using the .indexOf method right here. Again, opening and closing brackets. And now we need to define a search element once again. Let's use Jinwoo this time, like this. And we're getting 1, because the index position of Jinwoo is 1. So 0, 1. If I'm going to enter Luffy, for example, we would get 2. And if I would enter some random stuff, we would get -1. So -1 pretty much says that this item is not inside of this array, so it doesn't exist. Now, we've previously already seen that you can turn a string, for example, into an array. So if we have the string, for example, let text be equal to hello guys, how are you? Then I can turn this string into an array by saying text dot split. And now I have to define a splitter right here. This could be, again, a space, for example, like this. I'm going to save this. And now let me just console.log the result of text.split, for example, like so. And you can see we're getting an array that includes all of our individual words splitted every time we have a space, essentially. So here, 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 and so on. So I think you get the idea. So by doing so, we can turn a text into an array. But it also works from array to text. So we can also turn this characters array into a text. In order to do so, we can use, again, the variable name characters dot, and now we can use the join method, like so, for example. And as a separator, we are going to use a spacebar, for example, like so. And now we're getting our individual items as plain text separated by a spacebar. Of course, I could also use a comma, spacebar, and now it would look like this. So you can either turn a text into an array, or you can turn an array into a text. We can also reverse the order of an array by using .reverse, like this. And this will now output this right here. So now we have the reversed order. So instead of Goku, Jinwoo, Luffy, we have Luffy, Jinwoo, Goku. And we can also use the slice method to get a certain part of an array. Right here, you have to define a starting number, an ending number, and that's about it. Maybe we want to only extract Goku and Jinwoo right here. So we're going to start at index number 0, like this. And we want to go up to index number 1, 2. Why am I specifying 2? Because the last index, so the ending index, is excluded. So the starting index is included. This item will be included. This one will be included because this one has index number 1. And this one has index number 2. We're going up to index number 2. Index number 2, so the ending number, will be excluded though. So this item will not be part of the sliced version. And therefore we will only get Goku and Jinwoo, as you can see. If I would say 0 to 1, for example, we would not see Jinwoo because, again, the item that is on the position of the ending index will always be excluded. So that is something that you have to remember. And now let me also show you how to change the value of an item at a certain position. Maybe I want to change Goku to something else. In order to do so, I can use bracket notation like this. So now I'm accessing characters at index position number 0, so Goku, and I can just say that characters of 0 is going to be equal to Goku. Maybe I just have a couple more U's, like this. I'm going to save this. I'm going to console.log our characters right here. And now you can see we have Goku with 3 U's and Jinwoo and Luffy. I could, of course, also completely change it. So characters of 1 is, for example, equal to Buggy, for example, like this. And now I'm having Goku, Buggy, and Luffy. And those were the most important array functions to manipulate arrays. And again, you don't have to remember all of them. The important thing is that you really understand what an array is and how it works. So to summarize, an array function allows you to manipulate an array or get more information about it. Let me now introduce you to functions. And functions let us reuse code. So we use functions whenever we want to do a certain task multiple times and we don't want to type it out over and over again. So let me show you. Imagine we wanted to greet a dumb user, for example. So we could say console.log, hey, NPC, you are dumb for whatever reason. So that might make sense. And now in the console, we are getting, hey, NPC, you are dumb. And now maybe I want to split this into 2 lines. So I'm going to say, hey, NPC, console.log, you are dumb, like so, for example. And now afterwards, maybe I also want to have a console.log statement that says your IQ is below 50. This could be everything I want to output. But now maybe every time NPC, for example, in a real world, accesses a page on our website, I want to say the exact same thing. So I want to greet him essentially. So every time I wanted to do that, I would have to copy those lines and paste them to the position where I want to execute this code, like so. And at a certain point, you can see that this here is not really the best way to write code, because I'm simply copy and pasting this over and over again. And if I now wanted to change the name, for example, so NPC codes right here, I would have to change it over and over again. So at every single position. And not only does this get really repetitive, but this also increases the amount of errors that occur on your page drastically. Because of course, a normal developer, so a normal human, will for example miss to correct an error at a certain position and so on. So this is a terrible way of writing code. And by using functions, we can only define this code here once, and then we can use it over and over again. Let me show you. You define a function by first of all using the function keyword. After the function keyword, we have to define a name for our function. This name can be pretty much anything we like, so we can just make up anything. This could be greet dumb user, for example. Again, it might make sense to use descriptive names. And since we want to greet a dumb user, this might be pretty descriptive. Again, we are also using camel case right here. So the first letter is lowercase and every new word starts with a capital letter, like so. Now you have those opening and closing brackets right here. Those ones are responsible for parameters, but we'll get to them later on. So they're not that important at the moment. And now you have opening and closing curly braces, like so. And inside of those braces, you essentially define what your function should do. So now let me write something in between those brackets right here. I'm going to copy this code and I'm just going to paste it in here like this. And now this here is our function definition. So function keyword followed by the name definition, followed by those brackets that are responsible for our parameters later on, and the function body that includes all of the code that we want to execute when calling this function. How can we call a function? We can now call this function by using the function name followed by brackets. Without calling the function, you see, even though I saved this, we're not seeing anything in the console. Because right here, we're only declaring the function. We're not executing the function yet. To execute the function, we call it by again using the function name, so greet dumb user. Now I'm going to use opening and closing brackets, and I end the statement by using a semicolon, like so. I'm going to save this, and now you can see in the console, I'm getting, hey, NPC codes, you're dumb, your IQ is below 50. And if I now wanted to do the exact same, once again, for example, I could just copy this line, paste it in, and do the exact same again. And now I only have to use this single line of code to execute this function over and over again, as you can see. And this here is a much cleaner way than before. Because now, if I wanted to go from NPC, for example, so from NPC code to NPC, I can just do it like this, and you can see everything changed at once. So hey NPC, and so on. I could also change the IQ, of course, to below 40, and so on. But at the moment, this is still pretty static. Maybe I also want to have the username or the user dynamically, because maybe I want to use this greet dumb user function for a lot of users, because maybe a lot of users are pretty dumb, and not only the NPC. And in order to do so, we can use parameters. And parameters are somewhat similar to variables. there are also placeholders that will get filled once we call the function. Let me show you, because that is probably easier. So right here, I can just define a parameter by typing out the parameter name. And again, the parameter name is up to us. So I can make pretty much anything up. This here would be valid. This here would be valid. But again, it makes sense to use descriptive ones. So I could also say username. And now I can say, hey, plus username. So I can use this here like a normal variable essentially. And I'm going to save this like so. I'm again going to call the greet dump user function. But this time, instead of those brackets, I need to define a specific value for our username. So this could be NPC, for example, like so. And again, we're getting, hey, NPC, your dump, your IQ is below 40. Of course, I can also turn this here into template literals. So hello, username, for example, and this works as well. So this here is pretty similar to a variable. The only difference is pretty much that it's inside of a function. So you define a placeholder, and when executing the function, you essentially fill this placeholder with a specific value, and then you use this value to execute this body right here. And now I could use the exact same function, so greet dump user, but I could greet another dump user. So maybe Jonas is also pretty dump. And now we're getting hello NPC, you're dump, hello Jonas, you're dump. And I can use this for pretty much anyone I like. But I'm not limited to one single parameter. I could also use multiple parameters of different types. So now at this point we're getting a string. I could also use this as a number though. Let me show you. So let me delete this. And this here works also for a number, for example. So hello 40, you're dump. So I can use pretty much anything at this point in time. But now we can also accept multiple parameters. So I could also say that I want to get an IQ, for example. And now I'm going to replace this line. And I'm instead going to say, your IQ is at around IQ. So now I'm defining an IQ right here. And now I can also define a second argument right here. So I could say NPC has an IQ of 40 and Jonas has an IQ of 39, like so. And now we're getting hello NPC, your IQ is at around 40. Hello Jonas, your IQ is at around 39. So you can define as many parameters right here as you like. And if you have them right here, you call them parameters. If you have them right here, you call them arguments. And actually, this is just a naming convention. It's not really that important to know the difference. But when you declare it essentially, so right here in the function declaration, you call it a parameter. And when you use the specific value for a parameter, so you assign the value to the parameter, then it's called an argument. So in here, it's an argument. In here, it's a parameter. So it's as simple as that. But that is, in my opinion, not that important. As long as it works, it works. And of course, this here is not limited to greeting a dump user. You could also use this to do math calculations, for example. So I could add numbers, for example. Let's imagine we have num1, num2, and now we just want to console.log num1 plus num2. Also pretty simple example, but probably a little bit more likely than the previous one. And now I can just call add number or add numbers. And I can add two numbers, so maybe 10 and 20, and I'm getting 30. And I can also add 100 to 20, and I'm getting 120. So now I can use the exact same logic, but with different arguments, so different values. And I get a different result depending on the arguments that I'm using. So to summarize, a function just lets us reuse code and therefore reduce redundant code. Let's now understand the return keyword. And return sends a value back from a function. Let me show you what I mean by this. Imagine, again, we have a function that calculates the sum, for example. And maybe the sum of a number 1 and a number 2, like so. And now, up to this point, we always console.log the sum, essentially. So num1 plus num2. And then we would call this function like so, and maybe pass an argument 1 and a second argument to this function, and then we would execute this function. So now we're console.logging 40. But what if we wanted to store this value inside of a variable, for example? So let sum or calculated sum be equal to sum of 10 and 40, for example. And later on, we maybe want to use this calculated sum for something else. Now, if I'm going to do this, this is not really going to work because we're just going to console.log this, but console.logging this will not store the value inside of this calculated sum variable. Let me show you. I'm going to console.log our calculated sum, and you can see we're getting undefined. So we're calling our sum function right here. This sum function will console.log num1 plus num2, so it will output 50 first right here. And afterwards, I'm console.logging calculated sum, so the variable, and the variable is still undefined because right here, we only console.log the number, the sum to be precise, but we were not able to store this number. And in order to do so, we have to use the return keyword because the return keyword sends the value back from a function. So we're sending this value back by using return right here of num1 plus num2. And now we're returning the value of this addition and we're returning it to this calculated sum variable. And now I'm going to console.log the calculated sum. And as you can see, the calculated sum is now 50. So now we were able to successfully store this value, so the sum, inside of our variable. So return essentially just returns a value to whoever calls this function. And this is really useful when storing values inside of a variable, for example. So most of the times, you will use the return keyword and not a console.log statement. A console.log statement is primarily there for testing and debugging your code. But in real applications, you will more often use the return keyword. Let's now understand default values. And default values are used when no argument is passed to a function. Let me show you what I mean by this. Imagine we have the function greetUser, for example. And right here, we're expecting to get a parameter, for example, a username, like this. And now, instead of this function, we're just going to console.log, let's use backtick characters, and let's say, hello. We're going to access our username variable like this, and we're essentially saying hello followed by the username. So we're greeting the user. So let's call this function by using greetUser right here once again. And for now, let me pass NPC. I'm going to save this, and in the console, we're now seeing hello NPC. But what would happen if I would actually not pass an argument at all? So right here, we're essentially expecting to get this as a parameter, but since I'm not passing any value as an argument, we are seeing hello undefined. So isn't there a way to use a default value in case the user, so in case we do not pass an argument right here? And in order to do so, we can just use an equal sign, and then we can assign any value right here. So I could say guest, for example. And now, if I'm going to execute the same function, we're getting hello guest in the console. And of course, if I also have something like you are age years, so age years old, I can also have a default value for age. So first of all, I of course need to accept the age as a parameter. And now I can also assign a default value of 100, for example. I'm going to save this. And at the moment, we're getting, hello guest, you are 100 years old. But of course, I can also define or specifically define a value. So once I say NPC right here, for example, we're getting, instead of hello guest, hello NPC, you're 100 years old. And I can also override the default value for age. So maybe I'm 10 years old. And now I'm getting hello NPC, you're 10 years old. So this is how this works. You can always define a default value. You will use this default value if no argument is specified. But once you specify an argument for the corresponding parameter, you will use the specified argument instead. So to summarize, default values are used when no argument is passed to a function. Let's now have another practice project, and let's try to generate a random quote generator. So first of all, we need to have a way to store all of our quotes somewhere. And in order to do so, I will create an array. So quotes, for example. Instead of this array, I'm going to store all of my quotes. So the first one, I don't know, I don't really know any quotes. So I'm just going to use something like, this is the first quote, this is the second quote, and let me just add 2 more, like so. And this here is going to be the third quote and the fourth, like so. So now we have 4 quotes, but now we somehow need to be able to access one of those quotes. And it should be random, but for now, let's focus on accessing those quotes. And if you remember, we can access one of those elements by using the bracket syntax. So we could, for example, access quotes of 0, and we would get this element. We could access quotes of 1, and we would get this element. We could access quotes of 2, and we would get this one, and quotes of 3, and we would get this one. So we somehow need to be able to get a random number, ideally, between 0 and the length of our array. So let me for now console.log quotes.length. So this array function essentially calculates or gets us the length of this array. I'm going to save this, and we're getting 4. We need to get a number between 0 and 3. So now I want to get a random number. So let me have a variable let random number be equal to, and if you remember correctly from our math section, you can get a random number by using math.random, like so. Let me for now console.log our random number, and you can see we're getting 0.9. But now I want to have a number between 0 and 3. So if you remember from the previous lectures, if I calculate it or multiply it by 100, we will get a number between 0 and 100. So now I can also just multiply it by the length of our quotes, like so. And now I have to subtract 1 from the length because we want to get a number between 0 and 3, like so. Now let me save this. And you can see for the number, we are now getting 1.5, 0.7, 2.9, 2.6, 1, 2, 2, and I think you get the idea. And now we somehow need to round this. So we can just take all of this right here and use math.round and round whatever we have inside of those brackets. So we're going to round math.random times quote.length minus 1. I'm going to save this. And now let me delete this here. We're getting a number between 0 and 3. So 1, 1, 2, 1, 1, 2, 3, and so on. So I think you get the idea. And now we can use this random number to get a random quote. So we can just access our quotes of random number, for example, like this. And now we are having, this is the third quote, this is the third quote, second quote, third quote, first quote, and so on. So I think you understand how this works. And that is how you can create a random quote generator inside of JavaScript. Let's now understand arrow functions. And arrow functions are just a shorter way to write functions. So imagine we have a function that is responsible for greeting the user. So function greet user. We are getting the username, and inside of the function body, we're just going to console.log hello username, for example, like so. So this would be the normal function syntax. But now, as mentioned, you can do the exact same by using an arrow function, and it's just a shorter way to do the exact same. Usually, you store the arrow function inside of a variable. So const greet user arrow, for example, for now. And this is going to be the function name. So the variable name will be the function name essentially. And that is going to be equal. And now for an arrow function, you have this syntax right here. So you have the parameters right here. So instead of having them here, you just have them here. So I could have my username right here. Then you have this arrow right here. That's also why you call it arrow function. And then you have the method body. So it's just a different syntax essentially. How it works is pretty much the exact same. And instead of this body right here, I can now also console.log something like hello username, for example. And now I can also call this greet user arrow function the same way I would call a normal function. So I would say greet user arrow like so. And then I would insert my argument right here. So maybe NPC like this. And now I'm getting hello NPC inside of the console. And this would be similar for the normal function. So greet user, maybe NPC codes for greet user. And we're getting hello NPC codes, hello NPC. So an arrow function does pretty much the exact same. The syntax is just a little bit different. And from time to time, this here can be kind of beneficial. So imagine we wanted to have a function that calculates the sum again for num1 and num2. And we just want to return num1 plus num2, like so. Now I'm going to have const num or sum calculated, which is equal to our sum of maybe 10 and 20. If I'm now going to console.log our sum calculated, you can see that we are getting 30 in the console. How could we write the exact same by using an arrow function now? We can do so by saying const sum arrow, for example, is equal to those brackets. We again have a num1 and a num2, and we want to calculate num1 plus num2. If I now only have a single line, the benefit of using an arrow function is that you can also write it into a single line, and you don't even need to use those brackets right here. So you can just write it like this. And when you have a single line like this arrow right here will also automatically return whatever we have to the right. So this here will be returned automatically without having to explicitly write the return keyword. So this is not necessary. Let me show you. I can now have const sum calculated, and instead of using my sum function, I'm going to use my sum arrow function, and we're still getting 30 in the console. So now we're having the exact same result with one single line of code compared to right here 3 lines of code. So this here is just a shorter and more efficient way to write the exact same code essentially, or to be precise, to write the exact same functionality. And this here is just one scenario. You will use arrow functions a lot, especially when we get to callback functions. But for now, just remember, you can use a normal function and you can use an arrow function right here. And that is all you need to know about arrow functions. Let's now understand if statements in JavaScript. And if statements run only if a condition is true. If the condition is not true, they are not going to run. And I think it's easiest to understand when I show it to you. Imagine we have a variable age, for example. And age can be equal to, let's say, 10 for now. Now, we only want to allow a user to enter the page if the age is at least 18. And this already explains how an if statement works. If the age is greater than 18, then we want to allow the user to access the page. Otherwise, we don't want to allow the user to access the page. And this is exactly how it works in JavaScript. If something is true, in our case, if the age is greater than 18, then we do something, and otherwise, we do something else. So let me show you. If age greater 18, like so, then do something, else do something else. So that is the structure that we want to recreate in JavaScript. And in JavaScript, you use an if statement by using the if keyword. Then you have brackets, and inside of those brackets, you have a condition. And then again, you have a body. And inside of this body, you define what you want to do. So that is the basic structure in JavaScript. So first off, after the if keyword, we have to define the condition inside of those brackets. And the condition in our case is that the age should be greater or equal to 18. And if that is the case, so if this condition is equal to true, then we want to execute whatever we define within those brackets. And in our case, let's just console.log you can enter, like so. So this has been this block right here. If the age is greater than 18, we're going to let the user in. Else, so now we're going to use the else keyword. Right here, we do not need a condition, because if this condition is false, this here is obviously the only condition left that's possible. So else, we're going to do something else. And we're going to do whatever we define within this body right here. In our case, we're going to console.log you cannot enter kid, like so. And now we're getting you cannot enter kid because our age is currently 10. If the age would now be 18 at least though, you would see you can enter. But now let's add a second condition. For example, the person can only enter if he's at least 18 but below 50, because if he is above 50, he's probably too old. And under those circumstances, we can also say, or we can add an else if condition. So else if the age is, for example, greater than 50, do something else. So when using an if statement, you first of all want to have all of the conditions. If condition 1 is not true, then we're going to check for the second condition. If condition 2 is not true, then we could also add as many else if blocks as we like. So we could check for a third condition, fourth condition, and so on. And if all of those conditions do not meet essentially, then we're going to do whatever we have defined in the else block. So the else block gets executed if all of the conditions we are checking for are false. So let's now add the else if block. So else if, we again need to define a condition. Every time we have to define a condition, we use those brackets right here. And now we want to check whether the age is less than 50. So 49 essentially is the maximum. And now we need this block right here again that defines what we want to do if this condition becomes true. And if that is the case, then I want to console.log you cannot enter kid, like so. And at the moment, you can enter 49, you can enter 50, you can enter, which is of course wrong. This here needs to be greater than 50, so that was my bad. Greater or equal to 50 to be precise. And now you can already see a problem of if, else if statements and else statements. So right here, when writing them, you really have to check which condition should become, or which condition should be checked first. If you first of all check if the age is greater or equal to 18, this here obviously immediately becomes true. So we are never going to check for the second condition. And that is important to know about if, else statements. Once the first condition is evaluated to true, we will never check for any of the other conditions. And therefore, it makes sense to have the conditions ordered in the right order essentially. So it might make more sense to first of all check if the age is less than 18, like so. If that is the case, then we're not 18 yet, and we want to console.log you cannot enter kid. If this condition is false, then he is at least 18. So let's take a look at this. You cannot enter kid. And if this condition is false, then of course the user is at least 18. So next up, we should check for the next condition that will prevent our user from entering. So we're going to use else if. Now we're going to check if the age is greater than 50, because that is the second condition that prevents our user from entering. And now we're going to check, or we are going to output console.log you cannot enter bro, like this. And now we're getting you cannot enter kid because he is still a kid. If I'm going to use 40, we are not getting anything. And if I'm going to use 50 though, let's say 51, because we need to be greater than 50 at this point, we're getting you cannot enter bro. And if this condition is false, so if he is not less than 18 and he's not greater than 50, so he's essentially between 18 and 50, then we can output console.log you can enter like this. And now let's have a person that has an age of maybe 49. And now he can enter. If he is less than 18 though, or above 50, he cannot enter. So when writing an if statement, the order is always important. And that is something that is really, really important. So to summarize, you always have an if statement that checks for a condition. You can add as many else if statements to check for as many conditions as necessary. And then you can also use an else statement to define something that should happen if none of the if or else if blocks evaluate to true. So this is essentially the fallback if everything is false. And those were the basics about if statements in JavaScript. Let's take a look at comparison operators. And comparison operators compare two values. They are especially important when working with an if statement, for example, or loops, for example, but we will get to loops later on. For now, let's first of all take a look at comparison operators. And in order to do so, let me just console.log the result of 10 greater 5, for example, like so. I'll end this by using a semicolon, and in the console, we're getting true. And this right here is what you call a comparison operator, because it essentially compares two values. It compares the value to the left to the value to the right. And if the value to the left is greater than the value to the right, this will be equal to true. Otherwise, this will be equal to false, as you can see. And there exist a couple of different comparison operators. So let me introduce you to all of them. So the first one is greater than. Now, there also exists greater or equal to. And now, this of course is also true. But if I would check if 10 is greater than 10, for example, this would be false. But if I would check if 10 is greater or equal to 10, this will of course be true because it's equal to 10. Now you can of course do the exact same by using the less than operator. So is 10 less than 20, for example, like so. Of course, this is also true. And I can also check whether 10 is less than or equal to 20. And of course, this is also true. But if I would now check if 20 is less or equal to 20, this would still be true. But if right here I use 20 is less than 20, then I'm getting of course false, because 20 is not less than 20, it's equal to 20. You can also check for equality. Let me show you. So we can check whether 10 is equal to 10. So you use two equal signs to check for equality. One equal sign is the assignment operator. So you use that one to assign a value to a variable, for example. And two equal signs is the comparison operator. So this one compares two values. And if those values are equal, then we're going to get true in the console. And as you can see, we do get true in the console. I can also check whether 10, so the number 10, is equal to the string 10, so to the text 10. I'm going to save this. We are still getting true. Let me now use three equal signs. And now we are getting false. If I would check whether 10 is equal to the number 10 though, I'm going to get true again. And the reason for this is that this here is the equality comparison operator, and this one checks for strict equality. So when using two equal signs, it's only important that the value is the same. And the data type doesn't matter. So it doesn't matter whether this here is a number or a string. Two equal signs will only check whether the value is the same. Once you use three equal signs though, this is the strict equality operator, and this one checks whether values are equal and data types are equal. And right here the value is equal, so 10 and 10, but the data type of number is not equal to the data type of string. Therefore, we are getting false in the console. There also exists not equal. Let me show you. So we can check whether 10 is not equal to 10. Not equal will be expressed by using this exclamation mark followed by an equal sign, like so. I'm going to save this. And you can see we're getting false because 10 is equal to 10, If I'm going to have 11 right here though, we are getting true, because now 10 is not equal to 11. So this equals true right now. Again, we can also do something like this, and we can now use a different data type. We're again getting false, because 10 is equal to 10 when only using a single equal sign right here. But once we use two equal signs, we're again getting true, because the number 10 is not equal to the string 10, because now again the data type is different. So the same principle we had before when using two equal signs and three equal signs. And now you oftentimes, as already mentioned, use those comparison operators inside of if statements, for example. So if, for example, a value, so for example the value 100, is greater than the value 50, then you want to do something. And of course, this is not the best example. Oftentimes you will have a variable like age, for example, and so on, that you will compare to another value, but I think you get the idea. You will use those comparison operators a lot combined with if statements. And that is the most important stuff that you need to know about comparison operators. So to summarize, you use comparison operators to compare two values. And this comparison will then execute to either true or false. Let's now understand logical operators. And logical operators combine multiple conditions. What do I mean by that? Let me show you. In order to do so, let's for example have a variable, and let's say this variable is fast, for example. And that one is going to be equal to true. And that one essentially says whether a person is a fast runner, for example, or a slow runner. And if he is fast, of course, is going to be true. Now we can also have the variable let is strong be equal to true, for example. And now if a person is fast and is strong, is fast is going to be true and is strong is going to be true. If a person is only fast but not strong, then is fast is going to be true and is strong is going to be false. And now I can, for example, use an if statement and check if fast is equal to true, for example. And by using logical operators, I can now combine multiple conditions. So I can check if is fast is equal to true and is strong is equal to false or true, for example. And if those conditions are both true, then we can, for example, console.log you are fast and strong, like so. At the moment, we are not seeing anything because a strong is false. So I'm going to say a strong is true. And now in the console, you can see you are fast and strong. And this here is a logical operator. And in fact, this is the logical AND operator. This combines two conditions. And this here, so this entire expression is only going to be true if condition 1 and condition 2 is true. And of course, we could also use AND once again right here. And now we could also say let is smart be equal to true. And now we could check if is smart, like so, is also equal to true. And if all of those conditions are true, then we're going to consider log you're fast and strong and smart, for example. And if one of those conditions is false, this expression will not be equal to true anymore. So this entire expression will then be false. So by using the logical AND, and let me delete this here, like so. So by using the logical AND operator, you can combine multiple conditions that will only be equal to true if all of the individual conditions are equal to true. So this has to be true and this has to be true. Now, something that you can do in general is just get rid of this equal sign and this equal sign. And now this here is equivalent to saying is fast is true and is strong is true. So if he is fast and he is strong, then he is fast and strong, or we're going to consider log that. And if you take a look at this, if you write your code in a good and clean way, it's pretty much like reading normal English. If is fast and is strong, you are fast and strong. And let's get rid of the and smart, like this. So even a person who can't code would probably understand what this here means. And that is how you really write clean and descriptive code. Nevertheless, there exist a couple more logical operators. Another logical operator would be the OR operator, and you write it like this. So this is the logical OR operator. And now, if a person is fast or a person is strong, we're going to say you're fast or strong, like so. And this is also pretty self-explanatory, I would say, because if a person is either the first condition or the second condition, then this is going to be true. So this entire expression will then be true. If he is not fast and he's not strong, then of course this is going to be false. So if one of those conditions is false, essentially, you're fast or strong is still going to be true, because only one of those things need to be true. He only needs to be fast or strong for this entire expression to be true. If both of those conditions are false though, like so, then he's not fast and he's not strong, and therefore is fast or is strong is false, and we're not seeing anything in the console anymore. So when using the logical AND, both of those conditions need to be true. When using the logical OR, only one of those conditions need to be true for the entire condition to become true. And there also exists the logical NOT operator, and that one can be used by just using an exclamation mark, like so. And now this can be read as if not fast, then we are going to console log you are not fast, for example. And now you're not fast because is fast is false. So by using this exclamation mark, we're saying if this condition right here is false, then this entire condition is going to be equal to true. So this here essentially just inverts the value. So false will become true and true will become false. And those ones were the most important logical operators in JavaScript. So to summarize, you can use logical operators to combine multiple conditions or negate an existing one. Let's now understand switch statements. And switch statements run different code based on different values. They are somewhat similar to if statements, and you can write a lot of if statements using a switch statement. Let me show you. Imagine we're having a day, for example. So let day be equal to Monday, for example. So currently it's Monday. And depending on the day, we, for example, want to output a different message to a user. In order to do so, we can, for example, say if day is equal to Monday, and if that is the case, then I'm going to console.log hey bro, like so. Else if day is equal to Tuesday, for example, then I might have a bad day and I'm going to say you are dumb, bro, like so. So I think you get the idea. And now I can do the exact same for pretty much every single weekday, like this and like this. And now I'm having Monday, Tuesday, Wednesday, Thursday, Friday, and let's keep it like this. So I think you get the idea. And maybe else I'm just going to console.log, whatever, doesn't matter. And now I could have a couple of different sentences here, like you are slow, bro, you are big, you are, or I don't care. I think you get the idea. But writing all of this out is kind of repetitive, to be honest. And under those circumstances, a switch statement might make more sense. When writing a switch statement, you use the switch keyword like so, and inside of those brackets, you then have the expression. In our case, the expression is going to be the day, like so. After those brackets, we are going to have a body once again, and inside of this body, we're going to define all of the cases. And it's really good for something like the day, for example, where you have a lot of different cases. It could also be good for grades, for example, where you also have different grades, for example. So maybe A, B, C, D, E, and so on. So you have a case A, B, C, or under those circumstances, we have a case Monday, Tuesday, Wednesday, Thursday, Friday, and so on. So we define different cases inside of a switch statement. So you always have the case keyword, and afterwards you define a case. In our case, it's case Monday, for example. And now afterwards, we're going to have a colon right here. And now we can just say console.log hey bro, for example. Doesn't matter. And now let me delete this if statement for now, because we do not really need it. And now we can define all of our cases. So case Tuesday, I'm going to console.log it's Tuesday. It doesn't matter, to be honest. Like this. And of course, this here needs to be in quotation marks. Now I'm going to add case Wednesday with a capital W. And I'm going to console.log it's Wednesday, my dudes. Like so. And I think you get the idea. I can just copy and paste this for all of the other days. So maybe Thursday and Friday. And now it's Thursday and it's Friday. Like so. At the moment, you can see that we're having the day Monday and we're getting, hey bro, it's Tuesday, Wednesday, Thursday, Friday, and so on. So even though we should stop after Monday, we're getting all of them. And the reason for this is that it's going to check at the first condition, it's going to execute this one, and afterwards, it's just going on to the next condition, so to the next cases. And in order to prevent this from happening, we want to check, and once a condition becomes true, we want to break out of this loop essentially. So we don't want to check anything else after executing this console.log statement. So usually, under most circumstances, you always want to add a break statement after every single condition to break out of this switch statement, essentially. Because without this break statement, we're just going to keep executing. But once a condition, or a case to be precise, becomes true, we don't want to keep executing or keep checking for anything else. We just want to break out of this switch statement. And now we're only getting hey bro. If I would have Wednesday though, we would now get it's Wednesday, my dudes. And of course, if we have some random stuff like this, we're not getting anything. And for those circumstances, we can use a default case. The default case will always be executed if nothing else matches the pattern. So please enter something valid, for example. And now we are seeing please enter something valid because we have just a random string. So let's have Tuesday again, and you can see now we're getting it's Tuesday. So to summarize, you always start a switch statement by using a switch. Inside of those brackets, you then have the case that you're checking for, in our case the day, and within this body, you're defining all of your cases. So you can define a case for every single possible value. So a case for Monday, Tuesday, and so on. Afterwards, after a colon, you define what you want to do under those circumstances. So when this case becomes true, and afterwards, most of the times you break out of this switch statement. Because most of the times you only want to execute one single case. And when this case becomes true, you don't want to execute the other cases. In case you want to execute other cases afterwards, you can remove the break statement, and then you will also execute the next one. So if I would have Monday right here, we would execute Monday and Tuesday, because after Tuesday, we are breaking out. So the break keyword is really important most of the times. If none of those cases becomes true, similar to an else statement when using if statements, you can also define a default case. And this default case will always be executed if none of the cases is true, essentially. And that is how you can use a switch statement in JavaScript. So a switch statement can often be a good alternative to if-else statements. And again, another alternative would, for example, be a switch statement for grades. So if you have a grade A, B, C, D, you could also use it in a similar way. So switch, grade, and now we could check for grade A, B, C, D, or E, for example. And now we could just say great, good, okay, bad, you are dumb. And now we're getting great because we have an A, we have an E, we are getting your dump, and if we have a random letter, please enter something valid. So I think you get the idea. The switch statement is great if you just have a variable that accepts a couple of different values. Let's take a look at the ternary operator. And the ternary operator is just a short if-else statement. So let's take a look at the following example. Again, we have an age, and our age can, for example, be equal to 15. Now we want to check if our age is greater than 18. If that is the case, then we want to console.log you can enter like this. And let's check whether the person is greater or equal to 18. And if he is not greater or equal to 18, then we are going to console.log you cannot enter. And now you can see that we are writing probably 5 lines of code for a pretty simple task. In order to change that, we can also use a ternary operator. We can store the result inside of a variable, so let result be equal. And now we can check whether age is greater than 15. When using the ternary operator, you first always have your condition, then you have a question mark like so. And after this question mark, you will define what you want to do if this here is going to be true. So if this expression is going to be equal to true. In our case, we want to return true or store the value true inside of the result variable. Then you usually use a colon. And after this colon, you essentially define what you want to do if this expression here is not equal to true. So if this expression is equal to false. In our case, we want to store the value false in the result variable, like so. And now let me just console.log the result for you. And you can see we're getting false. Because at the moment, age is not greater than 15. And let's say greater or equal to 18, because this makes more sense. So at the moment, we are 15, so we are not older than 18, or at least 18, and therefore result is false. If I'm now going to say I'm 18 though, we are getting true. So you see, we were able to write this long if statement inside a single line. And that's the power of using a ternary operator. Of course, you can also stack a couple of conditions by using a ternary operator, but this can also get kind of confusing pretty quickly. So for example, if our age is greater or equal to 18, so if that is the case, then we're at least 18. And under those circumstances, we could now also check if our age is less than 50, for example. And right here, we could have another ternary operator. So I could again use a question mark. And I could say, under those circumstances, we are again going to return true. Otherwise, we are going to return false, like so. And we need those brackets for a second statement that VS Code added automatically for me. So now, if the age is greater or equal to 18, and our age is less than 50, so we're essentially between 18 and 50 years old, then we're going to return true. Otherwise, we're going to return false. Of course, I need to console.log the result again, like so. And we're getting true in the console because we are at least 18, but not 50 yet. If I'm going to say I'm 50 though, we're getting false because now we are 18, but we're not less than 50 essentially. So we have an age of 50 already. But as you can see, this here can look, to some people at least, a little bit confusing. And of course, it's also a matter of practice, but at a certain point, it is probably more readable to use if-else statements. But that's of course also personal preference. You can use whatever you like. And this is definitely the shorter way to write it. But again, for some people, probably also the more confusing way. Of course, you could add another ternary operator right here or right here. So that is up to you. But I think you get the point. So to summarize, the ternary operator is just a shorter way to write if-else statements. Let's now create a coin flip game. So we're essentially simulating to flip a coin. So it can either be heads or tails. And then we are going to output whether the result has been heads or tails. So feel free to try this on your own, and then you can take a look at my solution. In order to do so, I personally would first of all start to generate a random number. So let random number be equal, and now to generate a random number between 0 and 1, I'm going to use math.random like so. So let's console.log our random number. Currently we have 0.6, 0.01, 0.98, and so on. But since a coin can either be heads or tails, we should probably convert this random number to either 0 or 1. And then 0 could, for example, represent tails, and 1 could represent heads. In order to do so, I'm just going to use math.round for math.random. Now I'm getting 1, 0, 1, 0, 1, 1, 1, and so on. So I think you get the idea. But now I have to convert this number to an output, so to a text. In order to do so, I could use a ternary operator, I could use a switch statement, I could use an if statement, and so on. So let me show you an if statement, for example. So if random number is equal to 0, for example, I'm going to console.log tails like this. Else, I'm going to console.log heads like so. And now we're getting heads, 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 tails, heads, tails, and so on. So it's as simple as that. Let's also try to do the exact same by using a ternary expression. So maybe random number, if random number is equal to 0, then I want to console.log tails. Otherwise, I want to console.log heads, like so. I'm going to save this. We're getting heads, tails, heads, 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 tails, and so on. So this here works as well. And now we can of course also use a switch statement, even though it wouldn't make too much sense under those circumstances, but we could do so. So switch random number, like so. And now we're going to define a case 0. If that is the case, we're going to console.log tails, we're going to break out, and case 1, we're going to console.log heads, and we're going to break out. And we can also add a default statement, which we will probably not need in this case, but we could say console.log something went wrong, for example. I'm going to save this, and again we're getting tails, heads, heads, and so on. So I think you get the idea. So I could essentially implement this logic by either using a switch statement, by using an if statement, or by using a ternary operator. So I think you already see that you can get the same results by using different methods in JavaScript. And whatever method you use depends on the situation and from time to time also on your personal preference. Let's now take a look at scope in JavaScript. And the scope controls where a variable can be used. Imagine we have a function, for example, output message, like so. And now we could, for example, define a variable inside of this function. So this would be totally possible. So maybe let message be equal to hello guys. And now I can just console.log this message right here. I'm now going to save this. Nothing is going to happen because we also need to call this function. So output message, like so. And now we're seeing hello guys in the console. What would happen if I would now try to access this message outside of this function? Let me try this. So console.log, and I'm going to access our message. As you can see, we're getting an uncaught reference error. Message is not defined. And the reason for this is scope, because this message is only available within its scope. So within the scope of this function right here. And that is what you call the local scope, because it's only locally available inside of this function. There also exists the global scope. So I could also define the message variable right here. So let message be equal to hey, like so. I'm going to save this, and you can see we're getting hey in the console. This variable is now defined in the global scope. Everything will have access to this variable. And scope essentially always goes from top to bottom. So let me show you. If I would now take this message and put it in here again, this of course works. And if I'm now going to have an if statement right here, so if 1 equals 1, for example, which of course is always going to be true, if that is the case, then I'm going to console.log the message once again. And you can see we're getting hey twice right now. Once right here, and the other time right here. From a higher level to a lower level, essentially, a variable will always be accessible, but not the other way around. If I would, for example, define this variable within this scope, then it will not be available right here, and we're getting an uncaught reference error. Otherwise, if I'm defining it right here, for example, it will be available. If I'm defining it right here, it will also be available, but it wouldn't be available if I define it right here outside of the scope. So the variable is always bound to its scope. If I define it within this scope right here, then it's everywhere inside of the scope available. If I define it within, for example, so right here, then it's everywhere available. So within the entire document. And if I only define it within the scope of this if statement, so within this scope, then it would only be available within this scope essentially, and it will not be accessible outside of the scope. Even if I would place this one right below. So this doesn't change anything. We're still getting this error for this line. So now let me show you what happens if I'm going to have this variable right here. At the moment, we are seeing hey in the console. But what would happen if I would have another variable called message? So let message be equal to hey guys, like so. So what would now happen? As you can see, once I save, I'm still seeing hey. What would happen if I would define a variable? So let message be equal to hello guys, for example, like so. And you can see we're still seeing hey. So when accessing a variable, for example, when using console.log of this variable, we will always, first of all, take a look within the closest scope. So within the own scope, essentially. So within this scope, if it can then not find this variable, for example, if I delete it, it will go one level higher. So now it will take a look at this scope right here. If it finds it, it will of course use it. Therefore, we are seeing hey guys. If I delete this variable right here as well, then there only exists the global scope. So it will take a look at the global scope. Message is defined right here. Therefore, it's going to use this message and will output the result. And if it cannot find the variable right there in the global scope, we're just getting an error, obviously. So when accessing a variable, we will always look at the closest scope first and then go higher and higher. And that is all you need to know about scope in JavaScript. So the scope essentially controls where a variable can be used. Let's now understand objects in JavaScript. And objects store related data using key value pairs. So how can you imagine an object? Think about the real world. Pretty much anything in the real world can be considered an object. If you have a person, in JavaScript you can consider this person an object. If you have a car can be considered an object. If you have shoes, the shoes can be considered an object. So literally anything can be seen as an object. And usually an object is something where data is related. If you think about a person, for example, you have a lot of properties that are related to this person, for example. So a person has a certain height, a person has a certain amount of money, a person has a certain IQ, a person has a certain name, and so on. So a person has a lot of properties that belong to this person. And therefore, of course, you could go ahead and store all of those properties inside of different variables. But it might make more sense to group all of those properties together to an object. So you store all of those properties that essentially belong together inside of an object. So an object essentially helps you to logically group data that is related, like data that belongs to a person, for example. You can create an object by just creating a variable like so. And now we're going to use an equal sign. And now to define an object, you always use those brackets right here. So this here will tell JavaScript that this is going to be an object. And inside of those brackets, we can now define our key value pairs. A key is something that describes what this property essentially is. This can be something like age. It can be something like height. It can be something like income. So the key is essentially the description of what this property represents. So it could be a height, for example, in centimeters. And then you use a colon, and after the colon, you define a value for this property. And the height could be, for example, 180 centimeters. So I'm going to use the number 180. And now you can define as many key value pairs for this person as you like. So I could have another key value pair for the name, for example. So I could say first name like so. And that one can also be a string. So you're not limited to numbers right here. So the first name could be NPC, for example. I could also have a last name, which could be codes, for example. And now I could also have an income of 0 because I'm still broke. And I could have a variable is smart, that is probably false for me, and so on. So inside of this object, you can store as many key value pairs as you like. And of course, it makes sense to store all of those key value pairs together because all of those key value pairs in the end belong to a person. And you could also use a different name for this variable, so maybe NPC, because this is the variable or the person NPC. But that is up to you, of course. And now let me just console.log NPC, so myself essentially. And you can see we're getting this output right here. We have a first name, NPC, height 180 centimeters, income 0, and so on. So right here, we can see all of those key value pairs. But now, maybe I only want to access the height, or only the first name, or the last name, and so on. And I can do so by using the dot notation in JavaScript. So I can say NPC dot, and now I can access the individual properties. And you can see that this is a property. That's what you call a key value pair in JavaScript of an object. If you take a look at those brackets, because right here we are seeing property. So we can access the is smart property, for example. And now we will see false in the console because the NPC is dumb. So is smart is false. You can also output the income like so, or maybe the first name. So that is up to me. An alternative way would be the bracket notation. So I can use brackets right here. And now I can use the height, for example. And I'm getting 180 in the console. I can also access the first name, so NPC, or the last name, for example. And what is the difference between bracket and dot notation? Technically, you can use pretty much both of those notations, but oftentimes, when using JavaScript, you want to dynamically access a certain property. And accessing a property dynamically often means that you want to access this property at runtime. And under those circumstances, when a property, for example, doesn't exist yet on this object, you might want to use bracket notation. But you will understand this later on. At this point in time, it's not really that important. Just remember that you can use the bracket notation to access a property, and you can also use the dot notation to access a property. Now we can also add property names to this object later on. So I could, for example, say that npc.biceps size is equal to 100. I'm now going to console.log our npc, and you can now see that we're getting this result. So now we also have a biceps size of 100. We can, of course, also add the same property by using the bracket notation, like so. And now we're also having a biceps size of 100. We could also have NPC of strength, and this could be equal to 9,000, for example. And now NPC has a strength of 9000. We can also modify properties the exact same way. So I could, for example, say NPC of height should be 250 instead. And right now I'm getting the error height is not defined because I need those quotation marks. And now we're getting a height of 250 centimeters. So we can also override existing properties. So you can add properties or override properties. And you can also delete certain properties. So I could also say delete NPC of height, for example. So now overriding it might not even make too much because we're immediately deleting it afterwards. And now you can see we don't have the height property anymore. So this is how you can add properties, adjust properties, and delete certain properties of an object. It's me again, and I would like to add something to objects that I forgot to mention previously. So imagine we have an object like NPC, for example. So const NPC is equal to an object, the username is NPC, for example, and the age is, for example, 28, like this. But now an object can also have objects inside of it. So I can also store objects inside of objects, for example. So maybe he has a street, for example, or an address, like so. And inside of this address, as an object, we store, for example, our street. So maybe this is a random street, doesn't matter, like so. And maybe you also have a city, so maybe Munich, and so on. So I think you get the idea. So by just using the property name followed by a colon and then using the normal object syntax, you can store objects inside of objects. And you can also store arrays inside of objects. So maybe NPC has a couple of favorite numbers, for example, and then he can store those numbers inside of an array inside of this object. So maybe 2, 4, 6, and 1 million, for example. And that is how this works. So inside of objects, you can store pretty much anything you like. You can store numbers, strings, booleans, arrays, objects, and so on. And that is all you need to know about objects in JavaScript. Let's now take a look at object functions. And object functions are functions inside objects. So essentially, they belong to an object. If you think about the functions that we created up to this point, they were mostly standalone functions. But if you think about a car in the real world, for example, or a person in the real world, then there exist things that only, for example, cars do and things that only, for example, a person does. For example, a car can drive and a person, for example, can eat. So it might make sense to assign those functions to the individual objects. For example, only a person should be able to eat, so it might make sense to assign the eating function to the object person. On the other hand, it might only make sense for a car to drive, therefore it might make sense to assign the driving function to the car object. And for us, let's for example create an object Goku, for example. So of course you can also represent Son Goku as an object, like so. So Goku is an object. He probably has the property power level, like so, and he maybe has a power level of 9000 for now. So now this here is a property, so key value pair. This key value pair defines a certain property of an object. In this case, the power level of the object Goku. But now Goku can also do something. So maybe he can punch, maybe he can fight, and so on. So I think you get the idea. And in order to define a property, we use key value pairs. And in order to define functionality of a certain object, like driving, eating, thinking, and so on, we use functions. And when we have those functions inside of objects, we also say that they are methods. So let's create, for example, a method punch, like so. And you can create that method by using the method name, like so, followed by a colon, and then we use the function keyword, like so. And now it's pretty similar to a normal function. We just use opening and closing brackets, and now we use this body right here. So the syntax is just slightly different. Instead of having the function name right here, we define it right here. And now we can, for example, console.log Goku is punching, for example. like this. And now I can access this function by again accessing my object, so Goku. And now by using the dot notation, I can access my property and I can also access my method, like so. And now when accessing a property, it's enough to just use dot notation followed by the property name. But if you are accessing a function and you want to call this function, you always have to use those brackets. So those brackets always say that we immediately want to execute a function or method. In this case, a method because it belongs to an object. I'm going to end the statement and I'm going to save this. And in the console, we are now getting Goku is punching. Now, an object can have as many functions as it wants. So we could also create a fight function. And this function could now, for example, just console.log Goku is fighting, for example, like so. I'm going to save this. Now I can also call Goku.fight right here. I'm going to save this, and you can see we're getting Goku's punching, and right below, Goku is fighting. Now imagine we wanted to increase the power level. In order to do so, we can create another function, increase power level, for example, like so. This is also going to be equal to a function like this. And now we somehow need to access this property that belongs to this object essentially. And in order to do so, we can use this dot power level plus equals 1000. And again, this here is just equivalent to using power level plus 1000. So this is just the shortest syntax to using this dot power level plus equals 1000. And now you might wonder, what exactly is this? And this is actually pretty simple. A lot of people make this really complicated, but this just points to this object. So this always points to the object inside which you use it. And at this point in time, it might not make too much sense to you, because you might wonder, why do I even have to point to this object if I'm already inside of this object? But you will understand why this becomes necessary later on. But for now, just remember, this points to the current object. So this, in this case, just points to Goku. And if you would now have a second object of Vegeta, for example, like so, inside of this object, this will just point to Vegeta. So if I'm going to use this right here, this points to Vegeta, while this points to Goku. Because this is inside of Goku, and this is inside of Vegeta. And that was a lot of this, but I think you get the idea, guys. So that is really important. And now, at this point, we're pointing to the power level inside of this object. So this dot power level points to this power level right here. So to the power level inside of this object. And we're just increasing it by 1000 every time we are going to call the increase power level method. So now I can use Goku dot increase power level like this. And I'm going to console.log the property, so this property right here afterwards, by using console.log Goku.power level like this. Again, we don't need any brackets because we're only accessing a property. And you can see we're getting 10,000. Now I can call this method over and over again like this, and we're getting 14,000 right now. So we are just increasing this power level every time we call this method by 1000. Now let me delete all of this right here, and let me also show the shorter way to writing the exact same. So I can of course do it like this, and a lot of people do it like this, but the shorter syntax would be to just use the method name followed by those brackets. Inside of those brackets, we again have the parameters in case we want to define any parameters. And now I can just use those brackets like this. And inside of those brackets, I again define the functionality. So maybe this dot power level plus equals 1000. And this here is essentially equivalent. So this syntax is equivalent to this syntax. It's just a little bit shorter. And now again, we can call this a couple of times, and we're still getting the exact same result. we're increasing the power level by 1000 every time we call it. So every time we call this method. Now we can of course also accept parameters. So we could, instead of those brackets, for example, just define an enemy, for example. So a parameter enemy that we are expecting. And now we can say Goku's fighting against plus enemy, for example, like this. And now I can just say Goku.fight, and let's say he fights against Vegeta, for example. And now you can see we're getting Goku's fighting against Vegeta. And of course it should have a space right here. And we're getting Goku's fighting against Vegeta. So this is pretty similar to a normal function. And of course we could also use the shorthand syntax for this function. So we can just remove the function keyword right here and save this. And we're getting the exact same result. And of course the same works for this one right here. So the function keyword is essentially not really necessary. You can get the exact same result by using the shorthand syntax. And most people nowadays use this syntax, but a couple still use the old syntax, so I want you to know both forms. And that is all you need to know about object functions. So to summarize, object functions are functions inside of an object, and if you have an object function, you call it a method. So normal functions outside of objects are functions, and functions inside of objects are called method. But the difference is not really that important, it's just a naming convention. You can create a function by using the function keyword, followed by brackets inside which you can define the parameters, followed by the body, in which you define the functionality. And this always points to the current object. So under those circumstances, this for example points to the object that is currently calling this method right here, which is in this case of course Goku. And that is all you need to know about object functions. Let's now understand classes. And classes are templates for creating objects. Up to this point, we for example were creating Goku, we were creating Vegeta, and so on. So we were creating all of those individual objects. But maybe, in the end, every single person, for example, so Goku, Vegeta, and so on, they're all humans. So you could argue that all of them belong to the class human. So I think you get the idea. In the end, you can always create individual objects, but it might make a little more sense to first of all, create a blueprint for all objects that could belong to this class, and then use this blueprint to create the individual objects. And it might sound a little more confusing than it really is, so let me show you. Imagine we have a lot of different superheroes. We might have Goku, we might have Saitama, we might have Spider-Man, and so on. So all of them are individual objects, all of them are individual superheroes. But you could argue that all of them belong to the class superhero. And in the end, every superhero is pretty similar. Every superhero has a specific name, for example, a specific power level, a specific strength, and so on. So I think you get the idea. And now we can create a blueprint for those superheroes by using a class. So we use the class keyword to create a class, followed by the class name. And for classes, we usually use capital letters. So class superhero, like so. Now, inside of this class, we use opening and closing brackets. And inside of those brackets, so inside of those brackets here, we define the class. Usually, every single class should have a constructor, like so, and like so. And if you take a look at the constructor, it's essentially just a normal function, so a normal method, because the syntax is just similar to a normal method, like this. So we have the name, we have opening and closing brackets, and right here, we have the method body. But the constructor is somewhat also special, because the constructor will under the hood be automatically called by JavaScript every time we create a specific object from this constructor. So of course, the class is the blueprint, and later on we use the constructor to create from this blueprint our individual objects. So maybe you will call the constructor for creating Vegeta, and then you will call the constructor once again to create Goku, and then you will call the constructor once again to create Spider-Man, and so on. So I think you get the idea. The constructor will be called every time we create an object from our blueprint so the class blueprint. And usually you use the constructor to initiate every single object later on with different properties. Because every single superhero, for example, has a different superhero name, for example, and a different power level, and so on. And by using the constructor, we can use different superhero names for Goku, Saitama, Spider-Man, and so on, as well as different power levels under those circumstances. And now we're going to say this dot superhero name is equal to superhero name. I will explain what this means in a second, but for now, just stick with me. And this dot power level is equal to power level, like so. And now we can create a new superhero by using a variable. So maybe const Goku is equal to new superhero, like so. And now, right here, we can, for example, say the superhero name is Goku and the power level is 9000. Now we can do the exact same for Spider-Man, for example. So Spider-Man is equal to new superhero and his name is Spider-Man and his power level is maybe 5000, like this. And now let me explain all of this to you. So we're just using a variable to store our superhero. And this can literally be anything, but again, a descriptive name might make sense. Since we want to store Goku inside of this variable, we use the variable name Goku. And now we say that Goku is equal to new superhero. By using the new keyword together with the class name, we always say that we're calling the constructor. So this syntax will automatically always call the constructor of this class. In this case, of the superhero class. So right here, we're calling this constructor, and this constructor expects us to pass two arguments, since we define two parameters right here, to the constructor. The first parameter is the superhero name. So as an argument, we need to pass a name. The second argument right here is our power level. So to this parameter, we pass the power level. So up to this point, this is just a normal function, so a normal method inside of this class. So up to this point, it's actually as if we would have Goku right here and the power level 9000 right here, because we pass those values as arguments to those parameters. And now, right here, what are we doing right here? Right here, we are creating a new object. So when using the constructor right here, this points to this object right now, because we're calling new superhero for the variable Goku. So this will now point to the object Goku. And now we're saying that this .superhero name, so the superhero name of this object right here, is going to be equal to the superhero name that we passed as parameter, so as argument to this parameter. So actually, we are saying that this .superhero name, so the superhero name of this object, is essentially for Goku equal to Goku, because that is essentially what we're passing right here as a parameter. So this is how you have to think about it. This right here is the specific argument that we pass to the property superhero name later on of this specific object Goku, because this points to Goku. Let me get back to this one, like so. And now we're doing the exact same for power level, of course. We pass this power level right here as an argument to the parameter power level. So it is as if we would have 9000 right here. And now we're saying that this .power level, so the power level again for the object Goku, is equal to 9000, because that is what we have passed as an argument to the constructor right here. And usually you just use the same names for the parameters right here as you use for the properties. But that is just a convention. This here could also be PL and SN, for example. And now, of course, you would have to say this .power level. So the power level of this object Goku, so the property power level of this object Goku, is equal to PL. And this .superhero name, so the property superhero name of this object Goku, is equal to SN, for example. So this is the exact same. It doesn't really matter. A convention is just that you use the same names for the property as you use for the parameters right here. But that's just a convention. That's also up to you in the end. And now we're doing the exact same. We're creating the variable Spider-Man. Inside of this variable, we're storing a new object, which we say by using the new superhero constructor again. So this creates a new object, stores this object inside of the Spider-Man variable, and from this point on, for this variable, this points to this Spider-Man object. And now we're again saying that this.superhero name, so since we're calling the constructor right here for Spider-Man now, we're saying that this.superhero name for Spider-Man, so for the variable Spider-Man, is equal to superhero name. We pass the superhero name Spider-Man again to our constructor, so now it looks like this, and assign it to the property superhero name. And the exact same, of course, for the power level. So when calling the constructor right here, we are passing those values as arguments, and when calling the constructor right here, we pass those values as arguments to the constructor in the end. Let me get back right here. And I think you get the idea. If I now want to create 10 objects, for example, maybe I also have Saitama. His name is Saitama, and his power level is maybe 10,000, like so. I can use the exact same constructor. I just pass different values, so different arguments to this constructor, and by passing different arguments, the properties of this object in the end, so the properties, superhero name and power level, will just have different values for Saitama than for Goku or Spider-Man, for example. So I think you get the idea. You call the constructor over and over again every time you use the new keyword together with the class name. And for every single constructor call, you will create a new object, and every new object has this pointing to the specific object. So for Goku, when using the constructor, this points to Goku. When creating Spider-Man using the constructor, this points to the variable Spider-Man. And when creating Saitama as an object, this points to the object Saitama. And now you could, of course, also create a method right here. So maybe print name, for example, like so. And now I could just console.log this.superhero name, for example. And now for Goku, this points to Goku. So this.superhero name is Goku right here. For Spider-Man, this.superhero name is Spider-Man. And for Saitama, this.superhero name is Saitama. So if I'm now going to say Goku.superhero name, and I'm going to call this method right here, and actually this needs to be print name, so that was my bad, because of course superhero name is a property, like so. We're getting Goku. If I'm going to call Spider-Man.print name, we're going to get Spider-Man. And if I'm going to call Saitama.print name, we're getting Saitama. And the reason for this is, of course, that for Goku, this again points to Goku, so to the superhero name Goku. For Spider-Man, it points to the superhero name Spider-Man. And for Saitama, this.superhero name points to the superhero name Saitama. So this always refers to the object that has been created using the new superhero constructor under those circumstances. And I know I explained this really a lot, but I really want to make sure that everyone understands this, because this can be confusing to a lot of beginners. But it's actually really, really simple. This always points to the object that has been created by using the constructor for this individual object, which you store inside of a variable, of course. Welcome to this mini project where we want to create a user profile system together. In this project, the user should have a username, he should have an age, he should maybe have a specific country, and he should have an is logged in status that should be false by default. Later on, we will provide a function that logs the user in and a function that logs the user out, as well as a function that provides information about the user. And of course, I mean method, because all of this will be side of an object. So to summarize, I want you to create a user class that essentially initializes the user by giving him a username, an age, a country, as well as a login status that should be false by default, and then provides methods to log in, log out, and provide information about the user. And logging the user in essentially just means that the is logged in status should be true, whereas logging him out should set the login status to false. So you can try this on your own, and afterwards you can take a look at how I did it. So let me get started. First of all, we need to create a class user, and this will help us to create users later on. So we use opening and closing brackets, and inside of those brackets we now define our user blueprint. We're going to construct the user by using the constructor like so, and inside of the brackets right here we accept a couple of parameters. The first one is of course going to be the username, the second one should be the country, and the third one should be the age, like so. You're wondering why we're not accepting the login status, and I will show you in a second. But for now, let's say that this .username, so the username for the specific object later on, is going to be equal to the parameter username. So whatever we pass to our constructor later on. This .country is equal to country, and this .age is equal to age. Now we also need the login status. So this .login status, for example. But since we want to set it to false by default, we do not have to accept it as a parameter here, because we do not want to set this when initializing the user. The user will always be logged out by default. So login status is going to be false all of the time. Every time we construct a new object, a new user object, the login status will be false. So now we also need a method to log the user in. So let's create a login method right here. And for this method, we of course need to set the login status to true. So we're going to say this .login status is equal to true. And now we can also console.log, let's use backtick characters, and let's say the user $this .username is now logged in, like so. So this will be our message. And now we can also use or create a method logout like so. And that one just sets the login status to false, because then he's essentially not logged in anymore. And again, we can use console.log. Let's again use backtick characters like so. And let's say the user, this .username, is now logged out, like so. So this is our success message essentially when the user logs in or logs out. And now we also want to provide information about the user. So maybe the username, the country, and the age. So we can say get user info, like so. And now, right here, we are just going to console.log, for example. Let's use backtick characters. Let's go into a new line, like this. And now, let me just say that the username, for example, like so, is equal to this .username. Let me go into a new line. Now let's also print our age, and let's say this .age is our age, and of course the exact same for our country. And now we're going to say this .country, like so. So after a colon, we will always provide the actual information. And now let me save this, and let's create a new user by using the constructor. And let's say the first user, for example, is NPC. So const NPC is equal to new user, like this. The username is NPC. Country might be Germany. Age might be 28. And now I'm going to save this, and now I can access npc.login, for example. Let's test this. The user NPC is now logged in. Let's also use npc.logout, for example, like this. The user NPC is now logged out. And let's also use npc.get user info, like so. Username NPC, age 28, country, Germany. And of course, we could also format this a little bit better like this. And we could also output the login status. We're going to say login status colon. And now I want to access this dot login status like this. And you can see we're getting login status false. So currently we're not logged in because we logged out. If I'm going to remove logout though, we're getting login status true because now we're logged in. And this is how you can create a basic user that includes a couple of properties and has a login, logout, and get user info method. So I hope you enjoyed this little project and see you in the next lesson. Let's now understand keys, values, and entries. And keys, values, and entries are used to access object data. So what do I mean by this? Let me show you by first of all creating an object. So imagine we're having a user object like this. And this user object is equal to this object that has the property, or to be precise, the key username. And the username can be NPC. He also has an amount of subscribers, for example, currently 1,300, for example. And he has an amount of money, for example, currently probably around 0. So this is now our user. And now let me show you what keys, values, and entries are by just console.logging them, because that's probably the easiest way to understand it. And now we can access the keys by using object.keys, for example. And inside of those brackets, we can now define the object of which we want to get all of the keys. In our case, it's the user object. Like this. I'm going to save this, and you can see inside of an array, so inside of a list, we get all of our keys. So we're always getting the key. So username, subscriber, and money are the keys for our user. Now, instead of keys, we can also get the values by using object.values. And now, again, inside of an array, we're getting all of the values. So NPC, right here, 1,300, right here, and 0 right here. So by using object.keys, we're getting all of the keys, and by using object.values, we're getting all of the values. And now we can also use object.entries. And now we're getting an array of arrays. So inside of the first array, we have another array that includes key and value. So every single array inside of this array contains key value pairs, but this time as an array instead of key value pairs inside of an object. So we have the first array that includes username and NPC, the second one that includes subscribers and 1,300, and the last one which includes money and 0. And now, since this here essentially returns an array, we can of course also access those elements by using bracket notation. So I could access object.entries of user of 0, which gives us username and NPC. I can access number 1 like this, and number 2 like this. And of course I can also access 2, 0, for example, because this here is element number 0 and this here is element number 1. If I only want to get the key now, I could also get 2 of 0, for example, and this would give me money, and 2 of 1 would give me the actual value, like so. Of course, I can also do 0, 1, 0, 0, 1, 0, 1, 1. So I think you get the idea. You can access the values inside of this array just by using the bracket notation the normal way. So I think you get the idea. And that is how you can access keys, values, and entries of a certain object. Let's now understand object.freeze. And object.freeze prevents object values from being changed. So let me show you. Imagine we're having a user object. So const user is equal to this object right here. And now this user has a username of NPC, for example, once again, and an age of 28, for example, like so. And now I can freeze this object by using object.freeze, like so. And inside of the brackets, I need to pass my user object, like so. And now imagine I want to change this object, for example, object.username, and set this equal to npc codes, like so. Now let me just console.log the user for you. And now you can see for the username, we still have username npc and age is still 28, even though I changed it right here. So now once I remove object.freeze and I'm going to save this, you can see that username is now npc codes. So by using object.freeze, we essentially prevented our username, or the value to be precise, from being changed. And that is all you really need to know about object.freeze. It essentially prevents modifications of existing properties, and it is useful if you want to prevent anyone from changing an object at a certain point in time, for example. Let's take a look at the difference between primitive types and complex types. Primitive types usually store simple values, whereas complex types store multiple values. An example for a primitive type is a number, for example. So const score, for example, is equal to 100. So this right here is a primitive type. Now, a complex type is, for example, an object or an array. So const numbers is equal to this array, for example. And this here is a complex type. Another complex type is, of course, an object. So const user is equal to this user that has a username of npc and an age of 28, for example. So this is a complex type as well. And now let me show you the difference. Let me, for example, say const score copy is equal to score. So now we're saying that the score copy should have the same value that our score has, so 100. I'm now going to console.log our score, and I'm also going to console.log our score copy, for example, like this. And you can see we're getting 100 in the console both times. Now, what would happen if I would increase the score though? So if I would say score plus equals 100. And now, of course, I should use let right here because I'm modifying the value, so const doesn't work anymore. And now I'm saying score plus equals 100. So my score is now 200 for the first score. But since I'm first of all taking the value of score and assigning it to score copy, and only afterwards I'm incrementing the value of score, score will have a value of 200, whereas score copy will still have the value of 100. So you essentially just create a copy, and the copy from that point in time is completely independent from the original score. Now let me try to change the numbers array though. So let's say const numbers copy is equal to numbers. So we now have a copy, and now I'm going to say that numbers of 0, for example, is now 100. And now I'm going to console.log our numbers, and you can see, as expected, we're getting 100, 2, 3, and 4. So the first value has been modified. And now I'm also going to console.log our numbers copy, like this, and we're getting the exact same value. So even though we first of all took our numbers and copied them to our numbers copy, and only afterwards changed the value of the first element, we're still getting the exact same arrays. And the same would also happen for our object, so our user object. So why is that? And the reason for this is that simple types essentially have a value, and if you copy this value over to another variable, this variable will take the value, but from that point in time, it will be completely independent. And the reason for this is that score will get saved at a certain memory location, and the score copy later on will also get stored at a different memory location. So let me print this for you. So the storage of a computer looks somewhat like this. You have a lot of different cells. So you have a cell right here, a cell right here, a cell right here, and then you just have a lot of cells. And all of those cells allow you to store values. And essentially, if you take a primitive type, you essentially store the value inside of one of those cells, like so. And later on, every time you want to get the value of this primitive type, you're going to take a look at that cell and read the value from the cell. If you're now going to create a copy, you're going to take a look at this cell, you're going to create a copy and save the copy inside of another cell. So maybe this cell right here. So now the first value, so the original score, points to this cell, whereas the score copy, for example, could point to this cell. And if you now change the value of the score, you increment the value of this cell, but the value of this cell will of course stay untouched, whereas incrementing the value of this cell would of course increment the value right here, but keep this value untouched. So that is how this works. So now let me show you the difference to complex types. Imagine we are storing the value of our complex type, so maybe of our numbers array, inside of this cell right here. So now, whenever we want to get the value of our numbers array or increment the value, we are going to point towards this cell. So now we have a reference towards this cell. If we are now going to create a numbers copy though, we're essentially not going to take the value and copy that one into a new cell, but instead we're just going to take a copy of the reference, so of the cell reference. So maybe this here is cell 1, this here is cell 2, 3, 4, 5, 6, and so on. And now we're just going to take the cell number essentially and copy that cell number to numbers copy. So now numbers copy will also point to the exact same cell. And every time numbers copy needs this value, it's going to take a look at cell number 2. And every time numbers needs to have the value of the cell, it's also going to take a look at the cell with the number 2. So essentially for complex types, we're only going to paste the reference of the memory location. So for primitive types, you essentially copy paste the value, and for complex types, you copy paste the reference to the memory location where this value is stored. And of course, if one of those values, so of numbers or numbers copy, now changes the value inside of the cell, it will essentially change the value for both of those variables because both variables are pointing to the exact same memory location. And if the value is now different, of course, both of those variables will read the adjusted value, so the new value. So the important difference between primitive and complex types is that primitive types only copy the value and store their values inside of different cells in the end, different memory cells on your computer. Whereas complex types don't copy the entire object. So for a complex type, like an object, you just copy the pointer, so the pointer to the corresponding memory cell. So even if you have 100 copies of this user object, for example, there will only be one single user object stored in a memory cell, and you will have 100 different pointers to this one exact same cell. And something that I also didn't mention up to this point, if you take a look at the difference between primitive types and complex types, if you use const, for example, for the score, and let me for now delete all of this, and I later on decide that I want to change the value of score, for example, by 100, and I'm now going to console.log the score, you can see that we're getting this error right here, assignment to constant variable. So for primitive types, you cannot adjust the value of a constant variable. Therefore, if you have to change the value of a variable later on, you always want to use let. If you are certain though that you don't have to change the value of this variable later on, you should use const, like so. So under those circumstances, we should of course use let because we want to change the variable of our score later on. Now, on the other hand, when using complex types like arrays or objects, even though you have a constant variable right here, you can change the value by using bracket notation, for example, for arrays. So this here is completely valid, like so. Let me console.log the numbers. And you can see this works. You could also add elements by using .push, for example, like so. So I could just push a new element to this array, so 100. So you can add or remove elements as well and modify this array in any way you like. The only thing that you cannot do is essentially saying numbers is equal to completely new array, for example. So this here is not valid, but using methods to modify the array is completely fine. So using pop, push, and so on is something that you can do. So even though the array has a constant variable, it's still possible to modify this array by using methods, for example. And the same also works for objects. So if you have a user, for example, and this user maybe has again the username NPC, even though this here is a constant variable again, you can still say that user.username should now be NPC codes, for example. And let me console.log the user. And you can see this here is still valid, so we can change it like this. The only thing that you cannot do is again reassign to the user variable a completely new object. So something like this here is, for example, not possible because now it's a different object. But modifying it using a method, for example, or using the dot notation, so user.username, is something that you can do all of the time, like this. So understanding this difference is also important, even though this has a little less to do with primitive and complex types, but it's an important difference to notice. So to summarize, primitive types store simple values and store their values always inside of their own memory address, so memory location on your PC. Complex types store multiple values and they point to the stored value inside of the memory address by using a pointer. So when copying a complex type, you don't copy the entire complex type to a new memory cell, but instead you copy the pointer to the new variable. And those are the most important differences between primitive types and complex types. Let's now take a look at probably one of the most important takeaways of this course. And that one is that almost everything in JavaScript is an object. If you remember, a lot of the stuff that we did up to this point, it was probably a little confusing to a lot of you. So why did we, for example, say console.log hello, for example? So why did we use this dot, for example? What exactly is the console? And the same, of course, also works for math, for example. We used math.random, for example, like this. Again, we use this dot, and again, this name afterwards. So why is that? And the reason for this is that everything, again, is an object in JavaScript, or almost everything. So let me show you. Let's, for example, console.log the type of the console, for example, like so. And you can see the console is just an object. And we can also console.log the type of math, for example. Again, that is an object as well. And I can also show you how this works by creating something similar to the console. So the console is essentially just an object that has properties and methods. And if we would create a console ourselves, we could do so by, for example, saying const console1, for example, is equal to an object. And now this object, for example, has a log method like so. And now, instead of this log method, we could just define what we want to do. In our case, we maybe want to console.log, and maybe we expect a message right here. And now we can just console.log the message, like so. I'm going to save this. And now we could, for example, say console1.log. So now we're accessing our own log method right here. It expects a message. I could say hello guys, for example, and we're now printing hello guys. So in the end, this here is pretty similar. The console object is just a predefined object from the JavaScript team that provides us a method to log something in the console. And of course, it's a little more complex than this right here. Also, we're using the original console right here. So by default, the original method is of course slightly different, but the basic principle is exactly this one right here. You are having the object. You're going to access this object by using the object name. By using the dot notation, you say that you want to either access a property from this object or a method from this object. In our case, we want to access a method. Every time you want to access a method, you use opening and closing brackets. And in case this method expects a parameter, you pass a value as an argument to this method right here and then execute it. So those brackets right here always mean execute a method. And if you just have a property, so something like, I don't know, speed, for example, let's say we have a speed of 100, you can access this property pretty much the exact same way. You use the object name followed by a dot, and then you could just use the property name. If you access a property though, you don't have to use those braces right here. This here means you want to execute a method. This here means you want to access a property. So now we could just console.log console1.speed, for example, and we would get 100. And the important takeaway is that every time you do something like math.random, for example, like this, you're essentially just accessing a JavaScript object that the JavaScript team provided for us. In this case, the math object. You use the dot notation to access one of the properties or methods of this object that the JavaScript team provided. And then, in our case, we're going to access the random method from the math object. And we're going to execute it. So, if you would like to reconstruct this object, for example, you could just do something like const math1 is equal to an object. Then you would have the random method right here, for example. And now you could just create a random number, for example. So we could, for example, return some random number, and then you could do some calculations and so on. In my case, I would just use the math.random property that already exists. So of course it doesn't make too much sense, but I think you get the idea. You could also create something like an add function, or method to be precise, accept maybe two numbers, like so. And now you could just return num1 plus num2. And now we could access our own math object right here and say math1 dot add, for example. We get number 100 and number 200. At the moment, we're only returning it, so we should also console.log the returned result, and we're getting 300 in the console. And the math object that the JavaScript team provided looks pretty similar. It's just a normal object that includes a lot of different functions or methods, to be precise. So add, subtract, multiply, pow, and so on. So they added all kinds of methods there to this object, and now we have access to those methods. And the same, of course, also applies to the console object and to all kinds of objects in JavaScript. So that is the important takeaway. Every time you use the dot operator, you under the hood essentially just access a JavaScript object and access a property or method of this object. And knowing this makes this dot notation a lot less confusing in JavaScript. So to summarize, almost everything in JavaScript is an object. Let's now understand the for loop in JavaScript. And a for loop repeats code multiple times. Let me show you what I mean by this. And I'm first of all going to write it out, and then I'll explain it to you. You start a for loop by using the for keyword. Afterwards, you always have opening and closing brackets. And inside of those brackets, the first thing you do is initialize a variable. So let I be equal to 0. And I is just a convention. This here can be anything you like. This could be A, B, something like this. And again, I is the convention, like so. Then you use a semicolon to end this statement right here. So this here is the initialization. You initialize a variable. The initialization could also be 10, 5, 0, and so on. Again, 0 is pretty common for a lot of tasks, but it also depends on the task. After the semicolon, you define a condition. So how long should this for loop run? This for loop can repeat as long as the condition is true. So in our case, maybe as long as I is less than 10. So now this for loop will run as long as the condition I is less than 10 is true. And the third one, so the third thing we have to add right here, after a semicolon again, is what we want to do after each single loop iteration. And in our case, we, for example, want to increase I by 1 every single time we loop. And now we have those opening and closing brackets. And inside of those brackets, so again, inside of the body, we define what we want to do for every single iteration. In our case, let's just console.log I, for example. And you can see in the console we are getting all the numbers from 0 to 9. So how does this work? Again, we are going to initialize our variable I with the value 0. We are going to run this as long as I is less than 10, and after every single iteration, we'll increment I by 1. So initialization, condition, and increment or decrement. So change after every single iteration. So on the first iteration, I is 0. Is I of 0 less than 10? So is 0 less than 10? 0 is less than 10. So we're going to start by doing the first iteration. We're going to console.log I, which is 0 during the first iteration. Therefore, we get 0 in the console. After we finished executing this statement, we get to the end of this loop, and since it's a loop, we will do it forever until the condition is essentially false. So now, since we finished executing, we are now going to increment I by 1. So we will do whatever we defined right here. In our case, increment I by 1. So now I is 1. We're going to check, is I, so is 1, less than 10? I is still less than 10. Therefore, we are going to execute this code right here once again. So now we're going to console.log I. We're getting to the end of the iteration. We are going to increment I by 1. So now I is 2. Is 2 less than 10? 2 is less than 10. Therefore, we'll print 2. Again, we're at the end and we'll increment I by 1. We are going to do this forever until this condition here becomes false. So now after the last iteration, I is 9, we're going to increment I by 1. So 9 plus 1 is 10. So now is 10 less than 10? 10 is not less than 10 anymore, and therefore we're going to break out of this loop. So this loop here runs as long as the condition is true. So now what would happen if I would say as long as I is less than minus 1? So 0 is not less than minus 1, so this here should not run at all. And you can see it doesn't run at all. So this loop will only run if the condition is true. And right here, we could also do something else. So we could also say I plus equals 2, for example. And now we're going to get 0, 2, 4, 6, and 8. We could also say plus 5. So that is up to you. We can also say minus equals 5. And now we will get an infinite loop because this here will always be true. We're never going to break out of this loop. And you can see it goes on forever and ever. So I'm going to say plus equals 5 again. I'm going to save this, and probably my browser window crashed because I'm not really getting out of it. So maybe I have to reload this, and it doesn't work. So I think I have to close the entire window. So you can see an infinite loop can break your browser pretty fast. So I'm going to open this here once again, so the console, and now we can try this loop again, and we're getting 0 and 5. So to summarize, a for loop repeats code multiple times. You start by using the for keyword, then you initialize a variable. After the initialization, separated by a semicolon, you have your condition, and after another semicolon, you define what you want to do after every single iteration. And the block inside of the braces will run as long as the condition is true. And that is a for loop in JavaScript. Let's now understand while loops in JavaScript. And while loops run as long as a condition is true. Let me show you. Imagine we have a score, for example. So let score be equal to a certain number. And for now, let's say that this number is 0, for example. So by default, our score is 0. And now we can use a while loop to run a certain task as long as the score is less than 10, for example. In order to do so, we use the while keyword right here, followed by opening and closing brackets. And within those brackets, you define your condition. So right here, you have the condition. And this could be something like while score is less than 10, for example, like this. So this here is now our condition. So this while loop will run until the score is not less than 10 anymore. But as long as the score is less than 10, this while loop will run. Now we have a body again, so opening and closing brackets. And within this body, we again define what we want to do for every single iteration. So we could just console.log our score right here. If I'm now going to save this, you will see in the console that we will log the score. And this here is an infinite loop, because this here will never stop. We're going to run this code as long as this condition is true. So we are going to start with a score of 1, first iteration. We're going to console.log the current score, which is 0. We're going to get to the end of this loop. We'll check the condition right here once again. The score is still less than 10. So we run this code here once again. We get to the end. Therefore, we check the condition again. The score is still less than 10. So we are again going to console.log the score. And this will run forever and ever and ever. So in order to break out of this loop, we have to change our score in a way that will make this condition become false at a certain point. In order to do so, we could, for example, increment the score after every single iteration, like so, for example. Let me save this. And now you see that my browser window probably crashed. So I probably have to reload this. And I don't even know whether that is going to help. So yeah. As you can see, an infinite loop can probably break your browser. So now I have to close my browser like this, and I have to reopen my browser like this. And now we're back on our website. Let me inspect, console, and let me clear the console, and let me save this. And this is what we get in the console. So we get the numbers from 0 to 9. So what exactly happens right here? In the first iteration, our score is 0. Is a score of 0 less than 10? That is true. So we're going to console.log the score. And afterwards, we are going to increment the score by 1. So now our new score is 1. Is 1 less than 10? 1 is less than 10. So we're now going to console.log the score of 1. Therefore, we have 1 in the console right here. Again, we are going to increment the score afterwards. So now our score is 2. 2 is less than 10. So we're again going to console.log the score of 2. And now we repeat this here over and over again until our score is 9. We're going to console.log the score of 9 right here. We're going to increment the score of 9 to 10. So now our score is 10. Is 10 less than 10? 10 is not less than 10. And therefore we are going to break out of this loop. And once breaking out of this loop, we will just continue to execute whatever we have afterwards. So if we have hello, for example, right here, we would go through the entire loop, and afterwards we will print hello once breaking out of this loop. So this loop will essentially go from start to end to start to end, and only afterwards we will execute the code that comes afterwards. But now, of course, it can also happen that this condition here is never true. So maybe 11 right here, or 10, doesn't matter, like this. And we're only seeing hello in the console, which I can also delete because you know how this works now. And you can see we're not getting anything in the console because this condition here is not true. We're going to check, is our score of 10 less than 10? That's not true. Therefore, we will not execute this block of code right here. But if we want to run something once at least, we can use a do-while loop instead. Let me show you. A do-while loop is essentially a while loop. The only difference is that it will run once at least, even if the condition is not true. So for a do-while loop, you have do right here as a keyword. Then you have your opening and closing brackets. And right here, you define what you want to do inside of your while loop. So console.log score, for example. And now I want to increment score by 1. So score plus plus. And right here, after those brackets, I have my condition. So while this condition is true essentially. So while score is less than 10, for example. I'm going to save this, and you can see we're getting 10 in the console. And the reason for this is that we're first of all going to execute this code, since we're starting from top to bottom. Therefore, we'll execute this here first. And only after we've executed what we have in the do block, we're going to check for our condition. So now, this condition is of course immediately false. We even incremented our score right here. So now our score of 10 is 11. Is 11 less than 10? 11 is not less than 10. Therefore, at this point right here, we break out of this loop. So this here is also pretty logically, because as already mentioned, JavaScript executes code from top to bottom. So when we have a normal while loop, so score less than 10, for example, and let me just paste this here over, It makes sense that we first check the condition, because checking the condition right here comes first. And only after we check the condition, we execute this code right here. For a do-while loop, it also makes sense that we always execute it once, because again, we start from top to bottom. So we first of all execute this block of code, and only after executing this once, we check the condition. So only when checking the condition, we can break out of this loop. We can't break out of this loop when not checking the condition. Therefore, this here makes a lot of sense in my opinion. So to summarize, a while loop will run code as long as a condition is true, but it checks the condition before executing it for the first time. A do-while loop will also run as long as a condition is true, but the only difference is that it will run once at least, and only after running once, it will check the condition. And that is all you need to know about the while loop and the do-while loop in JavaScript. Let's take a look at the for-in loop in JavaScript. The for-in loop iterates over object keys. Imagine we have an object, for example, an object Goku that is equal to this. And let's use const right here because we do not plan to reassign the value later on. So this here is the clean way. And now, of course, the name is Goku and the power level is 9000 once again, like this. And now we can use a for-in loop to iterate over object keys. So over those keys right here. So again, we use the for keyword to define a for-in loop. Now, again, as a variable, we define a key. So we say let key. This here can be anything. This can also be this, or this. It doesn't matter. So you can have anything, but key is pretty common. But let me show you that it works like this as well. And now the name is for-in loop because we say in right here. And now we have to define the object over which we want to iterate. In our case, Goku. And now let me just console.log ASDAS for now, like so. And we're getting name and power level. And now let me use a more descriptive name. So let's use key, since you now know that this works. So a for-in loop allows us to get one of the keys for every single iteration. So for the first iteration, key is going to be name. We're going to console.log the key. We're going to reach this point where the iteration is essentially over. We're going to go on to the next iteration. For the next iteration, key will be power level. We're going to console.log the key power level, and we'll end right here. We don't have any keys anymore, and therefore we are going to break out of the loop at this point. Now I can also, for example, access the individual values, or for example, accessing Goku of key. And this is going to be similar to accessing Goku of name for the first iteration and Goku of power level for the second iteration. And this is a point where you essentially access a value dynamically. And under those circumstances, when accessing a value dynamically, you cannot use the dot notation. You can only use the dot notation to access specific properties like name or power level. But you cannot use the dot notation to access a value dynamically by using a changing key, for example, like this. So this is undefined. Under those circumstances, you always need to use the bracket notation. So Goku of key works, because this here will at runtime always take a different key for every single loop iteration and then access the individual values. So this here works. So for the first iteration, we're getting Goku of name, which is Goku. And for the second iteration, we are getting Goku of power level, which is 9000. So this is how this works. So to summarize, a for-in loop allows you to iterate over the keys of an object. And then you can use the key to access the individual values of those keys. And that is the power of the for-in loop. Let's now take a look at the for-of loop. A for-of loop iterates over iterable values like arrays. We already had the for-in loop, and you use the for-in loop to iterate over keys instead of objects. And you use the for-of loop essentially mostly to iterate over arrays. So for-in for objects, because you are searching inside of an object, and for-of for arrays, because you're getting individual values of an array. So that's how you can probably remember it. So imagine we're having a numbers array. So numbers is equal to maybe 10, 20, 30, 40, and so on. And now we want to iterate over those numbers. Again, to create a for of loop, we need to have the for keyword. Now, instead of brackets, we again define a placeholder for every single iteration. So maybe a number, like so, of numbers. And this variable that we defined right here will now hold the number or one of those numbers for every single iteration or during every single iteration. So during the first iteration, number will be 10. During the second iteration, number will be 20, then 30, and then 40. Let me show you. Let's for now just console.log the number, and we're getting 10, 20, 30, and 40. So for the first iteration, number of numbers will hold the value 10. We're going to console.log the number. We're reaching the end. We're going on to the next iteration, and number will now be set to 20. Now, 20 will be logged in the console. We go on to the next iteration. For the third iteration, the placeholder number, so our number variable, will hold the value 30, console.log that, and then go on to the last iteration. And that is how a for of loop works. So loops essentially always iterate over something. You can define those loops yourself by just using a normal for loop. You can iterate over objects, or you can iterate over arrays, for example, or iterable values in general. So that is up to you. But just remember that a for loop will run over and over again until a certain condition becomes false, essentially. For example, until a condition you defined becomes false, or for example, once an object does not have any keys anymore, or for example, once an array does not include any values anymore. So every time a specific condition becomes false, you're going to break out of the loop. But up to this point, the loop will iterate over and over again, one by one. And that is the basic principle of for loops. And a for in loop and a for of loop are essentially just specific implementations of for loops in the end. So you could also get the exact same result by using a normal for loop. Let me show you. So we could, for example, just say we're going to start at an I of 0. We're going to keep going until I, or as long as I, is less than numbers.length. Numbers.length should be 4. So as long as I is less than 4, we're going to keep going. And after every iteration, we're going to implement or increase I by 1. And now we'll access numbers of I. And let me just console.log this for you, so you really see how this works. And you can see we're still getting the exact same result, because during the first iteration, I0 will access numbers of 0, which is this value. We'll increment I by 1. We check is 1 less than 4, because numbers.length at the moment is 4. 1 is less than 4, so we'll again access numbers of 1, so 20. We'll increase I by 1 after the iteration, so we now have 2. We access numbers of 2. We increment I again. We now have numbers of 3. We are accessing this element, the last element. We are going to increment I. Now I becomes 4. Is 4 less than numbers.length, so 4. That is not the case, and therefore we'll break out of this loop. So as you can see, you can do the exact same by just using a normal for loop as well. A for of loop would just be a little bit easier. But nevertheless, it's nothing that is really necessary if you know how to implement the exact same yourself. And of course, under normal circumstances, you would use the for of loop because it's a little bit easier. But understanding that all of this essentially follows the exact same principle is really important. And that is all you need to know about for loops in JavaScript. Let's now understand nested loops. And nested loops are essentially just loops instead of other loops. Let me show you. Imagine we're having our loop that we already previously created. So for let I be equal to 0, we're going to do this loop as long as I is less than 3, for example. And after every single iteration, we're going to increment I by 1. And now inside of this for loop, we could also have another loop. So again for, and now we cannot use I again. So we should have another variable name, and a common name, so a convention, is to use j instead. So let j be equal to 0, for example. We're going to do this as long as j is less than 5, for example, and we are going to increment j by 1 after every single iteration. Now, let's always console.log I right here and j right here. So I'm going to say I is whatever we have for I, comma, and now I'm also going to log j right here for you, and j is of course our variable j, like so. And you can see we're getting this result. So we're getting I0, J0, I0, J1, I0, J2, and so on, so J3, 4, and so on. And then we're getting I1, J0, I1, J1, I1, J2, and so on. So how does this work? We're always going to start with the outer loop right here. So for the first iteration, I is going to be 0. We're going to go to the body and we'll execute this body right here. Instead of this body, we have our second for loop. So now I is 0 and j will now also be 0. We're going to do the inner loop as long as j is less than 5. And after every single iteration, we'll increment j by 1. So we're going to console.log I of 0 and j of 0 for the first iteration. We're going to get to this end for the inner loop right here. And therefore, we're going to jump to the beginning of this loop, after incrementing j, of course. So now j is 1 less than 5. 1 is less than 5. Therefore, we'll execute this here once again. I is still 0, but j is now 1. We're going to console.log that. We're getting to the end. Therefore, we're going to increment j. J is now 2. 2 is still less than 5. We'll execute this again. Increment j. J is now 3. 3 is still less than 5. Therefore, we'll execute this again. We increment j. J becomes 4. 4 is still less than 5. We'll execute this again. And again, we increment j. J is now 5. 5 is not less than 5 anymore. Therefore, we'll break out of the inner loop and get to the end of the outer loop. So now we're going to increment I by 1. So now I is 1. We're going to check if 1 is less than 3 essentially, which is of course the case. And we're going to start to loop over this loop here once again. So to go over this loop once again. Therefore, j is again 0 because we start executing this loop here once again. And of course we'll check is 0 less than 5, which is the case. Therefore now we'll execute this here again. But now I is 1 while j is now 0 again. So we go over the entire loop once again until j becomes 5 again. Then we break out of this loop and go on to the next iteration. So we increase I by 1 once again. So now I is 2. So it's actually pretty simple. We are going to start with the first for loop. And inside of the first for loop, we have another for loop. And of course, we have to go over this for loop inside of the outer loop for as long as this condition here becomes true, because we can never break out of this loop unless this condition becomes false. So we will iterate and iterate over this loop over and over again until this condition becomes false. And once this condition becomes false, we're going to go to the end of this loop essentially, so to the end of the outer loop, and we're going to increment I again and then check the condition again. And then a new iteration for the outer loop starts. And it also makes sense because you execute the outer loop, and for every single iteration of the outer loop, you have to do everything that is defined within the outer loop. So you have to execute the entire for loop for every single iteration of the outer loop. So I hope you get the idea. And this is something that can also be useful when you have nested arrays. So imagine we have a numbers array, like so. And now inside of this numbers array, we have 1, 2, and 3 as the first array. And then maybe 4, 5, and 6 as the second array, and 7, 8, and 9 as the last array, like so. So now this here is the outer array, and this here is the inner array, like so. And now we can first of all go over the outer array by using a for of loop. So for let r for array of numbers And now we're going to console.log r for now. And you can see we're getting one of those arrays for every single iteration. So we're getting an array. And now we can loop over this array once again by using a for of loop. So for let number of r, and we're just going to console.log each individual number. And now we're getting all of those individual numbers. So during the first iteration, so this for loop, we're essentially accessing each individual item inside of this for loop. So during the first iteration, this one, second iteration, this one, and third iteration, this one. And then during the first iteration, we are going to loop over every single item. So now during the first iteration, r holds this array right here. We're going to go to the second for loop, and during the second for loop, number will during the first iteration hold the number 1, during the second iteration, number 2, and during the third iteration, number 3. Then we are going to end this for loop because we don't have any items anymore inside of this array. Therefore, we're ending this, we're getting to this point, and now we're checking, does there exist another array inside of numbers? And indeed, we have this one. Therefore, r will now hold this one, so this array, as the next value. We're going to start this for loop again, and now number will hold 4 for the first iteration, 5 for the second iteration, and 6 for the third iteration. Once we finish doing this, we're again going to end this loop, going right here. We check, does there exist another array? And again, we have another array. So now r will hold this array, and we're going to do the exact same once again. So a nested for of loop can also be useful to loop over nested arrays. So to summarize, nested loops are just loops inside of other loops. And of course, you can also have loops inside of other loops inside of other loops. So I can nest loops as deeply as you like. Let's now understand how to convert strings into other data types. So imagine you have the string 10, for example. So just the text 10. But somehow you want to do an addition with a number, for example, the number 45. Doesn't matter. But at the moment, if you remember, this will not do a normal math operation. So if I'm going to add 10, so the string 10, to 45, we will get a different result. So we will get 1045. So how can I convert the string here to a number, for example? And in order to do so, we can parse this string to a number by using number like so, followed by opening and closing brackets. And inside of those brackets, we now need to define the value, as you can see. And in our case, it could be 10. And now we're getting 55. So this here converts this string, so this text, to a number. And now we can do mathematical operations with this string. We can also convert something to a float by using parse float. I'm going to save this. We're still getting the same result, but now I could also use 10.5, and we would now get 55.5. So this allows us to turn text into a decimal number, essentially. Now we can also convert a number to a string. So we could use string like so. And now as a value, let's use 10. And now again, we would get 1045. Because of course, now this here is just a normal text. And we could of course also turn this into a text, and it wouldn't change anything. Because once we have one string inside of a normal addition, everything will be converted to plain text. And adding the text 10 to the text 45 will always result in 1045, obviously. We can also convert something to a Boolean by using Boolean like so. And now you can see the number 10 gets converted to true, the number 5 gets converted to true, the number 4 or 3 gets converted to true, but the number 0 gets converted to false. Number -5 gets also converted to true, -10 as well, and so on. So only the number 0 will get converted to false, and that is something that is important to know. And for strings, it's pretty similar. If you have a normal string, this will be true. Doesn't matter what kind of string it is. If you have an empty string though, this will be converted to false. And this here is something that is important when working in web development, for example. Because by doing so, for example, when the user doesn't enter anything, you will always have an empty string. And now you can convert this empty string to a Boolean. The Boolean will be false. And therefore you can check whether the user entered something inside of an input field, for example. And if he did not enter anything, you can, for example, prompt the user to enter something. And knowing that an empty string will get converted to false essentially, and the number 0 will get converted to false as well, is something that is really important, especially if you work with if statements later on. Because now imagine you have a username, and that one is equal to an empty string, for example. You could now check if username, so if you have a username, and if you have a username, you can prompt or write, but else you can prompt or you can console.log username mandatory, for example. At the moment, the username is mandatory because we don't have a username. So this here is empty. This will get converted to false essentially, and therefore we will console.log username mandatory. Once I have npc right here, this will be interpreted as true. Therefore, if username is going to be true, because username is now true or will be converted to true, and therefore we can console.log alright. And this is really good to later on check whether a user has entered something or not. If a user did not enter something, we can always prompt them to enter something. And of course, the same works for numbers like 0, for example. So 0 will always be false, so username mandatory, whereas any other number will be true, therefore we are getting alright. Of course, doesn't make too much sense for the username, but I think you get the idea. So when using if statements, those conversions that we did previously will happen under the hood. But if you need to explicitly convert something the way we needed to do it previously, you can use things like, for example, string followed by a number to convert something to a string, or, for example, of course, number to convert, for example, text into a string, or, for example, Boolean to convert text into a Boolean or numbers into a Boolean, and so on. So those ones are really important. So to summarize, you can use those conversions right here, so Boolean, string, number, and so on, to convert strings or other data types into any other type. Let's now understand the map method. And the map method creates a new array by changing each value of an existing array. So let me show you. Imagine we have a numbers array. So numbers is equal, and let's have the numbers 1 to 5, for example, like this. But now maybe I want to loop over all of those numbers and create a new array at the same time, and every number inside of the new array should be twice as big as the old number. And in order to do so, I can use the map method to essentially map each old number to a new number in the new array. Let me show you. We can, for example, say numbers, and now every single array has the map method. So by using dot on this variable right here, so on this array, followed by map, we can access the map method on any array in JavaScript. Now we have to call this method by using the opening and closing brackets. And right here, Visual Studio Code also indicates that we have to pass a callback function. So this function will be called back over and over again for every single element. And as you can see, this callback function has the following syntax. You have the value right here as a parameter for every single iteration, and then you can do anything you like. Let me just show you. That's a little bit easier. So when using map method, we have to pass another function to this method that will be called back for every single value. And that is a new concept for us, but it's easier than you think. So let me just do it and then I'll explain it to you. So num goes to num times 2, for example, like this. And now I'm just going to store the result in new numbers, for example. So new numbers is equal to numbers.map, like so. Let me console.log the new numbers for you. And you can see our new numbers are just an array And every single number is just twice as big as the old one. So 2, 4, 6, 8, and 10 instead of 1, 2, 3, 4, and 5. So how does this work? As I already mentioned, a callback function is just a function passed to another function as an argument. So right here on the numbers array, we are calling the map method. And this map method expects a callback function. So we have to pass another function to this map method. And usually when writing callback functions, you use the arrow syntax to create that function. And now, right here by default, when calling the map method, JavaScript will always give us one individual item of this array for every single iteration. So this is somehow similar to a for loop, for example. So for the first iteration, this number parameter will hold the value 1. For the second iteration, it will hold the number 2. For the third one, the number 3, and so on. So during the first iteration, this here will hold number 1, and we're going to execute this function right here. So right here, we are going to say that we want to multiply num times 2. So we're essentially taking the old number, which is 1, and returning number times 2, so 1 times 2, which of course is 2. Therefore, we return 2. And then, since numbers.map, so since the map method returns a new array, we can store this array, so this first number, inside of this new numbers array right here. Then we're going to do the exact same for the second number. So now, second iteration, num is 2. We're again going to do num times 2. So 2 times 2, which is 4. And we return 4 and store it inside of this array, inside of our new array. Something that is important is that if you would use multiple lines like so, then doing it the same way would not work. So now you can see we're getting undefined, because you always have to return the result after every single iteration. So like this, it works. If we get rid of the bracket and write everything into one line, we can also get rid of the return keyword, because having it inside of one line and then using the arrow syntax together with that, it will automatically add the return keyword for you. So let me get back to the original version like this, and now it should work. Let me create a second example so you really understand how this works. So const tripled numbers, for example. Now again, I'm going to call the map method on my numbers array, like so. To this map method, again, I need to pass a callback function. For every single iteration, so every time we call back this function, we're going to get one of those numbers right here. And now I can just say that I want to multiply num by 3, for example, like this. And now the map method, in the end, once done, returns a new array that consists of all of the numbers that we just generated right here. So now I can console.log the tripled numbers, and I would get all of the tripled numbers. Of course, I can also do num times num, for example, and so on. So I think you get the idea. To summarize, the map method just returns, so creates a new array, by changing an existing one. Let's now understand the filter method. And the filter method creates a new array with matching values. So, to say it in one sentence, it essentially allows you to filter an array. Imagine we have a couple of numbers again. So maybe the numbers from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and maybe 10, like this. But now I only want to have the odd numbers, for example, or I only want to have the even numbers. So that is up to us. But I want to essentially filter out all of the numbers that do not fit this pattern. So if it is possible to divide a number by 2, for example, it's obviously an even number, and then I want to keep it. Otherwise, I, for example, want to remove it. So, again, similar to the map method, the filter method always returns a new array. So const filtered numbers is equal to, now, again, on the numbers array, we have to call this method. So I'm going to say numbers dot filter, like so. And similar to the map method, we also have to pass a callback function right here. Again, for every single iteration, the filter method will give us one of those numbers. So num might be a suitable parameter name, like so. And now, right here, we can create the filter condition. So now, what kind of circumstances do we want to return this value? So put this value into our new filtered numbers array. And under what circumstances do we want to filter it out? So we want to return this value if num divided by 2 is equal to 0. And in order to do so, we have to use the modulo operator, because that means there does not exist a rest. And if you can divide a number by 2 without having a rest, then this number is obviously even. Otherwise, it's odd. And now I can just console.log my filtered numbers, and you can see we're getting 2, 4, 6, 8, and 10. So let me show you how this works. During the first iteration, num will be 1, like so. And now we're going to say if 1 modulo 2 is equal to 0, but 1 divided by 2 is obviously 0 rest 1, therefore the rest is going to be 1, and the rest of 1 is not equal to 0, therefore we are not going to return this number and put it into our new array. For the second iteration, num is 2, 2 modulo 2 does not have a rest, therefore the rest is 0, 0 equals 0. So for that number, this condition becomes true, and we are going to put this number, so the number 2, into our new array, filtered numbers. Or to be precise, the array that we store within the variable filtered numbers. And now we're going to do the exact same for every single value inside of this array. And once we looped over all of those values, we essentially have our new array, so our filtered numbers array, that now only has our filtered numbers inside of it. Let me also show you what happens if I console.log the numbers. And you can see our numbers stay untouched. We still have the exact same numbers. So numbers.filter will not modify the original numbers array, but instead it will return a new array that we can store inside of a variable. And that is something that is really important. The map method as well as the filter method will never modify the original array. They will always create and return new arrays. So you use the map method to modify something inside of an array in a certain way, and you use the filter method to filter something inside of an array. Let's now take a look at the reduce method. And the reduce method reduces an array to a single value. So let me show you. Again, let's imagine we have a couple of numbers, like so. So maybe 1, 5, 10, 13, 2, 4, and maybe 29, like so. Doesn't really matter. And now imagine we wanted to create the sum of all of those values. In order to do so, we can use the reduce method to reduce all of those numbers to a single value. So again, we can use numbers.reduce. And reduce works similar to filter and map. You again have to pass a callback function. And for every single iteration, you now get a little more than just the current value. You get an accumulator, that's what you call it usually, later like so, and you get a current value like this. And the accumulator is essentially the value that you have during every single iteration. So this will always hold your value. Whereas the current value will always hold one of those values for every single iteration. And I will explain this later on in a little more depth. But for now, this is enough. Again, we can use an arrow function. And now we can, for example, just use accumulator plus current value, like this. And now, right here, we also have to pass the initial value, like so. Let me now store this result in a result variable, for example, and let me console.log the result for you. And you can see we're getting 64. So now let me explain all of this to you step by step. So right here, I'm calling the reduce method on the numbers object, so on the numbers array, which essentially is just an object in the end as well in JavaScript. Now Right here, I'm getting 2 parameters instead of only 1 parameter, as previously for the map and filter method. The first value, so the accumulator, will always hold our value, so the total value, the value we want to reduce everything to in the end. So for the first iteration, accumulator will be whatever we define right here as a starting value. So the last value essentially is our starting value. And for us, this one is 0. So the accumulator during the first iteration is 0. Then we have the current value. The current value will always hold one of those values for every single iteration. So during the first iteration, current value is 1. Now we are going to return for the first iteration the value of our accumulator, which is 0 during the first iteration, plus our current value, which is 1. So after the first iteration, we will return 1. 1 will be stored inside of our accumulator, and now our accumulator value is 1. Let's keep going. Accumulator value for the second iteration is 1. Current value for the second iteration is now 5. Now again, we have our accumulator of 1, and to this accumulator of 1, we add our current value of 5, and therefore we will now return the value 6. So now the new accumulator value that we now store inside of our accumulator is 6. Now, for the third iteration, accumulator is now 6, current value is now going to be 10. We again add our accumulator to the current value, so 6 plus 10, and it will therefore be 16. So for the next iteration, we will add 13 to our accumulator, so we will have 29. Then we will add 2 to our new accumulator, 31, 4 to our accumulator, 35, and 29 to our accumulator, so 35 plus 29, which is 64. And this is essentially the result that we're getting right here. And since I know that to a lot of you this here looks a little bit confusing, I want to make this a little bit easier for you, because a lot of people under those circumstances use a slightly different version of brackets. But I will show you. So a lot of people just say numbers dot reduce. Then they call this method, of course, and for the first one they use an accumulator, so the previous value, and a current value. Then you can use the arrow syntax right here, like so, and then a lot of people just prefer to use those brackets because this here makes everything a little bit more readable. Because now you can always say that I want to return accumulator plus current value, like so. And now after those brackets, you have a comma and you initialize your accumulator with the value 0. I'm going to save this. And now you can see this here is probably a little more readable to a couple of you. So this here is the initial value. So the starting value for your accumulator. And for every single iteration, current value will hold one of those values. And now I could also have a different starting value for our accumulator, so maybe 100. And now let me console.log the result for you. And we're getting 164. Because now our accumulator will start at 100. And for the first iteration, our accumulator will get added to the current value of 1. Therefore, after one iteration, accumulator will be 101, then 106, and so on. So it works the exact same way, you just have a different starting value. So to summarize, you can always use the reduce method to reduce an array to a single value. Let me now introduce you to the Foreach method. And the Foreach method runs a function for each array item. So it's somewhat similar to the map method, but it's also slightly different. So imagine we have an array, so for example numbers right here, and that one is probably equal to the numbers 1, 2, 3, 4, and 5, like so. And now, similar to map and filter and reduce and so on, we can use Foreach by using the numbers array, so by accessing our array, followed by the dot notation, and then followed by the for each method name, like so. Now we use opening and closing brackets, and once again we have to pass a callback function right here as an argument. Again, for every single iteration, we will get one number as a value right here. And now, when using the for each loop, we essentially can define what we want to do for each element. And therefore, the name is also for each. And something that we could do, for example, is just console.logging the number for each element. And now, once I save, you can see that we have all of those numbers in the console. Of course, I could also console.log num times 2, for example, or num times 10. So that is up to us. So I think you get the idea. For each just executes something for every single element inside of an array. So first of all, num will be 1 again. We're going to console.log the number times 10 for the number 1. So 1 times 10 is 10. And then the exact same for the other numbers. And that is all you need to know about the for each method. Let me now introduce you to the find method. And the find method returns the first matching value. Let me show you. Imagine we have an array of users. So const users is equal to this array right here. And inside of arrays, we can of course also store objects. So I'm going to store an object right here, like this. And now maybe the first object has a name, for example, or maybe a superhero name of Goku and a power level of 9000. Now we can duplicate this object twice. So every single object has the exact same structure. And the second one has the superhero name of Saitama, for example. That one has a power level of maybe 10,000. And for the last one, we have a superhero name of Spider-Man, for example. And here's a power level of 4000, for example, like this. And now we can use the find method on arrays to find an individual item inside of this array, for example. So we can say users dot find like this. And now right here, it expects a callback function once again. And for every single iteration, it once again will give us one of the individual items inside of this array. So for the first iteration, we will get this object. Second iteration, we will get this object. And third iteration, we will get this object again as a parameter. And a common convention is that you call this parameter just user, for example, if you have users, or if you would have superheroes, this here would be superhero, because you get one individual item essentially out of all of the items. So user right here. And now I want to return a user. So I essentially found a user if user dot superhero name is equal to Saitama, for example. Oops, let me just copy that one. So Saitama. And of course, I have to return this right here. And now we're essentially saying if the user.superhero name, so the user superhero name of the current iteration is equal to Saitama, then we are going to return that one. Otherwise, we're not going to do anything. So for the first iteration, user will hold this object right here. So user.superhero name is equal to Goku is user.superhero name of Goku equal to Saitama. That is not the case. Therefore, we will not do anything. For the second iteration, superhero user will hold this object right here. User.superhero name is therefore Saitama. Is Saitama equal to Saitama? That is true. Therefore, we are going to return the second object. So we will return this entire object when using the find method. And now I'm going to save this, and I can store this inside of a variable. So this here will essentially return the found user. So the .find method returns the found item essentially. So const found user is equal to users.find. And now I can just console.log my found user, for example. And you can see we're getting the user that has the superhero name Saitama and a power level of 10,000. So this here seems to work. So the find method is really useful if you're searching inside an array for a certain object, for example. And that is something that you will do a lot in the real world when you work with a server, for example. So this is really, really important, even though it might not seem like that at first. So to summarize, the find method just returns the first matching value, and that is important. It's also important to know that it returns the first matching value. So even if I have Saitama right here once again, and here's a power level of 11,000, like this, or doesn't matter, you get the idea, it will only return the first match. So it will only return Saitama, who has a power level of 10,000. So afterwards, it will not even check anymore for the rest. Let me now introduce you to sum and every. And sum checks if at least one value matches, and every checks if all values match. So it's pretty self-explanatory. Imagine we have an array of numbers, for example. And maybe we have numbers 1, 10, 15, 35, 100. Doesn't matter. So I think you get the idea. And now, on this numbers array, I can use the sum method, for example. Again, I can use numbers like this, dot sum, for example. So this is a method. And this one again expects a callback function. And once again, for every single iteration, we will get one of those numbers. So num, for example. And now let's use an arrow function. And right here, it will return true if the following condition is true, for example. So right here, we can define a condition. So maybe num is greater than 15, for example, like this. And now let me just store the result. So const sum pass, for example, is equal to numbers.sum. And now let me just console.log sum passed right here. And we're getting true in the console. Let me get to 150 and we're getting false. So sum will always return true if at least one number fulfills this condition right here. And it will return false if none of the numbers fulfills this condition. So to summarize, sum takes a callback function right here. Again, for every single iteration, num will hold one of those values. So for the first iteration, this num right here will hold the number 1. It will check whether num, so number 1 right now, is greater than 15. That is not true. Therefore, we will return false essentially. And we will do this for every single number right here. And once this here matches for one number, so once one number is greater than 15, so it fulfills this condition, we are essentially having true right here, and sum passed will automatically be true at this point, because this condition only needs to be true for at least one number. So if I'm going to say greater than 30 or 40, for example, this here will still be true, because 100 is greater than 40. The other numbers don't fulfill this condition, but it's enough if 100 fulfills this condition. On the other hand, we can also check whether all passed by using the every method right here. So all passed is equal to numbers, so numbers.every, like so. Again, we will get one number for every single iteration. Of course, we again have to pass a callback function. So the syntax is pretty similar to sum, or pretty much the exact same. And again, we're going to return true if number, so num, is greater than, let's say, 100, for example. Now, let me console.log all passed right here. We're getting false, because not every single number passed. Let me also do something like 10, for example. We're still having false, because 1 didn't pass this condition, and 10 didn't pass this condition. So even if I'm going to do 9, for example, we are still having false, because now 1 does not fulfill this condition. And once I go to 0, for example, we will get true, because now every single number inside of this array is greater than 0. So 1 is greater than 0, 10, 15, 35, and 100. So I think you understand how this works. Sum will check if at least one value fulfills the defined condition right here, whereas every will check whether every single value inside of this array fulfills this condition right here. And that is important to understand. So to summarize, sum checks if at least one condition matches, every checks if all values match. Let me now introduce you to the sort method. And the sort method sorts array values. So imagine we have a couple of names, for example, inside of an array. So superheroes is equal to Goku, Vegeta, Saitama, and Spider-Man, like this. And now I can use the sort method to sort them. So superheroes dot sort, like this. And now let me console.log the result for you. So console.log of superheroes.sort. And you can see we're getting the superheroes sorted right here. So Goku comes first because G is first in the alphabet. Then we have Saitama, Spider-Man, and Vegeta last. So for names, it just sorts the names alphabetically. Now we can also sort numbers, and that is a little bit different. So let me, for example, create a numbers array. So numbers is equal to 1, 4, 10, 3, 2, 15, 100, and so on. Now let me console.log the result of numbers.sort, like this. And you can see it doesn't really work. So it somehow, first of all, takes everything that starts with a 1, 1, 1, 1, then 2, 3, 4. But maybe we only want to have the smaller values first and then the bigger ones later on. And in order to do so, we can pass a callback function to the sort method. In order to do so, you often use a number A and a number B. And I will show you how this works in a second. But for now, let me just show you the result. And let's just return A minus B, for example. And you can see we're getting this order. So now it's ordered. So what is A and B? A and B are parameters. And every single parameter right here will hold one of those values for every single iteration. So during the first iteration, A will hold the number 1. So A is equal to 1, whereas B is equal to 4. Now we're going to subtract 4 from 1. So we essentially have minus 3 as a result. Because 1 minus 4 is minus 3. And since the result is negative, we know that 1, so parameter A, is less than B, and therefore this order is fine. And now, if this here would be positive, then we would know that the second number is bigger, so B is bigger than A, and therefore it would then change position of B and A. So it would essentially move B to the front and A right here to the back. And now we would go through this entire array and do this over and over again. So now for the next iteration, A is 4 and B is 10. Again, 4 minus 10 minus 6. Since we have a negative value as a result, A must be smaller than B, and the order is therefore correct. Now the same for 10 minus 3. This time we get a positive result. Therefore, A must be greater than B, and we should change order. So now 3 would be right here, and 10 would be right here. Now again, we would compare 10 to 2. 10 is greater than 2, so again the result would be positive. So we would have 2 right here and 10 right here. And this would go on. And now you see after one iteration, it's a little bit better. And at the end of the first iteration, the greatest number, so the biggest number, will be to the right. But this here is still not perfectly sorted. So you have to do this again and again. And after every iteration, you essentially can move one step further to the left. You don't have to understand this algorithm in depth, but it's important that by the end of this algorithm, all of those numbers will be sorted. So next iteration, this here is again fine, but this number here is less. So A will be 4, B will be 3. We get a positive number, and now 4 would move to the right, like so. And now this here would become 2, this here 4, and now this is ordered. So I think you get the idea of this algorithm. Again, you don't have to understand this perfectly. As long as you know this formula right here, this is perfectly fine. And if you want to have a reversed order, you just do B minus A, for example, like so. And now the greatest number is to the left, and the smallest number is to the right. So the exact algorithm that JavaScript uses right here to sort those numbers depends on the browser and the engine in the end. So the sorting method I showed to you is just an example, but that is something that allows you to visualize what is happening under the hood a little bit better. So the important takeaway is just that the sort method sorts array values. Let's now do a practice project together. And in this project, we will create a to-do list in the console. We first of all want to create a to-do class that allows us to create a to-do that has a title and a completion status. I also want you to add a function for adding, removing, and showing to-dos, as well as completing to-dos. We will store multiple to-dos inside of an array. Let's start by creating the to-do class that contains title and complete status. So we have a class to-do, for example, and we first of all have to define the constructor to construct our to-dos, like so. Inside of the brackets, we accept a title, like so. And now we want to say that this dot title is equal to our title, and this dot completed, for example, is by default equal to false. Later on, we also want to be able to set this dot completed to true. So we can create a function, or a method to be precise, that has the name complete to do, for example, like this. And inside of this method, we just say that this dot completed is equal to true, for example. So this is now the blueprint for our to-do. We now need to be able to create to-dos, so add to-dos. For example, to an array where we store all of our to-dos. So now we could say const to-dos is equal to an empty array by default, because by default we do not have any to-dos. And now we create a function to add to-dos to this array. So we have a function, for example, that has the name add to-do, opening and closing brackets, and those brackets for the body right here. And now to this to-dos array, we want to push a new to-do. In order to do so, we can say to-dos dot push, like so. And right here, we now need to pass our to-do. In order to do so, we could, for example, create a new to-do inside of the function by using the new to-do syntax right here. And now we need to have a title. We could accept this title as a parameter right here for the function. And now just pass this title right here that we accept as a parameter to our constructor method, which will then use this title to set this dot title to whatever we pass right here. So that is possible. And now we can just take this to-do and push it to our to-dos array, so to this array, every time we call this function. And now let me just console.log to-dos right here. So to-dos, we're having an empty array at this point in time. But now I can call the add to-do function, and as a title, I could, for example, pass learn to code. I'm going to save this, and now we have one to-do. That one is an object, and as you can see, completed is false, and the title is learn to code. So this seemed to work. We can also create multiple to-dos. So go gym, for example. Now we have two to-dos. And now the first one has a title of learn to code, and the second one has a title of go gym, for example. Next up, we want to add a function that adds the completion status of our to-do. In order to do so, we can, for example, use this complete to-do function on a specific index, for example. So function change completion status, we expect to get a certain index. So at which index position inside of our to-dos array is the to-do that we want to modify. So we're going to use those brackets. We're now going to access to-dos of index. So if we pass, for example, 0 as an index, we will access the to-do at this index position right here that currently has the title learn to code and completed false. And now we are going to use the dot notation to access the complete to-do function right here that will essentially just set this dot completed to true, like so. I'm going to save this. Now let me use change completion status, and for the index I'm going to use 0, for example, so the first to-do. Let me save this, and you can see now this one has a completed status of true, whereas this one should still have a completed status of false. I could also change the completed status for the second element by passing index number 1. And now we are having completed true and completed true. So change completion status now works as well. And now we also want to remove a to-do. So function remove to-do. Again, we have to accept an index. And for this, we need to learn about a method, an array method, that we didn't learn up to this point. And that one is the splice method. But it's actually not that hard. We, of course, have to access our to-dos array. And then on this to-dos array, we call the splice method. And right here, VS Code already gives you a suggestion what this method expects. It first of all expects a starting index and a delete count. As a starting index, we can of course use our index, so the index that we're expecting to get right here. And now, as the second argument, we have to define the delete count. And for us, the delete count will be 1 because we want to delete one element. Let me save this. And now, after adding those to-dos, let me, for example, just remove a to-do at index position number 0. This one should be learn to code. I'm also going to delete this here. And now we will delete the first to-do after we added that one. I'm going to save this one. And you can see we only have one to-do at this point. And that one is the go to gym to-do. So the second to-do that we've added. Because afterwards, we remove the first one, so learn to code. And I know this project can be a little bit confusing at this point, but I'm sure if you try it on your own, you will learn a little more about JavaScript in general and how everything works. And if you didn't understand everything up to this point, it's not that bad. You can just keep going and you will have a lot more time to practice and understand everything. Let's now understand the REST operator. And the REST operator collects multiple values into one single array. Let me show you how this works. So imagine we have a function, for example, to create the sum. So to add a couple of numbers, for example. So we have num1, num2, maybe num3, doesn't matter. And at the end, we're just going to return num1 plus num2 plus num3, for example, like this. And now I can always just use add numbers. I can pass my numbers, so maybe 10, 30, 45, and so on. Of course, I can now console.log the result of this function call. So console.log add numbers, and we're getting 85. But what if I now want to do the exact same, but I want to use 4 numbers maybe? As you can see, this doesn't work. It still prints 85 because it only expects 3 parameters. So isn't there the possibility to get a variable amount of parameters? And under those circumstances, we can use the REST operator. You can use the REST operator by using 3 dots, like so, followed by a parameter name. And that parameter name is up to us. So it could be this, could be this, it could be anything. But I'm going to use a descriptive one, so numbers. And now let me just console.log numbers for you once I call this function. So let's call add numbers like so, and let's for example use 10. You can see we're now getting an array that includes the number 10 right here. Let me add 10, 21, 30 or 24 for example, and so on. So now we have an array that contains those 3 numbers. So by using the REST operator, we can use as many numbers as we want, and all of those numbers will now be stored inside of an array. And of course, this here works for everything. This could also be fruits, this could be sports, and so on. So this doesn't need to be numbers. But then we would have to use sports, of course. And it might also make sense to then add, for example, sports, so basketball, football, and so on. But for us, let's stick with numbers. So numbers like so, because maybe we want to add a couple of numbers. So 20, 30, 40, and 50. And now we can use the REST operator together with the reduce method, for example, to add all of those numbers. So numbers dot reduce. Again, we need to pass a callback function. We'll have an accumulator, and a current value. That one goes to, and if you see this symbol right here, this arrow symbol, you can also read it as goes to. So accumulator and current value goes to, and let's return accumulator plus current value, and let's initialize our accumulator with 0 like this. And this here has been formatted the wrong way, so it needs to be inside of a bracket like so. And now let me just print the result of add numbers like this. And of course, this function also needs to return the entire result. So there needs to be a return as well. And now we're getting 140 because 20 plus 30 is 50, plus 40 is 90, plus 50 is 140. So I think you get the idea. You can always use the rest operator to collect multiple values, especially if you don't know the exact amount of values that you want to collect, or have variable amounts of values every time you call this function. And then those values will be stored inside of an array, and you can access those values just the normal way you would access any array essentially in JavaScript. And then you can work with them the way you like. And that is all you need to know about the rest operator. Let me now introduce you to destructuring in JavaScript. And destructuring extracts values from arrays or objects, for example. So let me show you. Imagine we have an array that holds a couple of colors, for example. So const colors is equal to red, blue, and yellow, for example. But now I want to have those colors instead of individual variables. So I could, of course, say const red is equal to colors of 0, for example. Now I can console.log red, for example. And you can see we're getting red in the console. Now you would have to do the exact same for blue, for example. So colors of 1, like so. And now I could also console.log blue, for example. And we are getting blue in the console. And I think you get the idea. So this here would be kind of time consuming. And in order to fix this problem, we can use destructuring. So destructuring will extract the values in a much faster way from an array, for example. In order to destructure for arrays, we use those brackets right here instead of the variable name. And now we can just, inside of those brackets, define the variable names. So maybe red, blue, yellow. And now I'm going to use an equal sign. So again, pretty similar to a normal variable, I'm now assigning a value, and this value is equal to colors. And now it's essentially taking a look at colors. What is the first value? The first value is red, so we destructure this value into the first value that we have right here. So into the first variable that we have right here. So now red is going to be equal to red, blue is going to be equal to blue, and yellow is going to be equal to yellow right here. So the value yellow will be assigned to the variable yellow. Let me console.log red for you. So again, red is red, blue, and yellow. And now those variables right here have these values assigned to them. And of course, this could also be R, B, J, for example. So just a little bit shorter. Of course, this is bad practice because those names do not really express anything in a proper way. But I think you get the idea. So by destructuring, so by using this syntax, you can essentially extract the values of an array, for example, and store them inside of individual variables. And you can do the exact same for objects, for example. So I can have an object, so for example, a user object, which is equal to maybe a user that has a username of NPC and an age of 28 and an IQ of 40 and has big biceps of 100, for example, like this. And of course, I need a colon right here. Now, if I want to destructure an object, I have to use those brackets instead of those brackets. So now I can again define my variables, so const, and the rest is pretty similar. So again, instead of those brackets, I use these brackets to destructure an object. And now I just have to define the keys right here. So the keys need to match the keys right here. So for object destructuring, this here needs to be a username and cannot be something else. So it's really important that the key is the exact same. You can also destructure age and maybe has big biceps. And now this is equal to our user object, like so. Let me console.log has big biceps, for example. We're getting 100. I can also console.log the age, 28, and the username, and I'm having NPC. But maybe you want to rename those properties right here. So you first destructure, and then you can rename this by using a colon followed by the new name. So this can be anything. This could be this right here. And now let me console.log this right here. And we're having the same result. So if you want to rename, you use a colon followed by the new name. So this could be player name, for example. I'm going to console.log player name, and you can see this works. So you can just destructure it like this, and then the new variable name will be the property name that we used inside of our object, or you can define a new name after a colon, for example. So I think you understand how this works. So I can destructure arrays or objects in JavaScript and get the values from an array or an object and store it inside of an individual variable. And that is all you really need to know about destructuring in JavaScript. Let me now introduce you to the spread operator. And the spread operator expands arrays or objects. So let me show you. Imagine we have a numbers array like this. So 1, 2, 3, 4, 5, for example. And maybe now I want to create a copy of this numbers array. In order to do so, I can use the spread operator. So I'm going to say const new numbers is equal to, I'm again going to use an array. And now I can essentially spread those numbers right here from the numbers array into my new numbers array. So I'm essentially using 3 dots right here to access the spread operator, followed by the variable name. And this essentially says, take this array and spread this array right here. So essentially spread those numbers. So this syntax is equivalent to taking those numbers and spreading them in here like this. So this is what this essentially says. Like so. Let me now console.log the new numbers right here. And you can see this is the exact same array. So you can use the syntax to create a new array. But now you can also add other numbers. So I could say 100, 95, and so on. And now you have this result. So I first have 100, then 95, and then all of the numbers that you spread it right here. And you can also add some numbers right after, like so. And that is how this works. So the spread operator essentially takes something out of an array and spreads it at the position where you essentially use the spread operator. And now you can use the spread operator for objects as well. So imagine we have a user. So const user. Let's keep this simple again. So we have a username of NPC codes and an age of 28, like this. And now I have an updated user, for example, like so. And now I just want to copy or spread all of those key value pairs into my new object essentially. In order to do so, I can again use the spread operator like this. So 3 dots followed by the object name. I'm going to save this. I'm going to console.log the result of updated user. And you can see we essentially have the exact same object. The only difference is that it's of course a different object, but we have the same key value pairs. I can also add a biceps size, for example, right here. And you can see our new object now also has a biceps size, so our updated user. We could also add something like this smart, this is false, and so on. So I think you understand how this works. You can always use the spread operator, and then you essentially spread the properties or the values into a new object or into a new array. So that is how this works. So to summarize, the spread operator allows you to expand arrays or objects in JavaScript. Let's now understand error handling in JavaScript. When writing code, of course, there can always occur an error, and error handling prevents the code from crashing. Let me show you. Imagine you wanted to access a variable that doesn't even exist. So we're going to console.log npc, for example. npc shouldn't be part of this program because we didn't define npc anywhere. So we're getting an uncaught reference error. npc is not defined. And this error would now crash our program. Therefore, our program wouldn't execute anymore. So imagine afterwards, I wanted to say, or console.log, hello guys, for example. I'm going to save this, and we're never reaching this line, hello guys. So once the program crashes, nothing afterwards will be executed. But oftentimes, you want to execute some other code afterwards, even if there is an error. For example, if you try to connect to a server, essentially, it could happen that the server is currently down, for example, and then you will get an error. But under those circumstances, you, for example, don't want the entire program to crash. You maybe just want to output an error message and then do something afterwards. So a crashing program is never something that is good. You always want to handle errors in a controlled way. And in order to do so, you can just use a try-catch block. Inside of the try block, you define what you want to try, and inside of the catch block, you define what you want to do in case there occurs an error. Let me show you. You always start the try block by using the try keyword. Then you have the body inside of opening and closing brackets again. And right here, I could, for example, try to console.log npc. I don't have npc right here, therefore this will not work. And in order to catch this error now, I should use a catch block right here. By default, JavaScript will always give us an error object that we can essentially accept right here as a parameter. And now I could, for example, just console.log the error like this. And now we're getting this reference error. Error is not defined. But you can see that the error message is already different. And the reason for this is that we're just console.logging the error object right here. We could also just say something went wrong. So wrong, like this. And now we're getting something went wrong in the console, but our program is not crashing anymore. And if I would now have another console.log statement afterwards, so hey guys, for example, we would see this statement in the console as well. So our program now tries to do this, but even if this doesn't work, we're just going to execute whatever we have in the catch block, and afterwards we are just going to keep executing our code the way we would do usually. So try-catch blocks are really important to prevent your program from crashing. And now you can always, of course, also access this error object to get more information about the error, for example, as we've already seen, like so. And now something that you can also add to every try-catch block, something that you don't have to add, but something that you can add, is a finally block, like this. And now you could always say, okay, it has been executed, for example. So this is just an example, but you will see how this works. So we're getting this error, but we're also getting, okay, it has been executed. And let me delete hey guys. So the finally block will always run. If this try block there is successful, this block will always run afterwards. And if you get an error, this block will also run afterwards. So finally will always run. Finally will always be executed. So in case you have something inside of your program that always has to be done, whether your code works or whether it doesn't, then it belongs into the finally block. So if I would now have, for example, const npc is equal to npc, for example, so now I have this variable, you can see we are now executing the try block and also the finally block. And of course, you can use try, catch for pretty much all sorts of things. But now let me also show you something else. Imagine, again, we have a try catch block. You can also, in VS Code, click on this try catch block right here, or statement to be precise, and then it will generate a basic try catch block for you, like so. I'm just going to delete all of this because I do not need it. I'll also delete this variable. And now imagine you're doing something where you have a couple of different possibilities. So maybe you have a number and that one can be equal to 10, for example. Now you're checking if number, for example, is not equal to 0. If that is the case, then you maybe want to say console.log 10 divided by number, for example. Because if the number is not 0, we can essentially divide 10 by our number. Otherwise, we, for example, want to throw a new error. Because usually, if I would just do it the normal way instead of JavaScript, like so, this division by 0 is not really an error. So let me show you. Right here, let me just console.log the error for now. Doesn't really matter. And at this point in time, we're getting 10 because 10 is our number, and 10 divided by 10 is of course 1. If I now would say 0 though, we would now say 10 divided by 0, and we're getting infinity. So that is how this works in JavaScript. We're not really getting an error. And of course, this here is a pretty unnecessary example, but in the real world, from time to time, there exist things that will not really throw an error on their own, but maybe you want to throw an error under those circumstances. For example, if the user doesn't enter a password, for example, you want to execute whatever you define in the catch block. So you don't want to keep executing this try block. And under those circumstances, you could just say throw new error, and this will now create a new error or create a new error object and will immediately redirect to this catch block. And now you can also define an error message inside of those brackets. So this is wrong, bro, for example. I'm going to save this. And now we are constantly logging the error. And as you can see, we're getting this is wrong, bro, inside of the console. So by using throw new error, you can immediately stop the code from executing and redirect to the catch block. So even if I would have something else right here, like this here will never get executed because throwing a new error will immediately redirect to the catch block. So from time to time, JavaScript will not throw errors on their own because probably the error is not predefined whatsoever. And then you can throw the errors yourself and therefore do whatever you have defined inside of the catch block. And this is something that is actually a lot more common than you might think. You could, for example, implement error handling, so maybe showing an error message to the user inside of the catch block, and every time the user tries to submit a form without having anything inside of the username field, for example, you could just throw a new error. You could, for example, say username is mandatory, and now right here you could, for example, inside of the catch block, just display the error message to the user, so username is mandatory, for example. Then you could do the exact same for maybe password is mandatory or required and so on. So I think you get the idea. And of course, those are just examples. It always depends on the situation. So to summarize, error handling in general prevents code from crashing, and throwing a new error can always be helpful if you want to execute whatever you have defined inside of the catch block. Let me now explain JSON to you. And JSON is used to store and exchange data. If you think about data, so for example, about the data of a certain user. Imagine this user has a username, NPC, and a power level of 100,000, for example, and a sub count of maybe 1,300, like so. We now have this user object. But if you want to send data to a server, for example, so store data on a server, you will usually transform this data into something else and then store this data in a different way on a server. So later on, when you need this data again and receive it from the server, the data will of course also have a different format. So you somehow need to be able to transform this normal JavaScript object to something else that you can store on a server. So something that you can exchange with a server. And that is what JSON is used for. JSON stands for JavaScript Object Notation. And usually, before transferring data to a server, for example, you will turn this normal JavaScript code, so this JavaScript object, to JSON code, essentially. Let me show you. We can create JSON data by using JSON.stringify. We have to pass as a value our object, and now this will transform normal JavaScript code, so a normal JavaScript object, to JSON data. I'm going to console.log the result of this for you, and you can see this is what we're getting. So this data looks really, really similar to a normal JavaScript object. But as you can see, it is also slightly different. If you take a look at our normal object, let me also console.log that one for you. So let's take a look at our normal user object. You can see we always have key value pairs. If we take a look at the JSON data, it also seems pretty much like key value pairs. So we always have username, NPC, power level, and so on. But if you take a close look at this right here, so at JSON data, the keys are always inside of quotation marks. So the keys are inside of quotation marks and the values are inside of quotation marks. So the text values are inside of quotation marks. Numbers, for example, aren't, but that always depends on the form of the value. But the keys are always inside of quotation marks. And that is a key difference to normal JavaScript objects. And JSON, of course, looks pretty similar to JavaScript, so to normal JavaScript code. And the reason for this is, of course, that JSON is just JavaScript object notation. So it is, in the end, pretty similar. You can also create JSON files yourself. And let me do it for you so you really understand how this works. So data.json, for example, the file name is of course up to you, but every JSON file ends with a .json extension. So now we created a JSON file. Usually you write JSON data inside of those brackets right here, so opening and closing brackets. And inside of those brackets, you can now define your key value pairs. So I could have a key username, for example, and the value for username would be NPC codes. You could have a sub count, that one could be 1300. And you could, for example, have a variable is broke, so a key is broke, and that one could be true, like so. So you separate each key value pair inside of JSON by using a comma, but the last key value pair doesn't have a comma. So that is the normal structure. And now this is normal JSON data. And usually when you send the data to the server, this is the form that the data will have. So this is what you will store on the server. Later on, when you want to get this data again, you will get this JSON data back from the server, and then you somehow have to convert this JSON data back to normal JavaScript code. So back to normal JavaScript objects. So that is the process. And let me also draw this for you so you really understand this. For example, if you have a user, he's accessing your website on a PC, for example, like so. And then on his PC, inside of his browser, he's running JavaScript, so right here essentially. And then maybe you want to store some data on a server, so on a web server, like this, for example. And a web server, in the end, is just a big computer, essentially. So even your own computer could be a web server, but usually the web server is a more powerful computer. But it's just important to know that any computer can serve as a server or as a client. But you will understand more about servers in my PHP course. For now, just remember that this is essentially your computer or the computer of your user, and this is a web server. So a server where you store data, for example. So user data maybe, or forms of data. That's up to you. And now you maybe want to store some data that the user entered, for example, on a web server. And in order to do so, you can convert the objects, so your JavaScript objects, to JSON code, and then you store this JSON code on the server. Later on, when you need to get this data back from the server, you will get JSON data back from the server. And of course, before storing the data on the server, you need to convert your JavaScript objects to JSON code, so you can store them on the server. And later on, when receiving the JSON code, you somehow need to go back from JSON code to normal JavaScript code, so to JavaScript objects. So that is the core principle. And now let me close this. So now we could create this JSON data by using json.stringify. We could store this data on a web server, for example, and later on, we might get this data back from the web server. So let me make something that is pretty similar. We're going to store this JSON data inside of a variable. So user JSON, for example, like so. So now we stored this JSON data inside of the user JSON variable. So console.log user JSON. This is what this currently looks like. So just normal JSON data essentially. But now I need to go back from JSON data to normal JavaScript objects. Because later on, when I would receive data from the server, I would have to convert this JSON data back to normal JavaScript objects. So let me store this inside of a user object variable, for example. And now I can go from JSON to plain JavaScript by using JSON.parse. So this will allow me to parse JSON data. So I'm going to parse our user JSON variable right here that includes JSON data, like so. And now I'm going to console.log user object, like this. And now you can see this here is again a normal JavaScript object. I'm also going to console.log user JSON. So you see this side by side. And this here is now the JSON data, and this is our JavaScript object. So by using JSON.stringify, we can create JSON data, and by using JSON.parse, we can go back from JSON data to normal JavaScript data or JavaScript objects again. And that is really important, especially when working with servers. Because, again, if you want to store data on a server, you convert it to JSON data. And when receiving data from a server, for example, you will have to turn it back from JSON to JavaScript. And those are the most important things you need to understand for now. If you didn't get everything at this point in time, it's not that bad. I will explain this a lot more later on in this course. Let me now introduce you to callback functions. And callback functions are functions passed into other functions. What do I mean by that? Let me show you. So imagine we have a function to greet a user. And then we have a function that calls this greet user function. And that's a simple example that might not make too much sense at first, but it's really good to understand how callback functions work. So imagine we have this function that greets a user, for example. So greet user like this. And this one just console.logs hello bro, for example, like this. And now we have another function that calls this function. So function call greet user, for example. And this one now expects a function. So we say callback right here. And inside of this function, we're just going to execute our function. So our callback function like this. So we expect to get the function as a parameter. And then instead of the function body right here, we essentially execute this callback function. So now I can call greet user. So I can call the call greet user function. So this one, as an argument to this function, I pass the greet user function right here. And now I'm going to save this. And you can see we're getting hello bro. I could, of course, also create another function, for example, to insult the user, for example. And now I could console.log you are dumb, for example, like this. And now I can call the call greet user function and pass greet user to this function. But I can also pass insult user to this function. And now one time we are greeting the user and the other time we are insulting the user. So depending on which function we pass, we get a different behavior for a call greet user. So that is the basic concept. And this here might seem unnecessary at first, but under the hood, instead of JavaScript, we use callback functions all the time. If you remember the map method, for example, so let me show you. Const numbers 1, 2, 3, and 4, numbers.map, for example, you can see that Visual Studio Code already indicates that this here is a callback function. And indeed it is, and it also makes sense, because right here, we are just passing another function to the map function. So right here, we just pass this function to the map function, and for example, say that we want to have num times 2. So this here is just a function inside of another function call. So this here is a callback function. And even without knowing, you will use callback functions a lot. And that is the basic principle about a callback function. So to summarize, callback functions are just functions passed into other functions. Let's now understand promises. And promises handle code that finishes later. So essentially code that will finish in the future. And it is somewhat similar to tasks, for example, in the real world that finish in the future. If you think about an order at a restaurant, for example, you're going to order, the waiter is going to take your order, and in the end, he will either accept the order or he will reject the order. So you're either going to get the pizza or you're not going to get the pizza. So one of those two cases is going to happen. And the promise is pretty similar. You want something that will happen in the future, and in the future, this will either be accepted or it will be rejected. And depending on what case is going to happen, we can define, using JavaScript, the code that should be executed. And let me just show you how this works, because this is probably a little bit easier. So I'm going to create an order pizza variable right here, which is equal to a new promise, like this. So by using this syntax, we can create a new promise. Inside of this promise, we can now again pass a callback function. And by default, JavaScript gives us a value for resolve and for reject. So the first one is resolve. So the first parameter that we can get is resolve. And the second one is reject. And you will understand this in a second. Right here, as a callback function, we of course pass an arrow function like this. And now we are going to have a variable inside of this function essentially. And that one can have the name let order successful, for example, be equal. And for now, let's say it's equal to true. So the order has been successful. We essentially got our pizza, for example, like this. And maybe pizza available is a more descriptive name. And now we can check if pizza is available. So if we did get our pizza, then we can essentially call this resolve parameter right here, like so. And this again is just a function that we can call, and we can also pass a value. So your order has been successful, like so. If the pizza is not available, so else, we can reject this right here and say your order has been declined, for example, like this. And by taking a look at this, you already understand how a promise works. We can create a promise by using the new promise keyword. And if you take a look at this, this here is pretty similar to the normal constructor that we call when creating an object. And in fact, in JavaScript, most things are objects, so this also makes sense. So right here, we are just creating a promise object. This promise object expects to get a callback function as a parameter. And right here, JavaScript allows us to access the resolve parameter and the reject parameter inside of our callback function, like this. And whenever we do something that should resolve our promise, then we can use the resolve function right here and pass a message to this resolve function. And whenever we want to reject the promise, essentially, we can use the reject function and pass a message right here. So a promise essentially says that we promise that in the future, the result will either be resolved or rejected. And in the future, so right here, for example, we're going to say that the promise is now resolved. And right here, in the future, we are saying that the promise right here is rejected. So that is how this works. And I will also show you a better example later on. But for now, just remember that a promise is something that you can use if the result is not available at the moment. And only in the future, it will either be resolved and rejected. And we can define what we want to do for both circumstances. But of course, right here, we only define a promise. We also need to call a promise. And we can do so by calling order pizza, like so. And then you can define a then block right here. This one, again, is a function. And inside of those brackets right here, we can now again define a callback function. And again, let me do this first of all, and then you will understand this. Right here, I'm getting the message, like so. And let me just console.log the message, like this. And now we can also chain the catch method right here. And right here, we are getting an error. And we can just console.log the error for now. As you can see, your order has been successful. If we now set pizza available to false, your order has been declined. So this seems to work. But now let me explain everything to you step by step. Right here, we are defining the behavior of our promise. So we are saying that we want to create a new promise. We also define the conditions if a pizza is available, so that we will resolve the promise if a pizza is available. And we also define the other condition, so that we will essentially reject the promise if a pizza is not available. Right here, we're essentially executing the promise. We're executing this promise, and since pizza is available is equal to true, we're jumping into this if condition right here when executing this promise. And right here, we are resolving this promise. And resolving this promise will then redirect us to the then block right here. So right here, we only define the conditions for this promise, and the actual things that we will do later on when resolving this promise will be defined within the then block. And when rejecting the promise, the actual things that we're going to do later on will be defined inside of the catch block. So right here, I could also say hello, for example, and now we will print hello every time we resolve this promise. And right here, I could, of course, also just print error, for example, every time we reject this promise. And now this will be the behavior. So again, instead of the new promise statement right here, we always define the behavior, and the actual things that we will do later on will be within the then block and the catch block. So right here, we essentially just, when calling resolve, say, execute the then block. And right here, when we reject the promise, we essentially just say execute the catch block. But this is not really the most practical example. And for now, I really want you to understand the basics. It's not really important for you to memorize this. It's important that you understand the concepts, because later on, we will use a different syntax anyways. So it's only important to understand that this here is something that will only happen in the future. When resolving the promise, we redirect to the then block, because this here is the future essentially, or we reject and redirect to the catch block. So this here is also the future. Those things right here will not happen instantly. And something where you use this, for example, is a server call. So maybe you want to get data from the server. And why is that something that will happen in the future? If you think about your connection to a server, you maybe want to get data from a server. So you're going to ask the server to get data. Asking the server takes a little bit of time because, of course, you have to send data via cable, for example, so through the internet. And this connection, of course, takes a little bit of time. Then the server has to process your request. It will decide what the response is going to be. Then it will send the response through the internet, which again takes a little bit of time, because in the end, information cannot travel faster than light, because oftentimes we transfer information via light, and nothing is faster than light. So it will at least take the amount of time that the light needs from your PC essentially to the server. But that's a little bit technical, so you don't even need to understand this. The only thing that is important is that sending the request to a server will take a little bit of time. Then processing your request will take a little bit of time for the server. So the server also needs some time to process your request. And then sending the data back to you will again take a little bit of time. So when sending the request to the server, maybe you want to get the profile of a certain user, takes a little bit of time. And you know that you will only get the response in the future. You will not get the response when sending it immediately. So there is essentially a delay between a request and response. And that is important because that is something where you can use a promise. You send a request to the server, and the server essentially promises that you will get the data in the future. And if you think about a server example, for example, you essentially create a promise. You then, for example, say, if the server responds with a positive response, for example, we're going to resolve this promise, and therefore we are going to redirect to the then block and execute whatever we define inside of the then block. Otherwise, if the server rejects our request, for example, we want to redirect to the catch block and execute whatever we defined right here. So this is essentially how this works. And now I will also show you this real example with a real server, for example. So then you might understand this a little bit better. So let me now show you a real example in the real world where we work with an API to get some data. And let me explain all of this to you by using a real example. So by using an API, for example. In our case, let's go over to Google and let's search for Pokemon API, for example. Right here, we're having the Poke API. like this. I'm also going to maximize this window. And now you can see that this here is the link to get a connection to this API. So I'm just going to copy this entire thing right here. I'll paste this into a new tab so I can show this to you and explain this to you. And as you can see, this here's what we're getting. And this here is essentially JSON data. So we already took a look at this. So this here should also be familiar to you. Let me make this a little bit bigger. So you see we have those key value pairs essentially. So this here's the key, so abilities, and the value is an array for abilities essentially. So what exactly is an API? If you think about your computer, for example, you're oftentimes running programs on your computer. And if you think about a server, I already told you that a server is actually just a normal computer. Usually it's a little more powerful. So usually a server is a computer that is pretty powerful. But that's most of the times the only difference between your computer and a server. But a server can also be a bad computer. So that's not really something that has to be like that. It's just something that usually is like that, because a server oftentimes should be a little bit more powerful to process all of the requests. But again, a server in the end is just a normal computer. And on this server, you can run a program. On your computer, you can also run a program. On the server, you might have slightly different programs, for example. So maybe on the server, there's running a program that, for example, processes your requests and then responses with the necessary data, for example. So maybe you're asking the server to get some data, for example, to get some user data. So for example, load a user that is currently logged in. Then you send this request to the server, and the server will reply with either the user data, or it will reply and say that you don't have access to this data, for example. And an API is an application programming interface. But in the end, it's essentially just a computer program that you're talking to. So you don't really have to memorize this complicated name. But the thing that you have to remember is that an API is just a program on another server, for example, that you're talking to. And this right here is an API, because right here, you're essentially sending a request to this API right here to get data. In our case, we want to get data about a certain Pokemon. So in our case, the Pokemon Ditto. And essentially, an API also has an address. So if you think about your house, for example, you also have an address. You have a street and you have a number. A URL is pretty similar to your house. It's just the address of an API. So maybe you're living in a certain street and have a certain house number, and this API right here has a certain URL. So the address of this API is essentially pokeapi.co/api/v2/pokemon/Ditto. And by entering this URL in the browser and pressing enter, we are essentially sending a request to this API, so to this program. This program will then, on the server, so not on our computer, but on a server, try to process our request essentially. It will decide whether our request has been valid, and if the request has been valid, it will send a response. And as a response, we're getting this data right here. So that is the data that the server sends us once we request the data. Of course, the server could also reply and say that we don't have access to this data, but right here we have access to this data because it's an open API that essentially shares its data with pretty much everyone. So by using this link, we can access the data from this API right here. And this data is just some JSON data. So later on, we already learned that we can turn this JSON data into normal JavaScript objects, for example. And of course, if you take a look, once I paste this link in here, and I'll press enter, you can see that it loads for a very short time. And that is the time that it takes for the request to get to the server, to be processed, and then for the server to send the response. So that is the time that it takes for our promise to either resolve or reject. But let me actually just close this for now. Let's go back to our website, and let me just show you a real example right here. Like this. Let's go to the console. Let me just delete all of this, like so. And now, if you want to do a request to a certain API, like the Poke API, for example, inside of JavaScript, you will always use the fetch method. So we can just use fetch right here. So that is a built-in method that the JavaScript team provides for us to, for example, ask an API for some data. And now we can, within those brackets, insert an input, like the URL right here. And now this will send a fetch request to this API right here. I'm going to save this. And now let me also just console.log the result of this, console.log fetch. And you can see we're getting a promise that is currently pending. But right here, you also see the promise state. So it is now fulfilled already. The promise result is a response right here. So we can see all of those things right here if we console.log our promise. So as you can see, this here just essentially sends back a promise. And now we already know from before that when we get back a promise, that we can always use then and catch, for example. Previously, we created this promise ourselves by using the new promise syntax, but usually you will not really do this. Usually things will just be a promise on their own. So this here is a promise already, so we don't have to create a new promise by using the new promise keyword, of course. And the promise will automatically either get resolved if the request has been successful, or rejected automatically if the request was not successful, essentially. And therefore, we can immediately just use then right here and decide what we want to do when the promise is fulfilled. And we can also chain the catch block right here and decide what we want to do if the promise has been rejected. Right here, we expect to get a response, for example, like so. And let's pass an error function. And for now, let me just console.log the response for you so you understand how this looks. And you can see this here is our response. This response is essentially an object that includes a body, headers, OK status, redirected, a status, and so on. And status code of 200 means OK. So the request was OK. So successful, essentially. But again, those things will be explained a lot more in my PHP course. For now, you just have to know that this response essentially gives us an object. On this response object, I can also access .json, like so. So I can use the .json method. And now you can see that we're getting another promise. So when using the fetch method, we're getting back a promise, which will then get resolved. So we're either going to call the then block, or it will get rejected. So we're going to call the catch block. But then, once we use response.json, this method right here will return another promise. So we first have a promise, and this here returns another promise. So we essentially have two promises in a row. First of all, this promise will get resolved, like so. And then we somehow also need to resolve this promise for response.json, for example. And under those circumstances, we can chain then blocks. So we need another then block right here. We should also return response.json right here. So that is also important. And right here, within the second then block, we then get the data. So let me console.log the data for you, like so. And now we're getting this data. And this data is just a normal JavaScript object, essentially. So we can just access this object the way we would pretty much access any normal object. So we can, for example, access data.name, for example. And now we would get D2, as you can see, because we, for example, have the name property right here. We can also access the order number, so 214. So once I'm going to access data.order, we will get 214 in the console, as you can see. I can also catch an error, for example, and say if I have an error, I'm just going to console.log the error, for example, like so. And now let me, for example, do this request to an invalid URL. This will take a short time, and then we're getting this error, 404. And 404, you probably know that from websites. 404 means not found. So this source there has not been found. I'm going to get the original state, it works again. And essentially, using the fetch method together with response.json and then data later on is something that you essentially just have to remember. That's just the way the web works, and pretty much any API call will work. Every time you request data from an API, you will first get this response right here. Then you will call response.json to transform the JSON data to an object, essentially. And this will return another promise. You can then chain another then block And right here, you will then get the data once the promise has been resolved, essentially. And now you can do pretty much anything you like with the data. So you could also store this data, or you could just log it the way that we did it right now. And I know this here can be a little bit confusing in the beginning, but once you did this once or twice, you will definitely just remember the syntax. And as I mentioned, pretty much every API call is the exact same. So you will just remember this pattern. And we will also learn about an easier way in the following lectures, so don't worry about it. I only want you to understand what a promise is, that it will be resolved or rejected at one point in time, and right here within the then block, you just define what you want to do once the promise is resolved, and in the catch block, you define what you want to do if the promise is rejected. And that is the most important stuff that you need to know about promises. So promises just handle code that finishes later, so in the future essentially. Let's now understand async and await. And async and await make promises easier to read. So essentially everything we did up to this point by using then and catch and so on can be replaced by using async and await. And they make everything a lot easier, and this is also the recommended modern syntax. So you should always use async and await, but understanding the core principles behind async and await, so promises in general, is nevertheless important. So it's important that you at least understood the concepts that we covered up to this point. If you forget how to implement then and catch and resolve and reject later on, it's not really that bad. So let me now implement our API call, for example, using async and await. So maybe we want to create a function to fetch data. So const fetch data, which is our variable, is going to be equal to this arrow function right here. And this here should be data. Or actually, we can also say fetch Pokemon, because that is a little more descriptive. Now we want to use a try catch block right here, because every time we call the server, there can occur an error. And we want to catch this error inside of the catch block. So let's just console.log the error inside of the catch block, like so. And now, inside of this try block, we can fetch the data. So again, we're going to use the fetch function that JavaScript provides, and we'll send a request again to this API here, so to this URL, like so. And now, instead of using .then, for example, and .catch, we can just say that we're going to await this right here. And await essentially means that we're going to wait for the result. And once the result is there, we can do pretty much anything we like with the result. And in our case, we will store the result, so the response, inside of a response variable, like so. So right now, let me go back to this page right here. And right now, we're just storing the response that we'll get at a certain point inside of this response variable. But you can see we're getting this error right here. So wait is only valid inside of async functions. So every time you use a wait inside of a function, you just have to mark this function as an asynchronous function. Because of course, now it's not synchronous anymore. It's asynchronous because fetching data takes a little bit of time. You send a request, you wait for a short time until you get the response. So remembering this is pretty simple. Every time you have to wait for something because it's asynchronous, so the task takes a little bit of time, you use await, and if you use await inside of a function, you have to use async in front of those brackets right here. So you have to mark that function as asynchronous. Now again, I can, for example, console.log the response for you again. And now let me also call this function, so fetch Pokemon. So I'm going to execute it. And you can see this here is the response. Now let me also log response.json for you. Again, this is a promise. So now I can again say that I want to store the result of this promise instead of the variable data, for example. And since this is a promise, we can again await the result. And now we can store the result instead of data. Let me now console.log data for you. And you can see we have the same result that we had previously. So we're getting all of this data right here. The only difference is that This time, every time we expect a promise, we can just use await. And the try catch block will do the error handling for us. So we don't need then and catch. And this here is a lot better and a lot more readable. So that is the modern way to write the exact same. So to work with promises. And again, you should usually always use async and await when working with promises these days. So this here is the modern way. And something that I didn't really explain at this point is what exactly this .json method right here does. So usually, when we're using the fetch method, we're getting back a promise. And in the future, this promise will be resolved or rejected. So by using await, we're saying wait for the response. And once you have the response, store it inside of this response variable. And then we take our response and use response.json, which again creates a promise. And once this promise has been resolved, we store the result instead of data. And the .json method right here that we can call on the promise object essentially will just transform this JSON data, which we're getting right here from the server, into a normal JavaScript object. So .json turns JSON data into a JavaScript object so we can use it instead of JavaScript. And understanding that is really important. So this here is just a normal response that we get from the server, but we cannot really use this response at this point. In order to use this response, so this JSON data, we have to call response.json, which again is first of all a promise. And once response.json is resolved, it will hold the actual data. So we can store this data instead of this data variable, for example. And this data is then the data that we can work with. But just test this out yourself, and I'm sure you'll understand this. And that is all you need to know about async and await. So async and await make promises easier to read. Let's now have another practice project. And now I want you to create a random user generator. So I want you to use an API that creates a random user every time you send a fetch request. And then I want you to send this data or to log this data in the console. So log it and make it look somewhat alright. And that is your task. So feel free to try this on your own. And once you're done, you can come back and take a look at my solution. So let's get started. So first of all, I'm going to go over to Google and I'm going to search for a random user generator API. I'm just going to use the first link. I'm sure there are other ones that you can use as well, but I will use this one. Let me maximize this window. And you can see we now got this person right here. So I'm going to reload the page. We're getting Ellie or Brian. I'm going to reload. We're getting another one, and so on. And now let's scroll down. And right here, you can see how to use. And we can just copy this URL at this point in time, because this here will allow us to get the data from the API. So let me open a new window. I'm going to paste this URL in. And you can see we're getting the data as JSON data. So right here, this is a JSON object, if you want to call it like that. Well, it's actually just JSON data. And inside of those brackets right here, we have result, for example, gender, female, name, and so on. So all of that stuff that we might be interested in. So phone number as well. So all of the things. And now we want to get this data inside of JavaScript. Let me get back to the original view. And now let me create a function to get the random user. So const get random user is equal. Again, let's use an arrow function right here. And we have a try catch block because we're going to call a server. And every time we're going to call a server, so make an API call, there can of course occur an error. And in case we're getting one, I just want to log it for now. Now I also want to fetch data. So I use fetch. And as an input, I will use this URL. We have to await this because this here is an asynchronous request that will take a little bit of time. And now I'm going to store the result inside of a response variable like this. So this is now what we're getting. But since we're using await, we also need to mark this function as asynchronous. And now let me call this function for now. So get random user like so. And I'm just going to console.log the response for now, like so. This is the response. But at this point in time, we cannot really use it. So I'm going to use .json on our response to turn this JSON data into a normal JavaScript object. And then I will store the data inside of the data variable, like so. Let me now console.log the data that we're getting from the server, so from the API. And at the moment, it's a promise. We need to await this here, of course. And now we're getting this result. And now, if we open this object, you can see that we have a couple of key value pairs. We have info, we have results, and so on. And actually, we probably want to get results right here. So I'm going to access the results key, so data.results. And I can do so because this is just a normal object. Now I have this array, and inside of this array, I have a lot of stuff inside of the first cell, essentially. So at index number 0. So let me access this array by using index number 0. And now this is an object once again. And now I could, for example, access the gender, I could access the email, and so on. So let me, for example, try to get email, like so. And this is the email. And now I can, of course, also format this by using backtick characters. Let me go into a new line, like this. And now I can, for example, say email, like this. So email, and email is going to be whatever we have right here, like this. You can see this here is the email that we're getting. Let me just duplicate this line here a couple of times. Let me also try to get gender, for example. If I remember correctly, this here was gender, like so. So now gender is female. Let me remove this white space, like so. And the same right here, like so. And right here, I don't know, maybe there also exists something like name. Let me test this. Otherwise, I have to take a look again. Actually, there does not exist something that is called name. So let me take a look at the array again, like this. And actually, let me just go back and use another console.log statement. And now we're getting this right here again. And maybe I can use something like, maybe the phone number. So .phone. And now we're having the phone number as well. Let me delete this here again. Let's have phone right here. And you can see now this here is formatted properly. And you can see now we essentially got the data from an API. And now we use this data that was inside of an object and displayed it inside of a console.log statement. And this here is essentially just accessing objects and arrays the way we would do usually. I know this here can look a little more confusing if you take a look at it like this, for example. So data, but under the hood, this is just an object. You open this object, and now you see that this object has the keys info and results. So we could access info by using .info, the way we would do usually, but you can also use results like so. And now we can access results. And if you take a look at results, you see that this is just an array and it only has one single element. So only index number 0. How can we access an array? We can access arrays by using the index right here. So again, we're just accessing an array the way we would do usually. And now you can see that this is just an object. How can we access an object? Again, we can just use the dot notation. So we could access, for example, DOP, email, gender, ID, login, name. So I think you get the idea. We can access all of those key value pairs again. And if you would, for example, access name now, so dot name, you will see that name is just another object. So it's essentially an object inside of an object. And now, inside of this object, you could also access .first, for example, or .last, or .title. So all of those properties as well. So this here looks confusing at first, so the data object, but in the end, those are just objects nested within one object, or arrays nested within our main object, so the data object. So in the end, you can just access all of those data points essentially by just using the normal way to access objects and arrays. So that is important to understand. And once you understand this, it becomes a lot less confusing. And that is all you have to do to solve this random user generator project. Let's now understand the strict mode in JavaScript. And strict mode just catches common JavaScript mistakes. Imagine we're having a variable, user for example, and that one is equal to npc. I'm now going to console.log our user like this. And you can see we're seeing npc in the console. But the problem is that this is not really good practice. Usually, when defining a variable, you always want to use the const keyword or the let keyword, like so. But without using const or let, this is not really good. And now we can just say that we want to use strict mode by typing use strict right here. And you can see, once I say use strict, I'm getting an uncaught reference error. User is not defined. So use strict essentially enables strict mode, and the strict mode is just a little bit stricter. So this here will cause an error. Well, under normal circumstances, this here would somehow work, even though it's not really valid to be honest, but it would go through. So the strict mode will essentially throw errors a little bit earlier. And oftentimes you want to do this because this will essentially prevent a lot of problems because you will just catch them a little bit earlier. So right now, I would probably have missed this problem right here without using strict mode. But now that I have strict mode, I know that this here is actually not that good. So I can just add const right here, and now it works. So if you want to catch your mistakes a little bit earlier, you can always use strict mode. Let me now introduce you to the call stack and to the event loop. The call stack runs normal code first, and the event loop runs asynchronous code later. So let me show you what I mean by this. And in order to really understand this, I first of all want to introduce you to two functions, to set interval and to set timeout. We can, for example, use the built-in set timeout function that JavaScript provides. And right here, we can, for example, as a first argument, define a callback function once again. And I can, for example, say console.log 1 second pass, for example, like so. And now right here, after a comma, I can define the timeout. So how many milliseconds should pass up to the point where we execute this code right here. And in our case, let's say 1000 milliseconds, so essentially 1 second. And now you can see, after 1 second, we're getting 1 second passed. I can also use 2000 milliseconds, and now we will get 1 second passed after 2 seconds. So this here should of course be 2 seconds passed. And I think you get the idea. Set timeout just sets a timeout, and after that duration passed essentially, we will execute this line of code right here. And this here is of course asynchronous code, because at runtime, we will not execute this code immediately, but we will run this code and then we will wait for 2 seconds and execute this line of code later. So it's again asynchronous. And set interval is pretty similar. The only difference is that set interval executes something inside of different intervals or specific intervals. So I could say 1 second passed once again, like so. I'm going to define a time of 1000 milliseconds, so 1 second. And now after 1 second, we're getting 1 second passed, 2 seconds passed. So 2 seconds passed is our set timeout function. And now we're getting 1 second passed over and over again. So after every second, set interval will execute this here once again. And both of those functions are asynchronous, because once running this code, essentially, it does not happen immediately. It takes a short time, and then the code runs. So similar to a server call, set timeout and set interval are asynchronous. And that is important to know for the following thing that I want to show you. Because now I already mentioned that code will run from top to bottom. So imagine I have a console.log statement here, and this here says first, for example. Right here, I'm going to say second, and now right below, I'm going to console.log third. So if you remember what I said previously, this here should run first. Then we're going to run this and wait for 2 seconds, and then we should see second in the console, and this here will run last, and we should see third in the console. So let me save this and show you how this really works. And you can see first comes first, third comes second in the console, and second comes last. So why is that? The reason for this is the call stack and the event loop. So it would be kind of bad for a program if you would have to wait for every single timeout. So imagine this here would be 10,000 or 100,000 or 1 million, it doesn't matter. Just imagine this here takes a long time essentially. And sometimes server calls can also take a long time. It would be really bad if the program would literally just stop and wait for this to finish, because then nothing afterwards could happen. And a lot of stuff right here should, for example, happen, especially if this call takes a lot of time. And because of this, we have the call stack that runs normal code first. So this here will get executed immediately, and this here will get executed immediately, and this here will get added to the event loop. And the event loop will always take a look at the events. It will keep them into consideration. And once this here, so once this time passed essentially, it will get back to our program and pass the result to our program. So this here will be passed to our program once the result exists. But before that, we're literally just going to pass this entire thing right here to the event loop. So the call stack can keep going and keep executing whatever we have afterwards. So that is the non-blocking nature of JavaScript. Without this non-blocking nature of JavaScript, we would have to wait for this here for pretty much ever. And that would of course be bad behavior. So the call stack will always run the normal code immediately, and the event loop will handle all of the asynchronous code and then get back with the result and give us the result once the result exists. And we can also see that if we take a look at our fetch request that we did previously. So let's take a look at the Pokemon API once again, for example. Let's just click on this link right here, and let's again copy this one. And now let me go back to the document, and let's now, for example, fetch something once again. So I'm going to have a response, for example. That one is equal to await, fetch. Let's just fetch whatever we have from this URL right here. So await is only valid inside of async functions. So we need to use a function or create a function. We can do so by saying const fetch Pokemon is equal to an asynchronous function. We're going to create that one. We will have a try catch block in here. For catch, I'm going to console.log our error, and right here, I'm going to wait for my response. And now let me just console.log my response, and you can see, I also have to execute this, of course. So now let's execute this function, and you can see we're getting first, we're getting third, and only afterwards we're getting the response. Because again, this here is asynchronous. Calling a server takes a little bit of time, and up to that point, we already finished first and third, and later on, once the result exists, so once this response here exists, we are going to see that in the console. So the event loop will give us that result once it exists. And that is something that is really important. You don't really have to think too much about it because it will happen under the hood anyways, but knowing the principle is kind of important. And that is all you need to know about the call stack, which runs code immediately, and the event loop, which will give us the result once the result is there. Let's now understand hoisting. And hoisting moves declarations to the top before the code runs. Let me show you what I mean by this. Imagine we are creating a function greet user, for example, like this. And this function should just greet a user. Therefore, we can console.log, hey, hope you are doing good, for example, like this. And now, maybe I'm going to call this function right above the declaration. So greet user right here. And you can see this here works. So hey, hope you're doing good. And the reason for this is hoisting, because hoisting essentially moves declarations to the top before the code runs. So under the hood, JavaScript takes this declaration and moves it right here to the top, like so. And therefore, this will work. So to be precise, this here works, because under the hood, it looks like this instead of the real code. And that is all you need to know about hoisting. Let's now understand the temporal dead zone. So as already mentioned, declarations will be moved to the top. So if I'm going to say let age be equal to 28, and I'm going to console.log our age right here, according to Hoisting, this here should work. I'm going to save this, but you can see we're getting an uncaught reference error. Cannot access age before initialization. So this right here is what you call the temporal dead zone. So for variables, they somehow get hoisted, but you cannot really use them before you initialize them. So you shouldn't do it like this. For variables that use let and const, you should always initialize them first and only access them afterwards. So for functions, it's actually kind of alright if you use them before declaring them. But for variables that use let and const, that doesn't work. So understanding the temporal dead zone is also kind of right. But I'm going to be honest, understanding the temporal dead zone and hoisting is kind of alright because now you somehow know a little more about JavaScript. But in the end, I always recommend you to structure your code in a logical way, which means even though you could, for example, declare a function and call it before declaring it, I don't think that it makes too much sense. Usually, you would always declare your function first in a well-written program, in my opinion, and after you essentially declared it, you can call it. So if you write your code like this, I think it's more readable and it's actually also a little more intuitive. So I don't really see why you would want to call this function here before declaring it. But again, understanding how JavaScript works is kind of nice from time to time. Let's now take a look at modules. And modules let us split code into different files. So imagine we want to have one file for maybe math operations, then we want to have one file for maybe greeting the user, and then we maybe want to have another file for, I don't know, calculating the power level of superheroes, for example. So I think you get the idea. You maybe want to code your JavaScript code into different modules and then access one module from another module, for example. So maybe instead of the module where you want to calculate a superhero's power level, you might need some math functions. So you want to access those math functions instead of that module, for example. And let me show you how this works. So imagine we have a math function right here, like calculate sum. We're getting num1 and num2 like this, and we're just going to return num1 plus num2, for example. How can I now access this function right here inside of another module? I can do so by using the export keyword right here. And you can see I'm exporting this function, but I'm also getting this uncaught syntax error, unexpected token export. And the reason for this is that this here, so our index.js file, is currently not a module. In order to declare something as a module, we have to go to our index.html, and right here, we have to declare our script tag as a module. So we have to define this here as a module in general. I can do so by using script module, as you can see, instead of VS Code. And the only difference is that you write here at a type being equal to module, essentially, to the script tag. You should, of course, also have the defer attribute and the source, which is index.js. And now you can see that this warning, or this error, to be precise, is gone, because now we declared this script tag right here, so this file right here, as a module. So if you want to use a JavaScript file as a module, you always have to declare it as a module by using type equals module. Now I can go back to my index.js, exporting this function here works, and now I could import it inside of another JavaScript file, for example. So let me create one. I could say this here is whatever.js, like so. And now let me also include this whatever.js file instead of my index.js by just adding another script tag of type source. This here points to our whatever.js file. I'll again use the defer attribute right here. Let me test whether this works by just console.logging hey. We're getting hey in the console, so this works. And now I need to import the previously exported function from our index.js file. So right here, we exported calculate sum, And now within my whatever.js, I need to import this function, and then I need to access it. I can import a function by using the import keyword. Now instead of those brackets right here, I can define the function name, so calculate sum, and now I need to define the path. So I'm going to import that from, and now I want to get this function right here, so calculate sum from ./index.js. So from our index.js file right here. Let me save this, and you can see again, we get this error right here, cannot use import statement outside a module. So again, let's go to our index.html and let's add type equals module right here. The error is now gone. And let's go back and let me just call calculate sum right here. For num1, I'm going to use 100. For num2, maybe 200. And we're not seeing anything because we of course need to console.log this right here. So console.log calculate sum, and we're now getting 300 in the console. So now we exported this function right here instead of our index module, so instead of this JavaScript module, and we imported it later on instead of our whatever module. And then we can access this in any way we like. And understanding modules when splitting your code in JavaScript can be really important because it allows you to essentially group all of your functions and your functionality, objects, and so on instead of different files. And then you can access one file from another file and have everything logically separated. And especially when you have extremely big projects, for example, or also bigger projects in general, this is a really important concept because it allows you to stay organized while writing organized code that also stays maintainable for a long time. And also for other developers, it's probably a little bit easier if you have one module for math functions, for example, and so on. So I think you get the idea. And that is all you need to know about modules. So to summarize, modules just let us split code across different files and allow us to keep our projects organized. Let me now introduce you to selecting HTML elements, because before we can even do something with any HTML element, we first have to select it. So we have to get a reference essentially to this HTML element instead of JavaScript. So imagine we wanted to modify this h1 right here that, for example, says npc codes. Then we first need to get a reference to this h1 tag right here. We also could want to get a reference to a p tag that maybe has a little bit of placeholder text, like so. So now we have those elements on our website, but we first need to get a reference to these elements instead of JavaScript. And for now, you don't need to completely understand this. It will all make a little more sense during the next lectures, but now just stick with me. So we can select HTML elements by using JavaScript in multiple different ways. We can, for example, use an ID to select a certain HTML element. So this here could, for example, have an ID of heading, and now I could use this ID heading to select this element instead of JavaScript. In order to do so, or in order to select pretty much anything, you will always use the document. Because again, the document holds a reference to our HTML document, and therefore to all of the HTML elements on our page. So I'm going to use document. Now we can, again, since this is an object, call a method on this object, and JavaScript provides the getElement by ID method for us. And now, right here, we can just define within the brackets the ID name essentially. In our case, it's heading, and this will allow us to select an element. Now we can store the selected element, the selected HTML element, inside of a variable. So I could, for example, say that this variable has the name heading. This here can be anything though. That's up to you, but I like to use descriptive names, so heading might fit right here. And now let me console.log heading for you. And don't worry, we will not use the console that long anymore. You will see real effects on the website soon. But for now, let's just take a look at the heading inside of the console. And you can see we're getting this h1 element that we have on our index.html page. So this here is the exact reference to this element right here. We could also get a reference to our paragraph by using an ID. So this one could have an ID of text, for example. And now I can use this ID to get a text reference. So const text is equal to document get element by ID. And now the ID is text, of course, like so. Let me console.log the text for you. And now we also have a reference to our text. Let me delete this and let me just add a comment. So by using get element by ID, you can get a reference by using an ID. You can also get elements by using a class name. So you can get a reference by using class names. So let me for now delete the ID right here on this paragraph. Let me duplicate this paragraph 2 more times. And now we have 3 paragraphs. And let me add a class to this paragraph of text. And now let me just add this class to all of the paragraphs. So right here and right here. And now we have 3 paragraphs who all have the exact same class. And now I can, for example, say const text, for example, is equal. Again, we use the document. And again, we use a document method. So document.get elements, plural this time because we are selecting multiple elements, by class name essentially. Opening and closing brackets, and inside of those brackets, as a string again, so as an argument, we have to pass the class name, the specific class name, like so. And now let me just console.log our texts right here. And you can see we're getting an HTML collection, which is pretty much an array. And now I could, for example, access the first element by using text of 0, text of 1, of 2, and so on. So I think you get the idea. And now I can also loop over this text collection essentially, which is not really an array, but pretty similar. So you cannot do something like map or for each on this text collection, but you can use a normal for loop. So for let text of text essentially, and now we can just console.log the individual text. So this works. Let me also change the text so you see that this in fact works. This is 1, this here will be 2, and this here will be 3, like so. And you can see we're getting 1, 2, and 3. So now we selected all of those elements inside of a collection, which again is pretty similar to an array. So let me delete all of this. And now we can also get a reference to an element by using tag names. Imagine we are using the p tag right here. Let me also remove the class, like so, and like so. So we don't need it anymore. And now let's say we want to get every tag that has a p tag. So p right here. And we can do so by saying document.getElement by tag name. Or to be precise, get elements, like so. Because of course, we can have multiple p tags on our page. And then we, of course, will get them as a collection once again. So again, opening and closing brackets. And this method expects us to enter a tag name instead of quotation marks, so as a string. And in our case, we want to get a p tag or all of the p tags. And now I store them instead of a variable. So maybe paragraphs this time, like so. And now let me just console.log our paragraphs for you. And you can see we're having a collection once again. So once again, I could also just use a for loop. So for let p of paragraphs. And now I'm just going to console.log p, like so. And you see we're getting our paragraphs once again. So all of them right here. So this is how you get a reference by using the tag name. And of course, you could also get a reference to our h1 by using document, get element, or get elements by tag names, like this. And now I could specify h1 and let me console.log h1. I don't even know if this is alright, but it seems to be alright. Of course, this is not the best name, I'm going to be honest. But for now, you see that we again have a collection and we could access our heading by using h1 of 0. So you will always get a collection even if you just have a single element. when using getElements by tag name. So that is important. Now, next up, we can also get them by using a CSS selector. A CSS selector would be a hashtag heading, for example, or for a class, it would be dot heading if we have a class heading, for example. So I think you understand how this works. We are just using CSS selectors inside of JavaScript to select an element. We can do so by using document.querySelector. And now we have query selector and query selector all. And I will explain the difference to you in a second. But let's start by taking a look at query selector. And now I'm going to get hashtag heading. So I use the CSS selector within those brackets right here. And now I'm going to store this within a variable const query heading, for example, like this. And I'm going to console.log query heading. And you can see I have this h1 right here. So this is the h1 that we're getting from our query. So query, and you see this is the query selection right here. And now I can, of course, also use a class, for example. So imagine I have a class right here, like Ayo. Let me just use a random class so I see that this works as well, like this and like this. And now I'm just going to use .ayo, like so. And you can see I'm only getting the first element, so only element number 1. And query selector will just return the first element, and that's essentially it. If I have multiple elements that I want to select, then I have to use query selector all, like this. And this will now again return a node list, which again is similar to a normal array. And now under those circumstances, I would have to loop over this one once again. So for let h1, for example, of query heading console.log h1. And again, h1 is a bad name, but I'm going to do it like this. And now you can see we're again getting all of the individual elements. So query selector, if you only want to get the first matching element, and query selector all, if you want to get all of the elements that match this query essentially. And this here is always a CSS selector. So I could, of course, also use P, and it would get the exact same result because an element selector exists in CSS as well. So this is the normal element selector in CSS. This would be the class selector in CSS. And this here would be the ID selector in CSS. But I think most of you know CSS, so this shouldn't be new to you. And now let me also add right here. So we are getting a reference by using CSS selectors essentially, like this. And you see those are all of the options that we can use to select an HTML element. So to get access to a certain HTML element inside of JavaScript. And now this is really useful because now we can target a specific element on our page, on our index website. And we can, for example, change the style, we can change the text later on. We can manipulate those elements in all forms essentially. And we will also do that very soon. So to summarize, you can get a reference to an element by using a CSS selector. So by either using query selector or query selector all. You can get a reference to an element by using the tag name. So something like h1, p, ul, ol, and so on. You can get a reference by using class names. So whatever class name you define, and this will return a collection, so something that is similar to an array. And you can also get a reference by using an ID. And of course, what exactly you use is to a certain degree personal preference and also depends on the situation. I usually recommend you to use an ID if possible, and especially if you only want to get a single element, or otherwise maybe a class name if you need to get multiple elements. And that is all you need to know about selectors inside of JavaScript. Let's now get to the interesting parts. And let's now understand how we can change or add text content, for example, and inner HTML, which is also pretty much text. But I will show you how this works in a second. So we've already learned how to select specific elements instead of HTML. So now imagine we have a paragraph right here. And that one says hello for now. And at this point, we will also not need the console anymore. So let me make this here a little bit bigger so you can really see this. And let me also make this window right here a little bit smaller. And now imagine we wanted to get this p tag and maybe change the text hello to something else. So I'm going to use an ID, for example, and this ID will be text. Now I have to select this ID inside my JavaScript file, and we can do it the way we did it up to this point. So const text is equal to document.getElement by ID, and the ID was text. So I'm just going to use text right here. So now I have a reference to my text, and now I somehow need to change the text. And I can do so by using text content or inner HTML. So I can use text dot, and again, this here is an object that has properties and methods, because again, pretty much everything in JavaScript is an object. And now I can use text dot text content, which is a property, and I can set this equal, so I can override this property using JavaScript and set it to something else. So I can, for example, say hello guys, like so. I'll end this by using a semicolon, and I'm going to save this. And you can see we're now having hello guys. So this allows me to change the text content. Now I can also use text.innerHTML, so the inner HTML property, to override this text here once again. So I can say, oh wow, for whatever reason. And now we are seeing oh wow right here. Because again, JavaScript executes from top to bottom. So first we get the element, then we override the text by using hello guys, and then we override the text once again by using oh wow. So what is the difference between inner HTML and text content? The difference is that when using inner HTML, you can write normal HTML essentially right here. So I could also turn this here into an H1, and now I can, for example, say hello, and I can end this by using the closing H1 tag. I'm going to save this, and you can see this here is now an H1. If I would do the exact same, instead of text content, I would get this result right here. So let me delete this. Now I would get this result. So text content will essentially just display everything as plain text, whereas inner HTML also allows you to write HTML code. And something that is really important to understand when using inner HTML and text content is that you want to avoid inner HTML whenever possible. And you especially want to avoid inner HTML when you display user content. So imagine, for example, you have an input field of type text, and that one allows the user to, for example, write a comment on your website. You then store this comment inside of your database, and other users are able to load this comment, to see this comment, for example. Like if you think about Instagram, on Instagram, people can write comments and then other people can read those comments. If you now load those comments and use inner HTML to display those comments on your website, one of the users could, for example, write something like this, so hello, like this, and this will now get executed as HTML code if you use inner HTML. So this would have the H1 formatting, which of course would break your entire website. And this is a really simple example. You could also use JavaScript code in HTML because in the end that would work. And that is a lot worse. So using this here is really a security risk if you load user content and display it on your page using inner HTML. So whenever possible, and especially if you load user content, avoid inner HTML. If possible, and usually it is possible, always use text content. So never try to use inner HTML if you can avoid it. You can use inner HTML if you are the one that defines this content and the content is not user generated. So if you, for example, just say text.innerHTML is equal to this right here, this is kind of alright. I would still argue that it's better to use text content. But if this here is content that you get from a database later on, once you start using a database, and you essentially allow users to input something and you just display what the user entered essentially, then you don't want to use this at all, because that is really risky. So the only takeaway is use text content whenever possible, and especially if you have user-generated content like comments, usernames, and so on. just avoid inner HTML at all and use text content instead. So to summarize, text content changes only text, while inner HTML can just insert normal HTML. Let me now introduce you to getAttribute and setAttribute. And getAttribute allows you to read an attribute, and setAttribute changes an attribute. So think about a website where we have an anchor tag, for example. That one has an href attribute, and this one, for example, redirects, let's say, to google.com, for example. So I'm going to copy this link, I'll paste it into the href attribute right here, and instead of the tags, so between opening and closing tag, I will have Google right here. So when a user clicks Google, he will get redirected to the Google page. So this is just normal HTML. And now let's try to get this anchor tag, so this link, by giving it an ID of link, for example. And now we're going to select this one instead of our JavaScript file. So const link is equal to document.getElement by ID. And we want to get the element that has the ID link. So up to this point, everything is normal. And now we can read an attribute by using the getAttribute method. So again, we can access our link, which as always is just a JavaScript object. And now we can access the getAttribute method on this object, like so. And right here, we just have to define what kind of attribute we want to get. For us, this would probably be the href attribute. Now I'm just going to console.log the result of this operation, and I don't have the console at the moment. So let me make this here a little bit bigger, inspect, let me open the console, and right here you can see that we're getting the link. So https google.com/whatever. So I think you get the idea. So this right here is just a link that we entered right here. So by using getAttribute, we are able to get access to an attribute. And now I could, of course, also store the value instead of a variable. So I could just say this here is the actual link. I don't have a better name right now, but you could get or come up with a better one like this. And I could also console.log the actual link like this. And this would actually be the same result. So when you need the link, you can always store it inside of a variable or pretty much any attribute. So I can get access to an attribute by using getAttribute, but now you maybe also want to set an attribute. And in order to do so, we can again access our link object, and now we can just use the setAttribute method right here. And that one expects two parameters. The first one is the qualified name. So essentially, what kind of attribute do we want to set? For us, it's the href attribute, and the second parameter, so the second argument we have to pass, is the actual value. And maybe we want to redirect to, let's go back and let's, for example, search for cameras. So I'm just going to redirect the user to maybe Amazon, this camera website. So let me go over to that website, I'll copy that link, and as the second value, I'll paste it in here essentially. Let me now close the console and let me press this link, and this should now redirect us to Amazon instead of Google. So you can see we're getting redirected to this camera right here on Amazon. So this seems to work. Let me also minimize this here once again, and let me also show you an alternative way. So let me just delete this here for now, like so. Let me press Google again. We're getting redirected to Google now. Let me go back. And now there's also shorthand syntax for setAttribute. So for a lot of attributes, we can just use the object name again. And then you could just say href, for example. And now we can just say that link.href is equal to maybe this link right here that again redirects to Amazon. I'm going to press Google right here, and you can see it again redirects us to Amazon. So for a lot of attributes, or for most attributes to be precise, there exists this shorthand syntax. So for images, when you want to set a source, for example, you could also use image.source to access the source attribute right here. And then you could say that this is equal to whatever source you have. I don't have an image right now, but I think you understand the idea. So to summarize, you can always use getAttribute to read an attribute, and you can always set an attribute by using setAttribute. And most of the times, you can just use the shorthand syntax, which essentially just means you type out the object name, so essentially the object that you got from the HTML page, followed by a dot, and followed by the attribute name. So maybe image.source, link.href, and so on. So I think you get the idea. And that were the most important things you need to know about getAttribute and setAttribute. Let's now take a look at how we can create elements, how we can append elements, and how we can remove elements. To create an element, we use createElement. To append an element, we use append. And to remove an element, we use remove. Let me show you. Imagine we have a div right here. And let's give this div an ID of container, like so. Now we want to get access to this div container instead of JavaScript. So I create a new variable, const container is equal to document.getElement by ID. And we want to get a reference to our container, like this. And now we can create a new element by using createElement. To be precise, we access our document and use the .createElement method of the document object. Let me show you. So for now, let's say document.createElement, like so. And imagine we want to create a new p tag, for example, like this. And now we can store this created element inside of a JavaScript variable. So const text could be equal to document.createElement p. So we are creating this p tag and storing it inside of this text variable. Now we can use text content to give this paragraph, so this text, a little bit of text. So I'm going to say text.text content is equal to hello guys, for example, like this. But now we're not able to see this on our page. Why is that? The reason for this is that we did not add this text right here to our DOM yet. So in order to change that, we have to append this text right here, so this text element, to our document. And now we can, for example, say that we want to add, so append this element to our container. In order to do so, we can say container.append. And now we define the element that we want to append to our container. And a short reminder, the container is just this div right here. And now to this container div, we want to append our text, so our paragraph. I'll save this, and now you can see we're having hello guys. Let me make this a little bit bigger. Let me go to inspect. And now let's take a look at our body. So we have this body, we have this div inside of our body, and inside of this div right here, we have our paragraph. So append essentially takes an element that we define within those brackets and puts it as a child element to the defined element. So in our case, it appends our child, so our text, to this container element, so to our div. And that is how append works. Now, let me minimize this and let me show you how we can use that together with a couple of other things that we've learned up to this point. Imagine we want to create a link, for example. And now I can, for example, say const link is equal to document.createElement, like this. And a link, so a link tag is an anchor tag in HTML. So we will create an anchor tag. And now I can just set the href attribute of this link by using link.href, for example. And this could be equal to a random link. Let me just get Google because it's probably the easiest, like this. And now we also set the href attribute right here. And now we can also add some text right here. So we can say link.text content is equal to go to Google, for example, like this. And now we're not seeing it because we didn't append this link to our document, for example. So let's just say container.append, and I want to append my link element to the container. And now you can see we're getting this link, go to Google. I could also add a target equals underline blank attribute. I'm not entirely sure, but I think we have to use it by using set attribute. So I'm just going to use link.set attribute. I want to set the target attribute, and the value is going to be underline blank. I'm not even sure if there is a shortcut for target, but I don't think so. But again, you can just look it up. Now, I added this attribute as well. I'm going to click on Go to Google, and you can see we opened it in a new tab, and it redirected us to Google. So this here essentially uses all of the stuff that we've learned up to this point. We're getting an element by using the document ID. We're then creating a new element by using .createElement on the document object. We then define an attribute by using the .href property right here. Afterwards, we set the text content by using the .textContent property, and afterwards we use the set attribute method to set the target equals underline blank attribute right here. And then in the end, we append this link to our container element, so to our div. So this is pretty much all we've learned up to this point. So I think this is a good repetition. Now it's also possible to remove elements from a page. So maybe I have a little bit of text inside of this container. So hello guys, for example, but let me delete all of this. And now imagine I want to remove this container from the page. In order to do so, I can just use the remove method. So this is really easy. You just specify the element, so the reference to the element, followed by a dot, and then you call the remove method on this object. And you can see this just removed the element from our document. Let's now understand how to style using JavaScript. So usually when styling, you most of the times use CSS. Imagine we have a div, and that div has an ID box, for example, like this. And now we can, for example, link a style sheet right here. And inside of our style sheet, we could, for example, target our hashtag box element like this. We could give it a width of 50 pixels, a height of 50 pixels, so 50 pixels, and maybe a background of yellow like this. Or let's use yellow-green, because this is a little less annoying, like so. But now we can do the exact same by using JavaScript. So let me just delete this right here, and let me show you how to do it using JavaScript. First of all, of course, we need to get a reference to our box. So we'll just do it the way we've done it up to this point. So const box is equal to document, get element by ID, and we want to get a reference to our box like this. And now we can style elements by accessing the element, so the reference. Now we can use the dot notation to access the style property of the box object, like so. And now we can use another dot, because style again is an object provided by JavaScript. And now we can just use the color property, for example, or the background property, or the width property, like so. Let's access the width property and set this equal to 50 pixels. So 50 pixels. You always define those values inside of quotation marks, like so. Box.style.height could be equal to 50 pixels as well. And now let's also define a background color. So box.style.background, like this. And this could be equal to yellow, for example. And you can see we now have this yellow square right here. This could also be yellow-green, like so. And I think you understand how this works. And something that is important to notice is you can see that the properties, every time you use or access the style object, have a pretty familiar look. So the naming is pretty much the exact same if you compare it to normal CSS. But there is a small difference. If you think about background color inside of CSS, for example, so hashtag box, and now let's use background color, you can see that the naming convention is to use one name and separate it from another name by using a minus. So background minus color. If you take a look at JavaScript though, we use camel case once again. So the first letter is lowercase, so the first letter of the first word, and every new word will start with a capital letter. So background color would be written like this. And this is pretty much all of the time like that. So this here is how it works. Now you can actually take a look at a lot of different properties. So I can also use box.style dot, and by using dot on the style object, you will get a lot of different properties and you will learn them pretty fast, especially if you know CSS. That's no problem at all. So to summarize, you can always add inline CSS essentially by using the selector, so the variable name that you use to select an element, followed by a dot. Then you access the style object of our selected element, and this style object then provides a lot of different properties to apply CSS styling essentially. So I can, for example, access the dot width property to define the width, the dot height property to define the height, and so on. So that is how this works. But now you could also replace an entire class by using the class name property. Let me show you. Let me delete those styles right now. Let me open CSS again, and let me again define something for our box. So width 50 pixels, height 50 pixels, background yellow, green, for example, like so. So now we use CSS to define these styles right here. But now I can essentially replace this by using JavaScript. So by using the class name property. In order to do so, I will again access our box. I will use the dot notation, and now I can use the class name property right here. And I can set this equal to maybe whatever, or from minus JavaScript, like so. So now we added the class from minus JavaScript, and actually at the moment we still have an ID right here. So let me use a class of box for now, like so. And now let me comment this out right here so you really understand how this works. So now we have the class box on our HTML element, and I'm going to target the class box by saying dot box, and you can see now CSS applies those styles to our box. Now I'm going to go back to JavaScript, and once I comment this line out, and we essentially apply box.className to from JavaScript, and actually this didn't change anything because of course we need to get the element, or we're getting the element by using an ID at the moment. So actually I'll just add the ID box as well, but I will only use that ID for selecting the element and not for styling. So now we're essentially adding the CSS style inside of our CSS file, so .box, but you can see that this CSS style has been removed once we added box.className. So .className will essentially remove all of the existing class names. So .box, so this class right here, will be removed, and instead it adds whatever we define right here. So in our case, from minus JavaScript. And now I can add this style to our, or this class to our style sheet, like this. And I could, for example, add the exact same styles, but let me turn this into a blue box. And once I save this, you can see that we now have a blue box, because right here inside of our JavaScript file, we are essentially removing .box, so the .box class from that element, and we're adding from JavaScript to that element, so that class right here. And of course, we can just style this class that we now added to this element by using CSS. So that is completely valid. And now let me show you another important way to essentially add classes, remove classes, or toggle classes. And that is probably one of the most common ways. So imagine we have the box class right here and the ID box. Now, let me go back to our CSS file. Let me delete this for now. And let me go back to our JavaScript file, and let me save this and remove this right here as well. So now we have a box once again. Now I'm going to access the classless property, and now I can again access the add method, like so. And now I can just define any class I want to add right here. So this could be Wayo, for example. Let me now, instead of our style sheet, add a style for the Wayo class. And let me maybe override the width to 100 pixels, for example. And you can see it now takes the width of this class, because of course in CSS, things that come later essentially override things that come earlier if the selector specificity is the exact same. And at this point, we have a class targeting our element and a class targeting our element. So the selector specificity is the exact same, and then the element that comes later inside of the document will override the previous value. But the thing that is important is that our element now has the class box, and it also has the class Wayo. So both of those classes now exist on this element, so on this div right here. We can also remove a class. So I could, for example, say box.classList.remove, and now I could remove the Wayo class like this, and now the style is gone. But I could also remove the box class, and now the entire style is gone. So I think you get how this works. And now I can also use toggle, for example. So let me use box.classList.toggle like so, and let me toggle the box class. And you can see now the box class is back again. And the reason for this is that toggle will add the box class if it does not exist yet, and it will remove the box class if it exists. So if I'm going to remove this line, so if we never remove the box class, it essentially exists. And if the box class exists, toggle will remove it. So now we should remove it. And therefore, this element is now gone. So essentially, toggle just toggles the state. If it exists, it will not exist afterwards anymore. If it doesn't exist, it will exist afterwards. And this is pretty cool if you combine it with buttons later on, for example, because you can toggle essentially the state when clicking a button, for example. So to summarize those ones, you can always access the .classList property, and then you can access the add method to add a certain class, the remove method to remove a certain class, and the toggle method to toggle between states, so between a class. So turn a class on if it's off, or off if it's on. And to summarize all of this, you can always use the style property to add inline styles. You can use the class name property to replace all of the existing classes and add a new one. And you can use the class list property to add, remove, or toggle classes. And that is all you need to know about styling in CSS. Let me now introduce you to one of the most important things in JavaScript, and that are events. An event lets us react to user actions. So what is a user action? A user action is, for example, when the user clicks on a button or clicks on a page or enters something inside of an input field, and so on. So all of those things where the user does something is what you call an event. And you can add events to all kinds of elements, essentially. You can add events to the entire document, to a certain button, to a certain input field, and so on. Let's start by creating a button that has the text click, for example. And let's also add an ID of btn, for example. So now we have this click button right here. And now, instead of JavaScript, we can add an event listener to this button, so we can react to the click event, for example. Let me show you. First of all, we need to get a reference to this button. So let's say const btn, so that is our variable name, is equal to document. And now we get this element by ID, and the element has the ID button like this. So now we have our reference. And now, by using this reference, we can add an event listener to this button. Let me show it to you, and then I will explain it to you. So we use btn dot add event listener. So we will use the add event listener method right here. And now, as the first argument, we have to pass the type of an event. And the type is usually within those quotation marks. So we have a lot of different events: blur, cancel, change, click, and so on. And if you want to remember at least one event, it's definitely the click event. And you will use this event probably 90% of the time. So this is the most important event overall. And now, as a second argument, we can pass a callback function, like so. And when I first started using JavaScript, I never knew why or how I should know what kind of event I should use right here. So this here was really confusing. But in the end, there exist a couple of events that the JavaScript team essentially provided. And the click event is one of them. And you just have to define the name of the event instead of those quotation marks. And you just have to memorize them. So whenever you want to react to a click event, the event name, so the argument that you pass right here, is click. If you want to react to a user input, for example, the event name is input, for example, as far as I know. So yeah, input. And there exist a lot of other events, so maybe mouse down, mouse enter, mouse leave, and so on. So in case you want to use those events, you can always look them up, of course, or you can also remember the ones that you use pretty often. And the click event, again, is probably the most important one. So that one is something that you should probably remember, but you will remember it anyways after using it a couple of times. And this here just says that we're going to react to a click event, and we will do whatever we define right here within this callback function whenever we click this button, essentially. Because to this button, we added the event listener. So what we are saying right here essentially is that to our button element that we selected previously, we want to add an event listener, and this event listener now listens to all of the click events. And every time we click on this button, essentially, we execute whatever we define right here as a callback function. And by default, we can also get the event object right here. So JavaScript will also provide this event right here. And now we can just console.log clicked every time we clicked on this button, for example. So let me just make this a little bit bigger. I'm going to inspect. I'm going to go to the console and I will click. And you can see we're getting clicked in the console. And every time I click, we're adding one clicked right here in the console. And of course, the logic could also be a little more complex. You could add text every time you click on this button. So I could, for example, add a new element to the DOM and so on. So that is up to you. But the important thing is that you can now react to button clicks. So if users click this button, you will just see clicked in the console, or you can do whatever you like. Let's also take a look at the event object, like so. Once I click, we should see this event object in the console, and you can see this is what we're seeing. So we're getting this super big object that has a lot of information. So maybe layer X, layer Y, offset X, offset Y, page X, and so on. So a lot of information, also information about the position on the screen, so on the X position, Y position, and so on. And also the type right here, which is the type click, for example, and the target right here. And especially the target might be important from time to time. You probably want to use it from time to time. It's not that important, but I will show you how it looks like in case you ever want to use it. So I'm going to click it, and you can see this here essentially gives us the target. So this essentially outputs whatever we clicked. And under those circumstances, we of course click the button. And this makes sense if you, for example, want to check if event.target, so if the click button, for example, is equal to an element, for example. And that is something that you will probably understand a little bit better once you start to use React or a JavaScript framework. For now, it might happen that you use it from time to time, but probably not that often. Nevertheless, this here can be helpful. So in general, the event object just gives us a lot of information about the event that happened. And from time to time, you probably want to use it. If you don't want to use the event at all, you can also just get rid of it, and you can just do whatever you like right here. So I could just console.log clicked, for example. And now, instead of just console.logging clicked, I could also target my button, so btn. I could change the style, maybe of the background, like so, and maybe the style is equal to yellow, for example. Now I'm going to click the button, and you can see we now have a background color of yellow. Again, this here looks terrible, but I think you understand the idea. By using an event listener, you can react to events and do or manipulate your page in any way you like. And right here, we are listening to the click event. but there exist a lot of different events. And I will show you some of the most important ones. Always remember, click is probably the most important one, but there exist a couple of others that are probably kind of nice to see. Let's imagine we have an input field of type text, for example, and that one will probably have an ID of username. So maybe we want to get a username. Now I want to get a reference to that username inside of JavaScript. So I'm going to say const username is equal to document get element by ID, and I want to get a reference to my username. So to the element that has an ID of username. Now, again, I can add an event listener to my username. So I'm going to say username dot add event listener. And let me also get rid of the console like so. And now I want to add that event listener. This time, let's, for example, listen to the input element like this. Again, second argument is always a callback function like this. And now let me also get our event. I can also use E for event. And I'm just going to console.log E, for example. I'm going to inspect this once again. So let me just make this a little bit bigger again. Let's take a look at the console. And I'm going to enter something. And every time we enter a value, so a new character, we're getting this event object right here. And now we can also see the value that we entered right here by just accessing our username right here. So username. And now this element has a dot value property that we can use to read the actual value. So, hey, like so. And you can see we're console.logging the value right here. So now this would be kind of useful to track the actual value that a user entered right here. And for example, if the user should enter at least 3 characters, we can, for example, check if the length of our value is at least 3 characters. So we can check if username.input.length, for example, is greater than 3 characters, so at least 4 characters under those circumstances. Then we're going to console.log, okay, like this. And otherwise, we are going to console.log to short, for example, like this. And actually this here needs to be value, of course. So that was my bad. And now let me just enter something again. And you can see we're getting too short, too short, too short. And now that it's long enough, we're getting okay. And of course, this here could also be a little bit better. So I could just use a paragraph right here, for example. And let me give that one an ID of success, for example, and right here I keep it empty. And now I can, for example, try to get a reference to this paragraph. So I can say const success message is equal to document get element by ID. I'm going to get a reference to my success message. Now I could, for example, say that success message dot inner or text content, so that was my bad, is equal to maybe username needs 4 characters like this. And otherwise, so if we have enough characters, I can just say success message dot text content. And now I'm going to say very good, bro, like this. You see, in real time, we can have a success message right here. But again, I need to switch this here. So this here needs to be right here. And this here needs to be right here. So my bad, but now it should work. So I'm going to say age, and we are getting, hey, username needs to be 4 characters. And I'm going to say hello. And once I have 4 characters, we're getting very good, bro. So this would be a possibility to give the user essentially a live updated success or error message. So to give him live feedback on whether his username meets certain criteria or not. So if his username, for example, meets certain standards or not. And you can see this here already feels really interactive. And that is really cool about JavaScript. So now we took a look at the click event and the input event. Let me show you a couple more. There also exists the submit event. So let me create a form, for example, of type post. Instead of this form, let's have an input field of type text, and let's also have a button of type submit, for example, like this. And now I need to get a reference instead of JavaScript to this form, so I'll add an ID of form, for example. I'm going to go over to my index.js. I will just delete everything. I will create a reference, so const form is equal to document get element by ID, and I want to get a reference to my form like this. And now let me add an event listener to this form as well. So form.add event listener, and this time let's react to a submit event. So this event will be automatically triggered once the user essentially submits our form. So this form right here. And now again, I have access to my event object, so event, and we have to pass the callback function right here. So this callback function will again be triggered once the user submits this form. And right here, we can just console.log our event, for example, like this. And now the button needs some text, of course. So submit, for example. Let me go back and I'm going to submit. And you can see we're getting this error right here. And you can see this here is the default behavior of a form. But oftentimes you want to prevent this default behavior of a form. And in order to do so, we can use our event. So something that you do pretty often in JavaScript is adding event.preventDefault. So the prevent default method, because this will prevent the default behavior of a form where it essentially submits the form immediately. Let me paste that in here and let me now submit the form. And you can see the default behavior now is turned off. So by default, usually when submitting a form, it will automatically use whatever we have right here as an action attribute and will essentially try to submit this form to that location. And it will also reload the page. But to prevent this behavior, we can just use event.preventDefault. So this will just prevent the default behavior, so essentially submitting the form automatically when we press the submit button, and also reloading page automatically when submitting the form. And oftentimes you want to define the behavior for your forms yourself. So we'll always start by using event.preventDefault. Right here, you could now, for example, define your own logic. So you could, for example, say when the user submits this form that you, for example, want to add a text somewhere. So maybe you have a paragraph right here that one has an ID of username. And now we can, for example, get a reference to this username. So const username is equal to document get element by ID username like this. And maybe we just want to display the username inside of this username paragraph right here. So now we could just use username dot text content, and let's say this one is equal to whatever we entered inside of this input field. So again, let's give this one an ID of input, and now let's get a reference to our input field as well. So const input is equal to document get element by ID input like this. And now we could, for example, just say that this is equal to input dot value like so and like so, yeah. And now let me test this for you. So we are just going to minimize this. I'm going to enter a username, so maybe npc codes. I will press submit, and right here inside of the paragraph, we are now having npc codes. And I could also reset input.value to an empty string afterwards, like so. So this would be valid as well. I'm going to say npc codes, I submit it, and you can see it also clears our old input.value, so our old value. And right here, we used a lot of the stuff that we learned up to this point. So I can always, or you pretty much always start by getting access to a certain HTML element, and then you use the same concepts over and over again to essentially manipulate your values in the way you like. And this here really becomes repetitive once you did it for a couple of weeks or months, I would say. So you will definitely get used to this, even though it might seem confusing to you at first. And we will also go over this over and over throughout the rest of this course. So I'm certain that you will understand all of this by the end of this course. Let me now introduce you to the next event, And that one might happen from time to time. So maybe you want to react to a key press, for example. And in order to do so, we can, for example, also add an event listener to the entire document. So document dot add event listener. And now we can, for example, react to the key down event. You could also react to key up. And as far as I know, key down essentially reacts once the key is pressed, whereas key up only reacts once you release the key on your keyboard. So the difference is not really that big, but in case you're interested, that is the difference. And now, as a second argument, as always, we just add our callback function right here. And for now, we can just console.log our event, for example, that we also have to accept, of course, like this. And let me inspect this in the console. So console right here. And once I'm going to press a key, essentially, so this one, you can see that we're getting this keyboard event essentially. And that includes a lot of stuff that we could, for example, get. And you can see that we're also getting the key property on this object. So I could, for example, use event.key, so .key to detect the key that I've pressed essentially. And now I'm going to press E, for example. You can see we're getting E in the console, maybe W, X, Y, and so on. So I think you understand how this works. So by using key down, we can essentially react to a key press. And now I want to show you one more event listener that is probably important from time to time, or that you might be interested from time to time. So let's again add an event listener to our entire document. And this time you can already see DOM content loaded. I'm going to add my callback function once again right here. And for now, I'm just going to console.log content has been loaded, for example, like this. I'm going to save this, and you can see it took a short time, and then I'm getting the message content has been loaded, like this. So every time I'm going to save my document, it will take a short time, and once the entire DOM has been loaded, so once everything has been loaded right here, we're getting this content has been loaded message right here. So this will essentially notify us once the entire document, so once this entire page right here has been loaded. And this will allow us to do all kinds of things once content has been loaded, for example. So once the entire page is ready. So right here, we can add stuff, for example, that should only be executed once the entire page has been loaded. So this is also kind of useful from time to time. But again, the most important event is definitely the click event. And probably from time to time, you will also use the input event. There, of course, exist a lot more events, and you can look all of them up if you need to. And in case you ever want to react to a certain user action, I'm pretty certain that there exists an event for that. And if you don't know the event, you can also just ask ChatGPT, and I'm sure that he will tell you pretty much every event that you could possibly need. And that is pretty much all you really need to know about events. So, to summarize, events just let us react to user actions. And especially the click event is important, which allows us to react to user clicks. Let me now introduce you to the local storage in JavaScript. The local storage allows you to store data in the browser. And you have a couple of methods as well that allow you to save data by using setItem, to get data by using getItem, and to remove data by using removeItem. So first of all, what exactly is the local storage? Of course, you can just get a server and therefore store data on a server. So essentially on another computer somewhere else in the world. Can of course be close to you, but can also be in a different country, on a different continent, and so on. So I can of course store data on an external server. But oftentimes you want to store data in the user's browser. So imagine, for example, you have a shopping website. So something like Amazon, maybe a shoe website, a clothing brand, and so on. And the user essentially adds something to his cart. And then he maybe adds a couple of shoes, maybe a couple of trousers, and so on. And maybe he leaves the website and decides to come back later on. If you think about most modern websites, your cart will still be there. So you will still have your shoes and your trousers inside of your cart, even though you essentially left the website and came back later. And that is the local storage, because you use the local storage essentially over there to save the card, so the user's card, in his own browser. And later on, when he decides to come back, you load that data from the local storage, so from the user's local storage, and therefore you still know what he had inside of his card, for example. Another example is the color preference, for example. So when the user decides to select dark mode, for example, you can save that inside of the user's local storage, and every time he visits that website again, you can just take a look at the local storage, and if you save dark mode to the local storage, you can then just select dark mode once again. So if I'm the user, for example, and I would select dark mode right here, I could save that within my own browser right here, or we will code it in a way that we will save it inside of my browser. And later on, when I decide to reload the page, I decide to quit the page and come back, we will just take a look at our local storage once I come back, and then we can load the data from the local storage and adjust our page in a way that fits whatever we have saved in the local storage. But I think it's easier if I just show it to you. So first of all, we can store items inside of the local storage by using setItem. So we can use local storage.setItem like so. And this is a method, and that one expects two arguments. The first one is the key, and the second one is the value. So we could have a key of language, for example. The language could be EN for English, for example. And this would allow us, for example, to store a website's language in the user's browser. So maybe we have a couple of different languages, and the first time the user selects a language like English, German, and so on, you can just save that to the local storage, like so. And now I essentially saved that and therefore stored this key value pair in the local storage, in the user's local storage. So we can now take a look at the local storage by going over to the application tab right here. And now you see a lot of different storages right here. Here you have session storage, extension storage, cookies, and also the local storage. And we need the local storage. So let's go to the local storage. We can expand it right here. This here is our current URL, so our current domain. And if I'm now going to expand this, you can see that we have a key, language, and a value, EN. I could, of course, also store something like dark mode, and this could be true, for example, like this. And now we have the key dark mode, and the value is true. So I can store as many things as you like inside of the local storage. And later on, you can, for example, read the value. And you could, for example, then use an if condition to, for example, do something if the language is English, to do something else if the English is German, and so on. So I think you get the idea. So let me now show you how to get the item. In order to get an item, so an item to get a key value pair, we use local storage dot get item, so the get item method. And right here, we have to define the key. So the key is, for example, language, and this will now give me back the corresponding value. So for us, it should give us value. So I'm going to store this inside of a language variable like so. And let me now console.log the language right here. Let's go back to the console. And you can see we're getting EN because our language in the local storage is currently set to EN. Of course, from time to time, we also want to remove a certain key value pair, and in order to do so, we can use the remove item method. Again, we access local storage like so, and then we just access the remove item method. Right here, we have to define the key once again, and maybe I want to get rid of dark minus mode. I'm going to save this, and you can see we removed dark mode right here. So to summarize, you can store data in the local storage. You can then get the corresponding key value pairs by using getItem. Depending on the result, you can of course use something like an if condition, or you can pretty much do anything you like. So you could check if language is equal to EN, and depending on the result, you could, for example, choose a different website structure or adjust your website any way you like. And in the end, if you want to remove an item, you can also remove an item by using the remove item method. and that is the local storage. But let me now also show you something else. You can also store objects inside of the local storage. So maybe a user object. That's probably not that common, or maybe a card object. And a card object, as already mentioned, might be kind of common. So let's imagine that we have a card right here. Let me also get rid of those lines, we don't need them for now. And we have a shopping cart. And this is an object, and maybe we have Nike shoes, and we have 10 of them, and maybe Adidas like this, and we have 20 of them. So maybe we are pretty rich. And we also have shoes or trousers, 20 for example. So that is our current card. And usually, of course, you would have the exact model and so on, but I don't really know much about shoes, so I keep it like that. And now you can just store that inside of the local storage as well. So we can again use local storage dot set item like so. And now as a key, we could, for example, use card, but as a value, we now have to save JSON data because you cannot store normal JavaScript objects inside of the local storage. And you can also not store arrays inside of the local storage. So we first have to transform this to JSON data. And we've already learned how to do this. We can just use JSON.stringify. And now let's stringify our card object like so. I'm going to save this. And you can see we now have the card and the value is our stringified, so our JSON data right here. Now let me try to get this data once again. So I'm going to say local storage dot get item, and let me get our card like so, and let me store this inside of a new variable, so const local storage card, for example. And for now, let me just console.log the local storage card, and let me also remove this line right here. This is not necessary anymore. And let's go back to the console, and you can see this is our card. But now this is still JSON data. So in order to get back the original object, I'm just going to use JSON.parse, and I'm just going to parse my local storage card. And now we have an object again. So now I could just use this object once the user comes back to my page, and I could just enter or put those items back into the cart. So now the user will feel as if he has never left your page, because the page looks exactly the same as when he left. And by using the local storage, you essentially have a little server on the user's PC, and that can be kind of beneficial from time to time. Of course, you don't use the local storage to store user data, for example, like his register information inside of the browser, but it's good for things like the card, the language, and so on. Sensitive information like a password, of course, doesn't belong into the local storage. Also because a hacker could, for example, get access to the user's local storage. The local storage is not really that secure, and then he would have essentially all of the information. Therefore, local storage is good for things that don't have to be that secure, like maybe card information, language, and stuff that is pretty small in general, so just a little bit of text. But it would be really bad for either big data, so images, or really sensitive information like credit card number, user information, and so on. And that is all you need to know about the local storage in JavaScript. And we've previously already seen that the session storage, if you go over to application, is pretty close to the local storage. So right here, we have the local storage, and right here, we have the session storage. And we can also open the session storage for our page. And at the moment, we have one key, whatever this is, I don't even know about it. And we can later on add a couple more. So first of all, what is the session storage? The session storage only stores data for the current browser tab. So for one session. Once you close this tab, essentially, so once you leave the site, everything will be deleted. And that is the difference to the local storage. The local storage will save your data even after closing this tab right here, for example. And once you come back, the local storage will still be the same. The session storage, on the other hand, will be deleted immediately once you, for example, quit your session. So, for example, close the browser tab. And once you come back, the session storage is essentially gone. So the local storage is a lot more common. You can use the session storage from time to time. But yeah, as already mentioned, it's more rare. So it doesn't happen that often. Something where you could probably use the session storage is if you have a register page and you, for example, want to store the register data, so the data that the user has already entered inside of the session storage. And if you, for example, goes to another tab on your website, so stays in the exact same browser, but maybe goes back to your homepage and then back to the register page, under those circumstances, you could, for example, use a session storage. Because during that session, it will essentially store all of the data. But again, it's not that common. But let me show you how the session storage works anyways. It's actually pretty similar to the normal storage, so to the normal local storage. We can access it by using session storage instead of local storage. And again, we can use setItem to set an item. Again, we need to define a key and a value. So this here could be user email for the key. And let's have an email of npc@gmail.com, for example. I'm going to save this. And you can see it added the key user email and the value npc@gmail.com to our session storage. If I later on want to get that item, I can use session storage dot get item like so. And again, I need to define a key. So I'm going to use my key right here. Of course, I can store this inside of a variable. So const user email is equal to that. And I can console.log the user email like so. Let's take a look at our console again. You can see we're getting the email right here. And now let's go back to our application tab and to the session storage. And right here, I can of course also remove an item. So I can just use session storage.remove item. Again, I need to define the key. So user email. And now I can also just remove our user email right here. So I can use pretty much the exact same syntax. The only difference to the local storage is that you use session storage right here instead of local storage. We can also store objects. So I could also have a user object, for example. So const user, maybe he entered his username. That one is npc. Maybe he entered an email at gmail.com. And maybe, I don't know, you probably wouldn't want to save a password, but let's save the password as well. Hello123, like this. And now we can just store this inside of the session storage. And let me delete this because this would be bad practice, so I'm not going to do this. But you get the idea. So you can just store this now inside of the session storage, the same way we did previously. The only difference is, again, we use session storage dot set item. For the key, we can use user data. And again, we need to turn this to JSON data. So JSON.stringify, and we're going to stringify our user object like this. Now we have the user data stored inside of our session storage. And now I can again get our user data. So const user data is equal to session storage dot get item. And let's get the item that has the key user data like this. Let's take a look at the console like so. I first of all have to log it, of course. So console.log user data. And now this is our user data. And as done previously, we need to convert this to a normal JavaScript object by using json.parse. And let's parse our user data like this. And now we have a normal object again. So we first use stringify to store it inside of the session storage. And then we use json.parse to parse the data when getting it back from the session storage. So I can pretty much store the exact same stuff inside of the session storage. But the difference is that the session storage will be gone once I essentially quit the session. So once I close my browser window, essentially. Whereas the local storage will persist even after closing the browser window. And again, most of the times, the local storage might be the better fit, but there exist situations where you probably want to use the session storage. And that always depends on the situation. So understanding that the local storage persists, whereas the session storage will be gone after every single session, so once you quit your browser, is definitely important. And that is all you need to know about the session storage in JavaScript. Let's now take a look at cookies. And I already want to tell you in advance that you can just take a look at this lecture. It's not that important that you really remember all of this. It's kind of nice if you understand what cookies are, but the rest is not that important for a JavaScript course because you more often use cookies when working with a backend. So when working with something like PHP, for example, because a cookie again allows you to store something in the browser as plain text essentially. So it's somewhat similar to the local storage. But the point about cookies is that you can send them to a server when you send a request to a server. And that is really the purpose of cookies. So cookies are not really there to store information in the user's browser. You could do that technically, but you would usually just use the local storage. So you would much rather use the cookie to store information that is related to your server, for example, and so on. So usually, again, you will send the cookie to a server together with your request, and then the server will do or will use this cookie. But understanding the cookie instead of this JavaScript course can be kinda good already. So let's go to the application tab, and right here we have the cookies tab again, and we can open that and go to the cookies tab for our website. So you can create a new cookie by using document.cookie. So document.cookie is equal. And now you can create a new value, so a new key value pair for your cookie by using something like this. So username equals NPC, for example, like this. And I'm going to save this. And you can see we now have all of those values. Let me make this a little bit bigger and this here as well. And you can see we have a name, so that is the key. So username for us. We have a value, that is the actual value. And right here, we also have domain. We have a path. This here says that this cookie is available or is valid on our entire website, essentially. We also have an expiration date. At the moment, this is set to session expiration, as far as I know, and so on. So you have a lot of stuff right there. You can also set an expiration date by using expires and using a path. But for this course, this is not really that important. All you really have to know is that you can also use a cookie to essentially store key value pairs inside of your browser, and this cookie will be sent together with your requests to a server later on. And that is the real power of cookies. So right here, you don't really have to understand much more. Usually, you will not really touch cookies using JavaScript. If you would now want to get the value of your cookies, you can just access them by using document.cookie. I'm going to console.log them, or I'm going to take a look at my console right here, and you can see we're getting our cookie. I can also set multiple cookies, so maybe let me store my password, which would be terrible, but let me just say password is 123 or MPC123, and now you can see every single string that we save within our cookie will get separated by using a semicolon by default. I could add another one, so maybe biceps, and I have a bicep size of 12 centimeters, and so on. So I think you get the idea. This is what the cookie in the end looks like. So it's just plain text. Let's take a look at our application tab, and you see this is what the key value pairs look like. And if we are going to access the cookie later on, it will look like this. So the individual key value pairs will be separated by using a semicolon. Again, this here is not really that important inside of a JavaScript course. Understanding the basics is important, but we will get to that inside of my PHP course. So for now, just remember that a cookie will be stored inside of the browser, and usually when you work with a server, the cookie will also be sent together with your request to that server. And oftentimes it's, for example, to validate that the current user, for example, has the necessary rights to get the data, for example. But again, that's for my PHP course. Let's now take a look at the window, document, navigator, and location object in JavaScript. And JavaScript provides all of those objects to us. We have already seen the document object. So let me again console.log the document object for you. And you can see this is what it looks like. We've already seen this before, but the document object is just a representation of our entire document. And we can use the document object to, for example, get elements by their ID, for example. So document, get element by ID, and so on. So this is how this works. So to summarize, So the document object is just an object provided by the JavaScript team that allows us to access pretty much every single element and get information about our document in general. So for example, .title, for example. So I think you got this at this point. But there also exists the window object. So let me console.log the window object. And the window represents the browser window. If you take a look at the window object inside of the browser or inside of the console, you can see that it has a lot of properties. And a lot of them will never be touched by you, but something that you might want to use from time to time is, for example, inner width or inner height. If you want to do something depending on the height or the width of your browser window. So this window essentially represents your browser window. And now you could, for example, access inner width like this. And let me just log this in the console and change the value. Let me reload this. And actually I need to change this right here. And I'm going to reload this. And you can see we now have a different width because we changed the width of our browser window right here. So that is how this works, like so. So the window object just gives us a lot of information about our window. Let's go back, like so. Let me make this here a little bit bigger. And now you can also access inner height like this. And I think you understand how this works. Now we also have the navigator. And the navigator gives us information about the browser in general, like so. So this is the navigator object. And you can see we have a lot of stuff right here. We have something like device memory, GPU, geolocation, and so on. And now I can, for example, access navigator.language, for example. And you can see my device browser language is English. So the navigator just allows us to access a lot of information about the browser, to be precise. And now, last, we have the location. And the location, as the name implies, gives us information about the current URL, so the current location we are on our website. This here is the location object, and you can see we have a lot of stuff like href, origin, and so on. So we can, of course, also change the href by using location.href, and we can maybe redirect to a different page, so maybe Google. I'm going to copy that href right here. I'll paste it in here. And once I save this, we should get redirected to Google. I'm going to save this, and you can see it redirects us to Google. So I can use this here for navigation, for example. And in general, the location object gives us information about the current location on our website we are on, essentially. So about our current URL. And those were the most important things about window, document, navigator, and location. So to summarize, the window represents the browser window, the document represents the loaded HTML page, so the document essentially, the navigator gives information about your browser, and the location gives information about the current URL, so your current location. And those are the most important things you need to know about those objects in JavaScript. Let's now take a look at alert, prompt, and confirm. And alert shows a message, prompt also shows a message, but also asks the user for text input, and confirm asks the user for yes or no. So let me minimize the console for this. Let me make this here a little bit smaller. And let's start by taking a look at alert. For example, maybe we want to tell the user that he is dumb, for example. So you are dumb. Like this. Now he has an alert and he can press OK and he cannot do anything else. So that is kind of nice. You can also give him more information about anything else, but that is up to you, of course. We can also use a prompt, are you 18, for example. Now we're asking whether he's 18 or not. Maybe he can say yes or no, whatsoever, like this. Or he can also ask or choose a username. What is your username, like this. And now we can also store the result. So whatever the user enters right here instead of a variable. So const username is equal to this prompt. I'm going to save this. Let's say npc. And let me just console.log our username. So we really see that this works. Let me make this here a little bit bigger. I'm going to press cancel, inspect. Let's go over to the console and let me just reload the page, NPC, and you can see we're getting NPC in the console. So we stored the result of what the user entered inside of our variable username, and then we were logging the username variable inside of the console. So that is how this works. And now let's also take a look at confirm. Let me make this here a little bit smaller. And now we can just ask or confirm, are you 18, like this. And now we can press OK or cancel. And we can, for example, store the result instead of a variable. So is already 18, for example. And let me again console.log is already 18 right here. I'm going to press OK. Let me also take a look at the console. And in the console, we can see that this is true. Let me save this again. Are you 18? I'm going to cancel. And we're getting false. So this right here, so confirm, will return either true or false. And afterwards, we could, for example, do something depending on his reply. So to summarize, alert just shows a normal alert, so a normal message. Prompt allows the user to enter something, and then you can store whatever he entered inside of a variable. And confirm asks the user for either yes or no. And again, you could also store that result in a variable. And that is all you need to know about alert, prompt, and confirm.